What better way to improve your Python and Pygame skills than by building a clone of Stardew Valley? Christian from Clear Code makes amazing Python game tutorials, and in this course he will teach you how to build a clone of this popular game.
In this tutorial, we will create a Stardew Valley style game in Python. And this is going to have a ton of stuff, like farming and foraging. We can cut down trees and trade items. There's also a day and night cycle and different kinds of weather. The entire game was also made in tiled, so you can expand it yourself. Speaking of, I am using the free version of the Sproutland asset pack by Capnooble, which is amazing. There's also a paid version with more stuff if you want to expand the game yourself. Although for this video, you don't need to spend any money. Before I start, I do want to emphasize that this is not a beginner's tutorial. To be able to follow, you will need to have a good understanding of Pygame. If you want an introduction or reminder, I would recommend my introduction to Pygame and my video on using delta time. If you have those two, you should have a really solid foundation. During the video, I will also mention a couple of videos that explain some more advanced topics in detail. Those can be helpful, but you are not going to need them to follow along. Alternatively, I also have a paid course, where you learn all of Pygame by making 4 pretty cool games. Check this one out if you are interested. And sorry about the requirements, but if I did this tutorial from scratch, it would easily be 20 hours long. Finally, the entire project is inside of one folder, and I will be working in the code subfolder. I will explain while coding when and how to access elements in here. I also saved the progress for every chapter, and you can find that on GitHub. And with all of that, I hope you enjoy. Alrighty, so let's get started. And I already have a couple of lines of code ready just to get started. Let's have a look at those. Here I have my code, and I have main.py and I have settings.py. Both already have quite a bit, and I am working in main.py for now. If I execute the code with all of this, I can see a black window that doesn't do anything right now, but we do have a start. And all of the stuff in settings we're going to use later, but well, for now, don't worry about it, besides these 2 lines here. Those determine the width and the height of our window. Now, if you have a very small or very large monitor, you could change these numbers to something else. Whatever is appropriate for you, the rest of the game is going to scale with that. At least within reason, don't make it 5 by 5 pixels, that would be a weird game. And I guess really quick, let's go over what we have. All the way at the top, we are importing Pygame and sys and settings. Pygame should be obvious, but sys we need all the way down here to close the game properly. Other than that, we are not using it. After the imports, we are creating a class called game. Inside of that, we have an init and a run method. Most of the game is going to run inside of the run method. In here, we have the game loop, and this one is checking right now if we are closing the game here, and then we are getting delta time, and we are updating the game. Besides that, in the init method, we are creating a display surface, we are creating a clock, and we are also initiating Pygame. So all things considered, a very simple class. And finally, all the way at the end, we are checking if we are in the main file, then we are creating an object from the class, and then we are calling the run method. And this run method contains the loop that contains our game. So with that, we have the main setup. Although there's one more change that I would like to make, and that is if I run the game again, in the top left, we have a window title. And right now it says Pygame window, which doesn't feel good. So I want to change that one. And this could be a really good exercise for you. What I want you guys to do is to change the title of the window. And if you want to code along, pause the video now and try to figure this one out yourself. After we are creating the display surface, we have to call pygame.display.set_caption. And in there, we can type in the name. In my case, I want to name the game Sprout Land after the asset pack. Although you could name it whatever you want. And if you run all of this now, you can see in the top left, we have Sproutland. This feels much better. Although, granted, a very small change. But, alright, with that, we have our setup. Now, if none of the things I've just talked about make any sense, check out my introduction to Pygame. This one is going to explain all of this in much more detail. And if you are lost already, the rest of the tutorial is just going to get harder. So definitely get ready for it. Now, there is one more thing that we do have to start thinking about, because later on the game is going to become quite complex. And I want to keep the basic main.py as clean as possible. It shouldn't really do too much. As a consequence, inside of this while loop, I want to run another object, and this object actually contains the level. Let me actually implement it, and then you see in a second what I mean. Basically, what I want to do is I want to create a new file, and this one I want to save as level.py. For this level, I want to import Pygame, and from settings, import everything. And this level is going to be a class, so class level. And this class level is going to have one method that I'm going to call run. This one needs self and delta time, because we need delta time available inside of our game to make everything frame rate independent. And inside of this, I want to, for now, just print run game. And this is all we need. In main.py, I want to, from level, import level. And inside of the init method of the class, I want to create an attribute level that is going to be the level. And now, inside of my run method of the game, before I update the display, I want self.level.run. That way, we are always calling this run method here. Although, don't forget, this one needs delta time, the one we have gotten here. If you don't know what delta time is, it's a bit more technical, but I've made a whole video on it, so check this one out. You basically are going to need it to follow along for this video. So, well, it is getting quite complex. Unfortunately, there's no way around it. If I run all of this now, we can see run game in the bottom left. So we are continuously updating this method here, and this means we can run the entire game inside of it, which is helping considerably to keep the entire game clean and organized. And for a project of this size, this is really important. Now, before I'm finishing this section, there are a couple more things that I do want to do. First of all, when we are creating this class, I want to run a dunder init method. And in here, first of all, I want to create another attribute for the display surface. And this one I'm getting with pygame.display.get_surface. This display surface is the same as this self.screen here. And this allows the level to draw straight on the main display that we are going to display to the player, which makes organizing the entire thing much easier. And let me add comments here to make all of this a bit easier to follow. Let's call it get the display surface. Now, besides that, we need sprite groups. And for now, I just want to create one attribute that I call all sprites. And this is going to be pygame.sprite.group. Groups are a key feature of Pygame, and they help us to draw and update any kind of sprite in the game. And sprites is what you use to basically do anything in Pygame. So our player is going to be a sprite. Any kind of tree or plant is going to be a sprite. And none of this works without a group. In my case, what I want to do inside of run, I first of all want self.displaySurface.fill with a black color, so we don't accidentally see the previous frame. After that, I want self.allsprites.draw. And in here, we need the surface we want to draw on. And in my case, I want to draw on the display surface, meaning this is what we have to pass in here. I can just copy it and paste it in here. And besides that, I also want self.allsprites.update. Now, this method we are not going to use for now, but later on, this is what updates all of the sprites inside of it, like the player, for example. But now, back in main.py, I can run all of this, and we cannot see any change. And that is because we haven't really made any changes to the logic of the game. Although if you want to see something, you could change this black to something like red. And now we have a red background. Although I want to keep this black. And there we go. So with that, we have a basic setup. So let's get started with the player. Now the player is going to become quite complex. So I'm going to do all of this over multiple steps. But we do have to get started somewhere, so let's create a really basic player. Here we are back in the code, and for the player, I want to have a separate Python file. Meaning I'm going to create a new one and save it as player.py. Just as before, we have to import Pygame, and also from settings, import everything. Once we have that, I want to create a class player. And this one needs to inherit from pygame.sprite.sprite because it is going to be a sprite. In here, we need a dunder init method, and this one eventually is going to have a lot of parameters. Although for now, all I want is self, then I want a position, and then I want the group the sprite is supposed to be part of. And the first thing we have to do inside of the init method is called super and dunder init. And in here, we have to pass in the group. That way, as soon as we are creating an instance of this class, the object is going to be inside of this group, which is super handy. Besides that, we will need self.image. This is what the sprite is going to look like. And this needs to be some kind of surface. Now, later on, we're going to import a lot of surfaces. But for now, we don't really have that available. As a consequence, I'm going to create a plain surface. And this I get with pygame.surface. This one is going to need a width and a height. And the numbers here don't matter since we are going to change them anyway, but let me go with 64 by 32. Now, this image right now is going to be completely black. And since we are putting this on another black surface, as we can see in the level, we are not going to see anything. To change that, I want to fill the image with a color, let's go with green. Finally, we are going to need a self.rectangle. And this one will take care of the position. This rectangle we create with self.image.get_rect. And in here, as the argument, we have to pass in where we want to place it. And I want to place the center of this rectangle wherever the position is. And this position we are getting from the parameters. With that, we have a very simple player sprite class. Now we just have to use it. And this is going to happen inside of level. In here, I want from player import player. To keep everything organized, inside of the level, I want to create a setup method. This one needs self as always. And in here, we are going to create an attribute called self.player. And this is going to be an instance of the class player. The player we have created here. And this player is going to need two arguments, the position and the group. So let me copy both of them and paste them in here. For now, the position is going to be completely random, but we are going to need a tuple with an X and a Y position. In my case, let's go with 640 and 360, the middle of the screen. Besides that, we need a group, and the group here is self.allSprites. The group we have created earlier on, and now we're just passing it in here. We are nearly done. The last thing that we have to do is to actually call the setup method. And this happens inside of the init method, so in here, self.setup. And now we should be able to see something. So back in main.py, I'm going to run my code, and we can see we have a green thing. Although I realized I confused the width and the height. So back in my player, this should be 32 for the width and 64 for the height. That is looking much better. So now we can see something, but we cannot interact with anything, which means inside of the player, I want to get some kind of input. And don't forget self, that one is really important. Now, to get all of the available keys that are being pressed, we need pygame.key.get_pressed. This one is returning a list with all of the keys that are potentially being pressed. And this I want to save in a variable, let me call it keys. And this list I can access with, for example, via keys and then square brackets. And now Pygame has a couple of predefined names. For example, for the up arrow, we need k up. And if that is the case, for now, let me just print up. All that is left to do now is to figure out when to call this input method here. And for that, we will need an update method that needs self and delta time. How this is going to work is, inside of level, we have our allSprites group, and this allSprites group has a draw and an update method. The update method is the really important part right now, because this one calls the update method on all of the children. Meaning, effectively, what is going to happen is that this update method here calls this update method. As a consequence, for the level, or the group more specifically, we have to pass in delta time as well. The delta time we get from the parameters here, and this delta time we get all the way at the beginning inside of main. In just a bit, this is actually going to become useful. But now, inside of the player, all we have to do is call self.input, and this should be working. So now, if I go back to my main.py, run all of this, and now if I press up, in the bottom left, you can see up, which means I get some input. All we have to do now is to cover the other directions, and then we should be good to go. And the usual system works like this. If we're not pressing up, then I want to check if keys and pygame.k_down, so we are pressing the down button, and if that is the case, I want to print down for now. And with that, we have up and down. Besides that, let me copy all of this. I also want to check for right, and I want to check for left. And then obviously the text has to be right, and it should be left. And with that, if I run main.py, we get left, right, up and down, all of the 4 directions. What we now have to figure out is how to translate all of this into actual movement. And for that, we need a few more attributes. Let me put it all the way in the init method with a comment. Let's call it movement attributes. And the ones before, let's call them general setup. For the movement, I want to have, first of all, self.direction. And this is going to be a vector. So pygame.math.vector2, and this vector is going to have an x and a y part, depending in which way the player should move. So for example, if x is 1, then the player should move to the right. And by default, this vector 2 is supposed to be empty. So it should have 0 and 0. And this is the default value, so I can just leave it like this. And all that we are going to do inside of here is change this direction. So basically inside of keys for up, I want to set self.direction.y to -1. This I can now copy and do it for down. This one is just going to be 1. For right, we are targeting x, and this one is going to be +1, and left is going to be x being -1. And with that, we have the 4 different directions. Although now we do have a problem. And let me isolate the vertical directions, just to illustrate what the problem here is right now. Later on, we are moving the player in whatever this direction is pointing at. So for example, if y is -1, we want to move up. And this is what we are getting in here. The problem is, in this setup right now, once we press up once, direction.y is always going to be -1, even if we release the button. And this is obviously not great, because once we move up once, the player never stops moving up, which, well, we have to change. This, fortunately, though, is very easy to change, because all we have to do is add another else statement, and let me copy the direction here, because now the direction should be 0. Which means now, if we're pressing up, the direction.y is -1, if we are pressing down, direction is +1, and if we're pressing neither, then direction.y is 0. So we're not moving in the vertical axis at all. And that is all we need here. So I can remove the white space, and for the horizontal axis, I have to do the same thing. So in here, self.direction.x is going to be 0. And with that, we have our basic direction. What I can do now, at the end of all of this, I can print self.direction, and now in main.py, if I run all of this, and I can have the different directions inside of my vector. This is working really well. There are 2 more attributes that we need to make all of this work. The first one I always call self.pos, and this is also going to be a vector. So let me copy this one here, and now we have another vector. Now, if you are familiar with Pygame, you probably always store the position inside of the rectangle. However, the problem with this approach is that a rectangle always stores the position as an integer. But if we want to use delta time, so this one here, to move everything in a frame rate independent way, we are very often getting floating point values, which wouldn't work here at all. As a consequence, I'm going to store the position inside of a vector, and this is going to be what self.pos is for. And this is also what we are going to move. And then at the end, we are going to update the rectangle depending on where the position is. All of that is going to make much more sense later on. But for now, for the starting position of self.pos, I want self.rect.center. Finally, I want self.speed. And this is just going to be how fast the player is. I put this at 200, but just choose whatever you think looks good. And with that, I can get rid of this print statement here and add another function, or well, method. And this one is going to be move. In here, we need self and delta time. And essentially what I want to do in here, I want to move my self.pos. And how I want to move it is by getting my self.direction multiplied by self.speed multiplied by delta time. And after I have done that, I want to set self.rect.center to self.pos. And now, after the input, if I call self.move with delta time, we should be having a moving player. So let's try and run main.py, and I can move around. This is working really well. And this is also frame rate independent. And this is why this entire system is really important by using delta time. Again, check out my video on it if you want more detail. It does get a bit more technical. But if you didn't do this and change the frame rate, for example, in this self.clock.tick, you could set the frame rate, for example, with 60. Or you could set 1000, or you could set 10. With this setup, the frame rate doesn't matter. But if you didn't do it, then the movement would be faster or slower depending on how high the frame rate is, which would be a massive problem. All right, in this case, we have our basic movement. Now, there's one more important thing that we have to do, and that is inside of this move method. If I run the code again, if I move left and right or up and down, I have 1 speed. However, if I move in the diagonal direction, like this, the player moves noticeably faster, and that is a problem. You can see it pretty well here. Now, why is that happening? And let me draw on the screen to explain. If the player is only moving in one direction, let's say the player is moving to the right, like this, at a speed of 1. That's not the actual speed, but 1 is a very simple number to use. And if we only move up, we are also going to have a speed of 1. This is what we're getting from direction. The problem now is, if we're combining these two numbers, we are getting a different kind of length. So let me rearrange the drawing a tiny bit, and let's say I want to move by 1 unit to the right and by 1 unit up. Then the actual distance I am going to move is going to look like this. And the distance of this length here is what we are getting from Pythagoras' theorem. It is 1 square plus 1 square, and then we are taking the square root of all of this. The result in this case would be something like 1.4. And this result means that if we move diagonally, the player would move about 40% faster than if we just move left or right or up or down. Which obviously is going to be a problem, so we have to adjust for that. And the way you adjust for that is called normalizing a vector. And normalizing a vector basically just means that, well, we're making sure the direction of the vector is always 1. And this is an inbuilt function into Pygame, so you don't have to think about it too much. All we have to do is get self.direction, and we have to assign it to self.direction.normalize. Don't forget to call it, and we are nearly done. The last problem we have is that we can only normalize a vector if the vector has a length. And this should make sense. I guess to illustrate what this one is doing is, let's say we have a vector of 1 and 1. What normalize would now do is convert these two numbers so that the vector overall has a length of 1, which in this case would get us the numbers something like 0.7 and 0.7. I can actually demonstrate this a bit better. So let me print the vector after we are normalizing it. So now I want to print self.direction and run all of this again. And we are already getting an error that we cannot normalize a vector with the length of 0. And this should make sense. For normalize to work, Pygame needs to know in what direction the vector is pointing. But if the vector is 0 and 0, it doesn't point in any direction. So normalize wouldn't work. But this we can fix quite easily. All we have to do is check if the vector has any kind of length. And this we get with self.direction.magnitude. Don't forget to call it. And if this is greater than 0, only then do we want to do all of this. And now let's try it again. If I move left and right, we have a direction of 1. If I move up and down, it is 1 as well. But now if I move diagonally, it's 0.7 or negative 0.7. And this is important to keep the speed constant. And all right, I hope that makes sense. There is just one more thing that I want to do before we finish off this part. And that is later on, I have to work with these two lines more to implement the collision mechanics. And for that, I have to separate these two lines into the horizontal movement and into the vertical movement. So first of all, I don't want to update the entire position vector. I only want to update for the horizontal part the x dimension. So for example, instead of updating position by itself, I only want to update x. And as a consequence, we have to update the other vector as well and update the rectangle too. And this could be a really good exercise for you to finish off this section. So if you want to code along, pause the video now and try to update the vector and the rectangle. And see how far you get. For position.x, we don't want to get the entire direction vector. Instead, I only want to get x of the direction. Self.speed and delta time can remain the same. Then for the rectangle, I don't want to set the center. I want to set the center x. And then this should be self.pos.x. And with that, we have the horizontal movement. Now I have to copy all of this, give me some white space and paste it in here. And now I basically have to switch all of these x's to a y. And there we go. The result in terms of if I run main.py again, we are not going to see a difference. But later on for the collision, we do want to have control over the horizontal and the vertical movement individually. But this I will talk about in much more detail later on. For now, we have a pretty solid setup. In this section, we're going to import the player graphics. And there's quite a lot of stuff that we have to import. Let me actually open the folder. Here we go. And inside of graphics, we have the character. And in here, we have all of the different animations. For example, down is a down movement. And here we have the player walking down. And well, we have to import all of these different animations. Now, you could do all of this by hand, and it would be possible, but not really practical because there are way too many animations. Fortunately, you don't have to. You can do all of this with Python to automate the entire process. So let's have a look at all of this. Here we are back in the code, and I want to work inside of the player. And let me minimize all of the methods so things are a bit easier to read. For the import, I want to add another method. Let's call it import assets. This one needs self and nothing else. And inside of here, I basically want to create a dictionary called self.animations. And this dictionary is going to have a ton of key value pairs. For example, one key would be up, and this would be up walking. And then the value associated with this key would be a list with a bunch of surfaces that correspond to the up movement. Now, for that, this is something you do have to copy from the notes. This is looking like this. Here are all of the different states the player could be having. We have up, down, left, and right. These are the movement ones. Then we have all of those with idle, then with the hoe, the axe, and the water. These are all of the animations. And these also correspond, if I open the folder again, here we have all of the different states. And the folder name corresponds with the key of this dictionary. So we have down here and we have down here. This is really important. Because what this allows us to do is I can do for animation in self.animations.ease. Don't forget to call it. And in here, first of all, I'm going to need a full path. And the full path is basically, I have to go up one folder, then I have to go to graphics, and then I have to go to character. And don't forget another /. And then I have to add the animation, because the animation name is also the folder name. Let me demonstrate what this means. Here is the file setup again. And right now we are working inside of the player. And from there, we have to go up one folder to the project. Then we go to graphics, then we go to character. And now we have to select all of these different folders, which is what we are doing with this line here, along with the for loop. And now essentially all I want to do is get my self.animations dictionary, target one of the key value pairs. And then I have to actually import all of the surfaces. Now this I'm going to do in a separate folder that I called import folder. And this one is going to need the full path so it knows what to import. And this import folder I generally put in a separate file because it's quite a handy one to reuse. So let me create a new file that I want to save as support.py. And in here we need a function called import folder. And this one needs a path as a parameter, but nothing else. And this is what the player, so inside of the player, I want from support, import, everything. So now we have to create this file here. And let me add a bit of white space. And now we can work on it. First of all, I want to create what I always call a surface list. And this by default is going to be empty. And in here, we're going to store all of the surfaces, and this is also what we are going to return at the end of this function. So now we just have to figure out how to actually access the folder. And for that, we need a specific module. This we have to import, but it comes with Python. We need from OS import walk. And walk allows you to walk through different folders. Let me actually demonstrate what it does. So for, let's call it folder in walk, and then we have to pass in the path. And that is the path we are getting from the parameters, and we're just passing it through. And I guess in here, let me just print what we get. The folder. And now, since we're calling this inside of the player, we just need to make sure inside of the init method, all the way at the beginning, this is really important, I want to self.import assets. And this has to be all the way at the top of the init method, because later on, when we create the image, we need this self animations dictionary. But now, if I run out of this, we are getting a ton of different things at the bottom. And this is what walk does. It basically returns a list with all of the contents of the folder. For example, the first folder here is the up folder. This one doesn't have any subfolders, and inside of this folder, we have a couple of files. They're always called 0, 1, 2, and 3. They all have the same name, but they are different files. And this is what we want to use to import things. Now, keep in mind, a really important thing here is that all of these are just names. We're not actually importing anything for Pygame. We are just going through a folder and looking at all of the file names. But this is something we can definitely work with. Now, first of all, since this walk is returning a couple of things that we don't need, we can unpack this quite a bit. So the first one we get is the folder name. The second thing we get is a list of subfolders. And the final thing we get is the actual content. Let's call it image files. Now, folder name and subfolder, I just do not care about. So I'm going to replace the folder name and the subfolder to underscores. That way I indicate that I don't care about them. So now let me print the image files and let's run main.py again. And now all I get is a list with names of images. And this is what I really care about. Once I have that, I need another for loop. Because remember, image files is another list. So I need for, let's call it image in img files. And now let's keep on printing things. If I now print the image and run this again, I am always getting the name of the image for each file. Now, this right now is a bit confusing because the name of each individual image is fairly repetitive, but these are all different files in different folders. So all we have to do now is to convert all of this into a full path. So now I have to do 3 things to finish off this function. First of all, I need a full path. And this full path is going to be the path we already have. That's a path to the folder. And then we have to attach the name of the image itself. After we have that, I can create an image surface. So this is the inbuilt Pygame surface that we actually want to create. And once we have that surface, I want to get my surface list and append, wow, that is misspelled. I want to append the image surface, meaning we have to get the full path and the image surface. And this, I think, could be a really good exercise for you. Try to combine the path to the folder and the image to get the full path. And then for the image surface, you have to import Pygame and then use the full path to import one specific surface. So pause the video now and try to figure this one out yourself. Righty, for the full path, I want to get the path itself, and this is getting me my folder. And to that, I want to add the image. Remember, the image is just the name of the file, not the actual image. Now, this would almost work. Let me actually comment out these other 2 lines, and let me print the full path. You might already guess what the problem with this here is. If I run this, we have the name of the folder. Let me do this all the way at the top. So up here, for example, is the name of the folder, and then 0.png is the name of the file. This is a really good start, but we do need a slash to separate the two. Meaning in here, besides the image, we have to add a slash. And now, if I run this again, we have the whole path towards this one specific image. So I can remove the print statement, and now I can actually use this full path to import an image as a surface. Now for that to work, obviously I need Pygame. And what I want to do in here is pygame.image.load, and now I need the full path. Although important here, you also have to add convert alpha. That way we are converting this image to something that's easier to work with in Pygame. As a consequence, our code is going to run much faster. Now I can uncomment the append line and we should be good to go. Back in my player. After I've run this for loop, I want to print self.animations. And let's see what we get. That is looking pretty good. We are getting a dictionary with a key and a ton of surfaces as the values. Now, we don't know what each individual surface looks like, but I'm pretty confident that this is going to work. All we have to do now, if I minimize this method here, is when we are creating the image, I have to pick one of these surfaces. Now, for that, we need a few more attributes to make all of this work efficiently. And the way I approach this is I add two more attributes. The first is self.status. And this could, for example, be up, or it could be down, or it could be something like down X, if you want the downwards X animation. But for now, let's keep to down. Actually, down idle is a good one, I suppose. Besides that, we need what I call the frame index. And this by default is going to be 0. Now, the frame index is going to make much more sense once we are doing the animations in the next bit. For now, don't worry too much about it. How we are going to use all of this is, instead of creating a plain surface, I want to get myself.animations. This is a dictionary with key value pairs where each key is going to be accessed via the status. Meaning, inside of this, I want to access the key value pairs with self.status. And this list I am accessing with self.frameIndex. And now I can get rid of the image fill, and we should be seeing the player. Let's try. And there we go. We have one frame of the player. Now, since we don't have animations yet, this doesn't look too impressive. But, well, what you can do now, for example, this could be down X. And let's try this one. There we have the first frame of the X animation. This could also be, let's say, left water. And then we get this kind of animation here. Or well, it's not an animation, it's just a surface. But we do have a very good start. In this section, we are going to animate the player. Now, for that, we are going to need quite a bit of logic. So let's go through it one by one. Here we are back in the code, and I want to keep on working in the player. Now, for the animations to work, there are two things we need. First of all, inside of the self.animations dictionary, we have to go through the list of surfaces because they are the animation. And this is actually a fairly simple method. This we can start with in just a second. The much more complicated bit is getting the self.status. So we have to know if the player is moving or idling or using the X or the water or the hoe. And this is going to determine what animations we need. Getting the status is quite a bit more complicated. But let's start with the actual animation. That one is actually quite simple. I first of all have to create another method. Let's call it animate. This one needs self and it also needs delta time. And basically what I want to do in here, I want to get my self.frameIndex and increase it. In my case, I went with 4 multiplied by delta time. And then after that, I'm going to get my self.image. So what the sprite actually looks like. And I set this to self.animations. I get my self.status. And then I get my frame index. The way you have to think about it, let me open the folder again. And let's say for down. Inside of down, we have 4 different images, 0, 1, 2, and 3. And we are using self.frameIndex to go through them. So we have first 0, then 1, then 2, and then 3. And all I am really doing is I am increasing self.frameIndex to pick up all of these numbers. That's literally all that's happening here. However, there are 2 major problems here. Number 1 is that we can only ever take the index with an integer. But this operation here is going to return a floating point number. As a consequence, this self.frameIndex has to be converted to an integer, which is very easily done. Besides that, the other problem is that each animation has a finite amount of frames. For example, down has 4 frames inside. However, this line here is going to be very quickly on a higher number than 4. So we have to make sure that we are always looping through this. And this we are doing in an if statement. If self.frameIndex is greater or equal than the length of self.animations. And in here, once again, I need self.status. If that is the case, I want to set self.frameIndex back to 0. So what this one does, if I open the folder again, and let me try to get everything on the screen. Something like this looks good. We are basically starting with self.frameIndex being 0, which is getting us this first image here. After that, we are increasing the frame index by a certain number. And then down here, we are getting the integer of that number. So at some point, this is going to be 1, this is going to be 2, and this is going to be 3. After that, we're going to end up with a number larger than 3. So we are going to be somewhere down here, which would be causing an error. And for that, we have this line here. This one is making sure that this doesn't happen. And instead, we're moving back to 0. And with that, we have proper animations. All that's left to do now is to actually call it. So inside of update, all the way at the end, I want self.animate. Don't forget to pass in delta time in here. And now, if I run this, now the watering animation isn't great, but the animation for down does look much better. So here we go. This is down movement. If I just move down, this is already looking pretty good. And what I actually want to start with is down idle. If I run this now, there we go. We have the player idling and looking straight at us. This is looking really good. So this was the easy bit. Now we have animations. The one thing we now have to figure out is how to set this self.status to capture all of the different animation states. And there are quite a few different states we have to account for. All of these. The really easy ones we can get in input. Because in here, if we are, for example, pressing up, we know that the player is moving up. Which means in this, we can set self.status to something like up. Then I can copy this and change this to down, copy it again, and change it to right, and copy it one more time, and change it to left. And with that, we already have the walking directions. So now, if I start all of this, I can move left, right, up, and down. And we already have some very basic animations that look pretty good. Really good start. Besides that, let me minimize input. I want to check if the player is idling. So if we go, for example, from moving up and we stop moving, then I want to switch to up idle, which in practice means I have to add _idle to the status of the player. And to do all of that, I want to create another method. Let's put it below input. In here, I want to get status. Needs self and nothing else. And in here, I want to check if the player is not moving. Then I want to add underscore idle to the status. And again, if you want to code along, this could be a really good exercise for you. So try to figure this one out yourself and see how far you get. If you want a tip, this should be doable in 2 lines of code. First of all, we have to figure out if the player is moving or not. And this we have actually already done. This happened inside of move. Because we know if self.direction.magnitude, so the length of the direction vector, if that is 0, we are not moving. So I can just copy it, minimize the move method, and now if the magnitude is equal to 0, then I know the player is not going to move, which is covering the first bit. Let me put it at the top here. Besides that, I have to add underscore idle to the status, which in a very simplified way would just be self.status plus equal underscore idle. And don't forget, this is supposed to be a string. All we are really doing for the status here is we are manipulating different strings to represent the status of the player. That's literally all it is. Now, this is a good start, but it would cause a problem really quick. Let me actually demonstrate. So after I'm getting the input and before I am moving or animating, I want to get self.getStatus. And now, if I run main.py, we're getting an error that we have a key down, idle, and idle. And basically what happened here is that if the player is not moving, Python keeps on adding underscore idle towards the status. We're not stopping at 1, we're adding more and more. And that way we are getting an error. So we have to make sure that we only ever have a single underscore idle in the status, which we can get very easily. All we need is self.status.split. And I want to split wherever we have an underscore and then pick the index 0. This one here is going to return a list, and the first item of this list is always going to be the status. So this would be up, down, left, right, and so on. And only to that, I want to add the underscore idle. That way, we will only ever have a single idle inside of any kind of status. And this I want to assign, I don't want to add it to the status. And now, the player is idling, and if I move downwards, we are walking. This also works with up, it works with left, it works with right, and this is looking really good. So now we have some basic animations that are definitely improving already. So let me get rid of the comments here, and we have the first bit covered. The other bit we need is the tool use. I guess let me add general comments here to make this a bit easier to follow. Let's call this the movement. Actually, the idle is better. Now, for the tool use, the code is getting quite a bit more complex because besides getStatus, we also have to add the input and we have to be able to select different kinds of tools. So let's do all of this in a separate section. So let's work on the tools. For this to work, we need a few parts that interconnect quite a bit. So, well, let's jump right in and let's have a look at all of this. Once again, here I have main.py and I want to keep on working inside of player. And specifically, I want to work inside of the init method. And in here, I want to add another section. Let me call this one tools. And for now, I want to add one more attribute that I call selected tool. And this could, for example, be an axe, it could be a hoe, or it could be water, short for watering can. I guess for now, let's stick with the axe. That one is really easy to see. And for now, we don't have any way in the game to change the tool. That's going to be in the next section because I do want to keep things a bit more organized. But, well, now that we have the selected tool, I want to go to my input, and in here, besides the directions, let me actually add a comment, directions. I want to add another section, and let me call this one tool use. And in here, first of all, I want to check if we are pressing a certain key, which I get with if keys, and then Pygame dot. In my case, for the tool, I have k space. Now, basically, what I want to do in here is if this condition is true, I want to run a timer for the tool use. So for example, if the player is pressing space, then we should have half a second of tool use being activated in some sort of timer. And if the timer is active inside of getStatus, we are always adding _x to the status. Now, for that, we need a timer. And this is not inbuilt into Pygame, so we have to make it ourselves. And this I'm doing in a separate file. And this one I want to save as timer.py. In here, as always, we have to import Pygame. After we have that, I want to create a class timer. And this one needs a dunder_init method. In here we need self, we need a duration, and then we need a function that by default is going to be none. The duration should make sense. This one is really simple. It's just how long the timer is going to be. The function is going to be if we want to execute some code once the timer has run out. Something we are going to see in just a second, but for now, don't worry too much about it. Inside of this, I want to create some attributes. So duration is going to be duration, and self.func is going to be func. So we're just capturing the parameters. Besides that, I want to have two more. I want to have self.start_time. This one is 0. And then I want to have self.active. And this, by default, is going to be false. And for this timer, we have a couple of methods. We have activate, we have deactivate, and we have update. And all three will need self, but no other parameter besides that. And let me go through how the timer is going to work. We always start at some kind of start time, 0 by default, and this is what we are getting here. After we have declared that, we will continuously check the time, which means we're checking the time here, 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 and so on, continuously throughout. And besides that, we also have a duration. And the duration could, for example, be, let me put it here, at 300 milliseconds. And now all we are really going to do is we are continuously checking if these red dots are before or after the 300. Meaning once that is the case, we want to run some code. So let's implement that. First of all, for activate, this one is very simple. All I want to do in here is if the timer is active, I want to set active to true. And besides that, I also want to set self.startTime to pygame.time.get_ticks. This is really important because this starting time here doesn't necessarily have to be 0. We could very well start a timer at some point in our game. So this 0 might be something like 1240, which means we started a timer about 1 second into the game. We're doing all of this in milliseconds. And if the timer has a duration of 300, then this number here would be 1540. So these numbers are all relative. It's really important for all of this to work. Now, besides that, if I want to deactivate the timer, I want to set self.active to false. And just to be sure, self.startTime is going to be 0. Finally, inside of update, the actual timer happens. And this is some horrible spelling. There we go. First of all, inside of update, I want to have my current time. And this I get with pygame.time.get_ticks. The same line we have used up here. The difference now is that this update method will be called continuously, which means that this pygame.time.getTicks will always get our current time. And basically what I want to check is if my current time minus my self.startTime is greater or equal than self.duration. For example, if my current time is something like 1500, my start time is something like 1000, and my duration is something like 300, then the result here would be 500 is greater or equal than 300, which would be true. So our timer should have run out. Now, if that is the case, first of all, I want to self.deactivate the timer. I want to run all of this here. Besides that, in case we have defined a function we want to run if the timer has run out, I want to check if self.func, so if a function exists, and if that is the case, I want to call self.func. And with that, we have a timer class that we can use inside of the player. Now for that, first of all, we have to import it, which we do with from timer import timer. And with that covered, I want to add another section. Let me put it before the tools. And this I'm going to call timers. In here, I want to create a dictionary that I call timers. In here, we have a couple of key value pairs. The key is just the name of the timer. Let's call this one tool use. And now I can create a timer. And let's say for the tool use, I want to have a duration of 350 milliseconds. And once this has run out, I want to call a function that I called self.use_tool. Really important here, you do not want to call this function. You just want to pass it into this class. And this one doesn't exist right now, so we do have to create it. Let me put it actually right at the top here, so things are easier to see. So use tool, and this one needs self and nothing else. Now this use tool for now is not going to do anything. All I want to do is print, let's say self.selectedTool. Later on, this one is going to do quite a bit more, but for now, I just want to minimize it. More importantly for now, inside of the input, I want to get myself.timers, and in here, the tool use timer, the one we created just a second ago. And this timer, I want to activate. And now this we can use inside of getStatus. And really all I want to do is if self.timers and tool use, if this one is active, then for now, let me print tool is being used. And let's try if this one is working. So now if I press space, we get tool is being used. So something is happening, but this is looking weird and it never stops. So we do have to make some adjustments here. Now, first of all, the one thing I do want to change is the player should not be able to move once we are using a tool, which means once this timer is active, the player shouldn't be allowed to do anything else. And for that, I want to indent all of this one level. And I want to have an if statement, if not self.timers and tool use, if this one is active. So only if we are not using a tool, the player is allowed to move around and to use a tool. We couldn't use a tool if the player is already using a tool. That should make sense. Now, besides that, I also want to set self.direction to an empty vector. So pygame.math.vector2. The reason is, think of if the player is moving to the right and then starts using a tool here. If we didn't add this line here, the player would just keep on moving to the right while using the tool, which would be very strange. And we wouldn't be able to stop it because, remember, the player is not allowed any kind of input while we are using a tool. So we have to stop the player, otherwise we would get some weird results. But once we have that, inside of getStatus, all I really want to do is update my self.status so that I have a string that could, for example, be right and x. So x is going to be what we are getting from our selected tool. Could also be whole or could be water, but for now I want to keep it with x. Meaning this is going to work kind of like this line here, except now we're adding a different word after the underscore. Which means this could be a really good exercise for you. Copy this line here and adapt it so you are incorporating the selected tool. Let me minimize the input so we can see it a bit better. If the timer is active, you are supposed to have the status, so up, left, down, or right, plus an underscore, plus the x. All right, all you have to do is, first of all, copy this line here, or this part of the line, so we just have up, left, down, or right by itself. And to that, I want to add an underscore, and then I want to add self.selectedTool. And with that, we should be good to go. Let's try this one now. And now, if I press space, we have something. So we do have an animation. The problem is the animation never stops, which I guess is a start, but we do have to work on it. The main reason why this happens is because we don't actually update these timers. What I forgot to do is to call this update method continuously. And to do that, let's put all of this in a separate method, although it's going to be a very short one. Let's call it update timers. This one needs self and nothing else, as always. And then here, all I want to do is for timer in self.timers.values. Because remember, we have self.timers as an attribute. This one is a dictionary, and then the key is the name, and the value is the actual timer. And this is what we are getting here. And all I want to do is call timer.update. And now, inside of the update method of the player, I want self.updateTimers. And now let's try this again. So now we have an animation that is very inconsistent though. And the reason why that is happening is, let me go back to input. In here, we have to add one more line. And that line is going to be self.frameIndex is going to be 0. The reason we need that is, let's say we have our frame index. This could be 0, 1, 2, or 3. And essentially what we are doing is we always go from one to the other, and then we are going back to the start. When we are pressing space, so this line here, we want to play a new animation. The problem is frame index doesn't know that. So when we start this animation, we might already be on frame index being 2. And as a consequence, we are playing not the first frame, but we are playing one frame that is already maybe at the end of the animation, which would be looking very strange. And if we add frame index being 0, this is being fixed. We always start the animation from the start. So now let's try this again. And there we go. We have a proper X animation. This one looking quite nice. What you could also do is replace this X with a hoe. And now we have the hoe. And you could also change it with water. And if I do that, we have the watering can. So with that, we have our different tools. Although we are not able to change between different tools. And we also can't see which tool is currently being selected. I guess let's work on that in the next major part. In this part, we are going to work on switching between the different tools. And since we already have timers, there isn't actually that much to do. So let's jump right in and let's have a look at all of this. Back in the code, I want to keep on working inside of player.py. And now, first of all, I want to check if the player is pressing a button to change the tool. This happens inside of input. In here, I want to add another section. Let's call it change tool. And for this one, I want to check my keys again. And in here, pygame.k_q. So we are pressing the Q button on the keyboard. I couldn't really think of a better one. If you can't find a better key, just go with that. If that is the case, I want to do something. Now, what that something is going to be determined inside of the init method. So right now, the selected tool is always going to be one specific string, but I want to make this a bit more flexible. And what I want is, first of all, I want to have an attribute that is called tools. And in here, we have the hoe, we have the axe, and we have water. And besides that, I want to have a seed index. And this by default is going to be 0. And then when we select a tool, I am not going to get a string. Instead, I want to have self.tools and then this shouldn't be seed, this should be tool index. Sorry about that. So I want self.tool index. And right now, since our tool index is 0, we are picking the first element from this list. And what I basically want to do inside of this if statement here is I want to self.tool index plus equal 1. And after we have that, I want to update my self.selected tool. And this is just going to be self.tools and then self.tool index. Now this is fine in theory, but in practice, this is going to break. Let's actually try. So main.py, I want to run it. And now if I press Q, we are getting list index is out of range. The reason is, to us, pressing Q once might just be pressing Q once. To Pygame, it looks like we are pressing Q for a certain amount of time. And it keeps on adding this +1 to the tool index continuously. I can actually visualize this. That is much better than explaining it. So if I print the tool index and run this again, and if I now press Q, we are getting 1, 2, and 3. And then we are running out of numbers. And I should get rid of the print statement. Let me look for it really quick. Let me comment out this print statement here. And let me just add a pass in here. That way it's a bit easier to see what's going on. If I now press Q, we are getting 1, 2, and 3. And then we're getting an error. Because we are trying to use these numbers for indexing. And this list doesn't have that many indexes. As a consequence, we are getting an error. And the problem is that Pygame tries to add more and more numbers. The way around that is we need a timer that after every time we are pressing the button, we want to wait a couple of milliseconds. Now, fortunately, we already have a very good system to work with timers. So I want to create another timer. And this one I call tool switch. And this one is going to be another timer. And this one has a duration of 200 milliseconds. There's no second argument because we don't really want to call a function after this one is over. We just care if this timer is active or not. Once we have that, and not self.timers, and in here I want tool switch dot active. The player should only be able to change the tool if we are pressing Q and if the tool switch timer is not active. Inside of the if statement, the first thing that we are going to do is self.timers and tool switch. And this timer I want to activate. That way, we are only ever adding a single number to this tool index and we're not doing it continuously. So now let's try this again. If I press Q, we get 1, we get 2, now we get 3, and we're getting an error. This error we are getting because even though now I am only adding a single number, we can still add as many numbers as we want. But what I want to do instead is that if we are exceeding the length of this list, I want to set the tool index back to 0. So if tool index is greater than length of tools, then I want to set the tool index to 0. And this could be a really good exercise for you. So if you want to code along, pause the video now and try to figure this one out yourself. This should be doable on a single line of code, although 2 would also be doable. Alrighty, basically all I want to do is I want to set my self.toolIndex, and now I want to get self.toolIndex by itself, but this only if a certain condition is true. And that condition is self.toolIndex is smaller than the length of self.tools. And if that is not the case, so else, I want to set tool index to 0. And now, let's try this again. Now I can press Q, we get 1, 2, 0, 1, 2, and so on. And I can never go beyond the length of self.tools. And now, we already have all of the tools. Because remember, we are updating our selected tool. And this is what we're using inside of the status, so we don't have to make any more changes. This is all we need. So with that, we are able to change our tool. Wasn't actually so bad, or at least I hope this wasn't too difficult. Now, while we are here, we can go in 2 different directions now. We can either work on the overlay, or we can work on the seeds. Now, I think it's best to start with the seeds, because the seeds work basically in the same way as the tools do. And once we have that, we can create the entire overlay in one go. So let's do the seeds right now. And this is going to be started inside of the dunder init method, right below tools. And here, I want to have my seeds. And for the seeds, I want to have self.seeds. And in here, we only have 2. We have corn and we have tomato. Then we have self.seedIndex, and this by default is going to be 0. And then we have self.selected_seed, and this is going to be self.seedIndex. We are basically doing the same thing we have done for the tools, except now we are storing all of this in different attributes. Which means now the tool use and the change tool are going to be very similar as well. We have a seed use and we have a change seed part. And those are going to be very similar compared to those two. As a consequence, this could also be a really good challenge. So try to copy those two to update the seed. If you want to start, if the player is pressing Control or left Control, then I want to use a seed. And if the player is pressing E, then I want to change the seed. So pause the video now and see if you can figure this one out. And remember here, you are going to need some more timers. All right, let's try it together now. First of all, I need 2 more timers because I have a tool use, I have a tool switch. Besides that, let me actually duplicate both of those. I want to have a seed use and a seed switch. And for the seed use, I want to have a method called useSeed. And you could change the numbers here. I really don't care about it. Now, first of all, I have to create another method, just like useTool. I need use_seed. Needs self and nothing else. And for now, let me add pass in here. Then I can minimize the function. And now we can work on duplicating these 2 lines. And we are very much duplicating them. So let me copy and paste things. First of all, if keys, and now we are checking k_, and the name for the left control button is LCTRL, short for left control. If that is the case, I want to activate my seed use timer, and the other two lines I want to keep as they are. After that, I want to copy the if statement for change tool, and this one is going to be KE and not timers seed switch. If that is the case, I want to activate my seed switch timer, and now the index here is going to be for the seed. So I'm basically replacing tool with seed, and that is all we are going to need in here. Now, unfortunately, there's no animation for the seed. So instead, what I want to do is I just want to print, let's say for left control, use seed. And then for change seed, I want to print self.selected seed so we can tell what's going on. And now let's try. And we're getting an error that I made a typo somewhere. So inside of the init method, this method here should be useSeed, not used seed. So now let's try this again. And there we go. If I press left control, we get useSeed. And if I press E, we get either corn or tomato. So this is working really well. And with all of that, we have a ton of different inputs for the player without too much work actually. So let me remove the print statements, and now I can minimize the input. This one is getting quite chunky. Okay, I'm quite happy with this section. So in the next section, we are going to work on the overlay so we can tell what's going on. In this section, we are going to create the overlay, which honestly isn't all that difficult. All we essentially are going to do is put some images on top of the entire game. And then those images are going to change depending on what the player has selected, both for the tool and for the seeds. So let's jump right in. Once more, I have main.py open, and I want to create a new Python file that I'm going to save as overlay.py. In here, I want to import Pygame, and also I need from settings, import everything. And now I want to create a class called overlay. There's no need for inheritance, and I do need a dunder init method. We need self as always, and now we also need the player, because the overlay needs to know what the player currently has selected. Inside of that, I want to have a general setup. In here, we need two things. First of all, I need self.displaySurface. That is the same thing we have done inside of the level. This way, we can draw straight on the display surface, and we can keep all of this inside of the overlay class. All we need here is pygame.display.get_surface. Besides that, I want to store the player in an attribute. So self.player is going to be player. Besides that, I need to do some imports, because in here I need self.tools and self.seeds. And those are not the same seeds and tools that the player has. Instead, let me rename it actually. These are all surfaces. More specifically, they are dictionaries with key value pairs. For example, one key for the tools could be X, and then the value would be a surface of an X. Now for that, we have to import a couple of images. Let me show you what we are going to import actually. Here is the project folder. I want to look at graphics, and inside there we have overlay. Inside of that, we have X, corn, hoe, tomato, and water. And this is what we want to import. Now here, you could import everything manually, but once again, that's not really a pleasant way to work in, well, any programming language. So I'm going to use dictionary comprehension. How that is going to work for the tool surfaces, I want to have a tool, and this is going to be the key, and then I want to have a surface as the value. And this I want to do for tool in player.tools, which means inside of player, I want to look at all of these tools. And from this data, I want to create a key value pair. And the tool can actually remain the same. So if we leave it like this, the tool or the key would be hoe, x, or water, which is totally fine. The one thing we have to change is the surface. What I want to do in here is pygame.image.load, and inside of that, we need an f string. Now, to keep things a bit shorter, I want to store the path separately. So let me call it path. Actually, let's call it overlay path. That makes a bit more sense. And all this is a string. We go up one folder, we go to graphics, and then we go to overlay, and don't forget the final /. And this I want to use inside of this f string, so overlay path. After that, I want to look at the tool. So the tool could either be X, hoe, water, or could be one of the seeds. And this is also how each of the files here are named. So this is very handy. Finally, one important thing, don't forget, we are looking at PNG files. Also really important, you want to convert alpha, all of this, which makes all of this fairly long, but very easy to work with. And once I have that, I can copy the entire thing and paste it in here. And all I really have to do is to replace tool with seed. Make sure you call this player.seeds. And then this tool should also be seed. But other than that, we should be good to go. Let me actually print tool surface and seeds surface just to make sure that this is working. Oh, actually, we have to create the object from the class first of all. And this happens inside of level. So in level, I want from overlay import overlay. And now when we are creating everything, I want to create self.overlay. And this is going to be the overlay class. And in here, don't forget, we have to pass in self.player. Now for that to work, you have to create this overlay after the setup method, because inside of setup, we are creating the player. And now once we have that, let's run main.py, and we are getting an error. The name tool surface is not defined. Let's have a look. Ah, I forgot self here. Now let's try this again, and there we go. We're getting dictionaries with key value pairs that all look pretty good. Cool, I'm very happy with this. So now we have access to the player and we have all of the surfaces that we do need. All I have to do now is to create another method, and let's call this one display. In here we need self and nothing else. And now I want to show the tools and I want to show the seeds. And for this one, first of all, I need the tool surface, because right now we have a dictionary with key value pairs, but what we want is one specific surface. We have to select one surface from this dictionary. And this we get with self.tools surfaces. And what I want to select from here is self.player.selected tool. Remember here, the selected tool could either be X, it could be hoe, or could be water. And this is also what we're using as a key inside of tools surface. And let's actually try. So I want to display this tool. And this I get with self.displaySurface.blit. And in here, I need a surface, which is my tool surface. And for now, I'm going to place this at position 0 and 0. With that covered, I have to make sure I actually call the display method of overlay. And this happens after we are drawing all of the sprites. You could just run this line all the way at the end of the run method. So in here, self.overlay.display. And now let's try. And now in the top left, I can see my selected tool. And if I change my selected tool, this graphic updates as well. So this is very nice. The problem is it shouldn't be in the top left. And for that, we have to update these numbers here. Or to have a bit more control, I want to create a tool rectangle. And this one we get with tool surface.get_rect. And in here, since I want the tool to be in the bottom left, I want to place the mid bottom. And the position here, I am storing in my settings, because in there I have overlay positions. That way it's a bit easier to adjust all of the settings later on. There are a lot more similar dictionaries in here as well. So these are the numbers I do want to use, which is quite simple. All I have to do is I have to get my overlay positions. Let me just double check if I spelled this correctly. Actually, let me copy all of this and paste it in here. That looks pretty good. And in here, I want to get my tool. And now, when I am using the blit method, I want to use my tool rectangle for the positioning. And now, let's run this again. And this is looking really good. And with that, all we have to do now is to copy all of this for the seeds. And I think this could be a really good exercise for you. Basically, what you want to do is copy all of this, except now it should be for the seeds. So pause the video now, and if you want to follow along, try this one yourself. Just as before, I want to create a seed surface. And this I get with self.seedSurfaces, and in here, self.player.selected_seed. After I have that, for the positioning, I want to get a seed_rectangle. And this I get with my seed surface. This should not have an S. And get_rect. Once again, I want to place the mid bottom, and the position here, I can copy it from the tools. I want to get my overlay positions and get the key seed. That is going to be this one here. Finally, all I have to do is self.displaySurface.blit, and I want to have my seed surface and then my seed rectangle. And with that, let's run main.py, and we are getting an error that I forgot the square brackets here. Now let's try this again, and there we go. Now in the bottom left, we have the seeds and the tools, and we can switch between them. This is working really well. And is surprisingly satisfying. All right, cool. With that, we have the overlay. That was all that was needed. Now that we have the player, we can start working on the camera and the floor. Those two kind of have to come together, because without the floor, we wouldn't see what the camera is doing. And without the camera, we wouldn't be able to see what the floor is looking like in total. And I know I am repeating myself a lot, but for the camera, there is a whole set of logic. I will go over the basics, but I have made a whole video on cameras in detail in Pygame. So check this one out if you want to go into much more detail. Once again, here I have the code. And before I do anything else, I want to close a couple of files. We don't need overlay anymore, and we don't need the timer.py anymore. Those two are basically finished, and well, we don't have to worry about them. And I do want to keep things a bit more organized. Besides that, the level should be right next to main.py, because those two files are the most important ones. And inside level.py, I want to create the camera. This is going to be a separate class. And let me call it camera group. And this one has to inherit from pygame.sprite.group. Basically what this one is going to do, or how this one is going to work. Instead of putting all of the sprites into a normal Pygame group, we're going to create a special kind of group. And via this group, we're going to get the camera. For that to work though, first of all, we have to initiate the group by itself, and this one itself and nothing else. And in here, we need the super dunder init method so that the group works by itself. Now, once we have that, I can replace the group we created like an hour ago with the camera group. And so far, since we have basically created another group, there shouldn't be any difference. Meaning if I run main.py, nothing has changed. Which is a good start. At the very least, we didn't break anything. But now that we have more control over what the group is doing, we can customize this thing quite a bit. And one thing you could be doing, for example, is get self.displaySurface in here as well with pygame.display.get_surface. That way, this camera group can draw on the display surface straight away, which you could use by creating a customize draw method. And this one needs self and nothing else, at least for now. Now, the way a normal group draws a sprite, so this line here, essentially all that it does is it runs a for loop with for sprite in self.sprites. Don't forget to call it. For some reason, this is a method. And now in here, we are calling the display surface with blit. And then we are passing in sprite.image and sprite.rect. This is basically all that is happening inside of a normal group for the draw method. Which is also the reason why every sprite always needs an image and a rectangle. If you didn't have those, you wouldn't be able to draw the sprite, so they are mandatory. So now that we have a customized draw, I can comment out this draw here, and instead I want to run self.allsprites.customizeDraw, and let's call it. Actually, let me call it custom draw. That makes a bit more sense. Custom draw, that fits better. And now if I run this, everything still works just as before. There's no difference. Although now we don't have to pass in the display surface anymore in here, which already is a minor improvement, although not that much of a difference. With that, we have a start for the camera logic. Although we don't have a camera yet, but well, this method is going to become quite a bit more extensive. Although right now we have a problem. Because any kind of camera I would create would be impossible to see because the background is pure black. So even if we move left or right, you wouldn't be able to see it because it's, well, all black. As a consequence, we first of all need some kind of floor so we can see what's going on. And for that, we have to import the floor. Now the floor is very simple. It is one big image. If I open the project folder, inside of graphics, there we have world. And inside of there, we have the ground. And I guess let me open this one. All this is one big image. And you can see here, we have, for example, the trader, and we have a whole bunch of objects all the way over here. And the rest of the map, so all of this stuff here, is really empty. How all of this is going to work in detail, I will explain in the next few sections. For now, just don't worry about them. But don't worry, I didn't make a mistake. All of this is intentional. So let me move this away. And this image we want to import. Although for it to work, we first of all need another class to actually use it inside of Pygame. And for that, I want to create a new Python file that I want to save as, let's call it sprites.py. Because in here, we are going to have more than one. And I want to import Pygame, and from settings, import everything. And for now, we just want to create a very generic class. So let me call it generic. And this one is going to be a sprite, so pygame.sprite.sprite. In here, as always, we need the dunder init method. This one needs self. And besides that, we need a couple of arguments. We first of all need the position. After that, we need the surface we want to import or we want to use. Then we want the groups. So this is kind of similar to the player, where we have a position and a group. So where the sprite should start and what group it should be part of. However, for the generic sprite, it needs a surface because we might add different kinds of images in here. Now, first of all, in here, as always, you need the dunder init method with the groups inside. That is missing something. That's looking better. And now we need self.image and we need self.rect. The image is just going to be the surface, which means we're taking the surface from the arguments and passing it in here. That's all that's going to happen. And for the rectangle, we get self.image.get_rect. And now we're placing the top left wherever the position is. The position we are again getting from the arguments and passing it in here. Now we just have to figure out how to use it. And this I am going to do inside of a level, which means first of all, I need from sprites import generic. And now inside of setup, I have to import it by using this generic class. I want to create an instance of the generic class. And now I need the different arguments for the various parameters. Let me copy them and paste them in here. And let me use named arguments so this is a bit easier to see. The position is super easy. It's just going to be 0 and 0. For this is terrible formatting. Let me clean this up a tiny bit. For the surface, all we have to do is to import pygame.image and load. And now we need the file path, which is one folder up. Then we go into graphics, then we go into world, and then we get ground.png. As always, don't forget to call convert alpha on all of this. Finally, we need the groups, and this one is easy. Just like for the player, we need self.allSprites. This one should be working already. So let me try. And there we go. Now we can see the background. And now we need the camera to see the rest of the level. So right now we can only ever see the top left of the map, which wouldn't be helpful, but this is already looking much better. However, before we can do that, there's one major problem. Right now, the floor is only behind the player because we are creating it before we are creating the player. Which means if I created the player before this generic class and run this again, we wouldn't be able to see the player because the player is behind the ground, which is not, well, good at all. And this leads us to one of the 3D effects we need for the game. If you look at settings, we have what is called layers, all of this. And this I want to use to draw the different elements of the map. Most of the game is going to happen inside of main. In here, for example, we have the player, all of the plants and the trees and stuff like that. And the ground should be all the way here. What we are essentially going to do inside of this custom draw method, we are going to cycle through this list and then draw things one by one. Meaning the water will be drawn first, then the ground, then the soil water, and so on, and the raindrops all the way at the end. That way we get a three-dimensional effect where different things are on top of other things. There's actually going to be a second three-dimensional effect, but that's going to come later. I don't want to overwhelm you guys. Now, for all of this to work, we first of all have to assign each sprite one of these layers. Which means right now the sprites need one layer and the player is going to need a layer. And let me get started for the player. Right below the rectangle, I want to assign what I called Z. And Z is just going to be layers, so the dictionary from settings, and the player should be on main. So I can just copy it and paste it in here, and now the player has a Z position. This means that inside of the game, every single sprite has an X position, we have a Y position, and besides that, we are going to have a Z position. X and Y are always going to come from the rectangle here. And Z is going to be a separate variable, but both of those work very closely together. Now, besides that, for the sprites, we also have to determine what the Z position is going to be. And this might potentially change. As a consequence, I want to have Z as a parameter. Although here I do want to have a default parameter where if we don't get an argument, Z should be on the main layer. And don't forget to turn the parameter into an attribute, so self.z is going to be Z. Now, that being said, for the ground, so the ground we are creating here, the floor is not supposed to be on the main layer. Instead, it is supposed to be, so Z is supposed to be in layers, And this key here is called ground. Let me copy it and paste it in here. Now we have a Z position. We just have to figure out how to actually use it. This is going to happen in here. And this, I believe, could be a really good challenge for you. So try to use this dictionary here and draw elements by the order inside of this layers dictionary. Meaning the higher the number is, the later it should be drawn. If you want a quick tip, this should be a for loop. But pause the video now and try to figure this one out. Let's see if you can do it. The way this is going to work. First of all, we have to cycle through the layers dictionary. Let's call it for layer in layers.values. We don't actually care about the keys, they just don't matter. And all of the drawing is going to happen inside of this for loop. And all I really want to do is I only want to draw a sprite. So after going through all of the sprites, I want to check if sprite.z is actually the same as the layer being one of the values of the layers dictionary. And only if that is the case, I want to draw this layer. And that should be it. Let's try. And now I can see my player again. Even though the player is being created before we are creating the floor. Which means this logic here is working just fine. Cool. So with that, we actually already have some sort of camera, but not a real camera yet. Let's actually work on it properly now. So for the camera, and once again, check out my dedicated video on camera logic. This one is really important to understand. But first of all, what we need here is we have to create some kind of offset. And this is going to be a vector. So pygame.math.vector2. And how this is going to work. Think of this one here is the player and everything else. So all of this stuff here is going to be the rest of the map. And how the camera is going to work is if the player is moving to the right, we are going to shift the entire map to the left. Now, when I say shift the entire map to the left, I don't mean to actually move it. Instead, we're going to draw it in a different position. The actual position doesn't change. Which means in practice, when we are doing display surface.blit, sprite.image is going to stay exactly the same. Which means in practice, when we are calling this display surface.blit, this one doesn't change the position. It just draws a sprite in a certain position, wherever this rectangle is going to be. But this rectangle you can move around perfectly fine. And the way I want it to work is by making it relative to the player. And for that, first of all, when I do custom draw, I want to look at the player, because this is what the camera should be following. And now I want to have my offset .x, and I also want to do this for y. And the logic here, let me do it for x and y together because it's going to be fairly similar. I want to look at my player.rect.center, and for x is going to be x, and for y it's going to be center y. So right now I am getting the position of the player. And from that, I want to subtract this green, and then for x, this is going to be the width, and for y, this is going to be the height, divided by 2 for both. What that basically means is the offset is going to be by how much we are going to shift every single sprite relative to the player. And we have to figure out by how much we want to move them. And this logic here ensures that the player is always in the center of the camera. If this one here is the player, we always want to have an offset that points at the top left of the window, which means we want to go half the screen width to the left and half the screen width up. And then we're ending up on the point up here. This is what we have to use to draw everything. Now for that, first of all, I want to create an offset rectangle. And this we get with sprite.image.get_rect. And this we get with sprite.rect.copy. And this offset rectangle, I actually want to offset. So I want to get the offset rectangle again. And now I want to move the center by minus equal the offset. And this offset rectangle is what I'm going to use to draw the image. And now there's one more thing we need, and that is when I'm calling custom draw, I have to insert the player. Fortunately, we do have the player inside of self.player. So let me pass it in here. And now let's run all of this. And now if I move around, we have a camera. And this is feeling pretty good. We are definitely making progress. Although a lot of stuff is missing right now, and this tends to look a bit weird. But, well, we're getting there. And I am fully aware that I didn't really go into detail for this entire logic. So I hope you could kind of follow along. But if you check out my videos on cameras, this is explaining all of this in so much more detail. So check this one out if you are interested. The logic here unfortunately gets quite complex, and I don't want this video to be 20 hours long. But alright, let me remove some white space, and then we are basically done for this part. In this part, we are going to import all of the other elements, and we are going to fake 3D a tiny bit more. And I guess let's go through this one by one, and let's start by importing all of the elements. We have already done this to an extent, but, well, now we have to do more of that. Now, there is a tiny bit of theory that I do have to cover, and that is that the entire game was designed in Tiled, which is a free program that you can use to design levels. It's really powerful. And I am using another module called PyTMX to import all of this data. Now, let me go through what all of this means by looking at Tiled. Here we go. This is all of Tiled. So in here, I could, for example, move things around and design the level to look slightly different. And doing all of this took quite some time. There's a ton of things in here. So if you look on the top left, there are a ton of layers that you could be working with. And well, all of this is very complex. And once again, I have made a complete video on all of this, so if you want to have a ton of detail, check that one out. I just don't have the time for this video to go over Tiled separately. All I am going to do is import all of this data into Pygame. So let's do all of that. Once more, here I have my Python setup, and I want to continue working inside of level. And let me minimize all of the methods, so this is a bit easier to see, and I can minimize the camera group. Now, first of all, I have to import PyTMX. This happens with from pytmx.util_pygame. I have to import load_pygame. And really important here, PyTMX you have to install separately. It does not come with Python. So either in the PowerShell or in the terminal, type pip install pytmx or pip3 install pytmx, depending on Mac or Windows. Now, this I want to use inside of the setup method. And in here, let me add a bit of white space. First of all, we have to load a file. If I open the project, inside of data, we have map.tmx. This is what I want to import. All of the data is in here. And this I am loading with load pygame, and in here I need the path to this file. I have to go one folder up, then I have to go to data, and in there we have map.tmx. And now we have to import a ton of different things. So let's start by building the house. I think this is quite good to illustrate how this is going to work. Now the house, if I go back to Tiled, the house consists of a couple of different layers. Let me go through them one by one. So if I hide all of them and zoom in, let me hide all of this as well. We have a house floor, then we have house walls, then we have the furniture at the bottom, and then we have the furniture at the top. And all of these layers we have to import separately. And really important, all of these have to be on a different layer inside of Pygame. Which means back in Pygame, for the house, we have a couple of different layers. Most importantly, house bottom is going to be for the bottom and the rest of the house is going to be in main. And this is really important. So let's go through it one by one. First of all, to access the data, I need to store all of this inside of a variable. Let me call it tmx_data, and now I can use it. And this has a ton of methods that we could be accessing. The one I want to use now is called tmxdata.get_layer_by_name. And now we need a name of a layer. The one we could be using in here, for example, is house furniture bottom. And this, if I look at tiled, is this name here, house furniture bottom. And what I want to do is to add tiles after this. That way, I am getting all of the tiles inside of this layer, and I can use them inside of a for loop. And what I'm getting here, let me add the for loop first. So this for loop is going to return a list that I can unpack right away. And the list consists of x, y, and a surface. Really quick, back in tiled. When I'm only looking at the house furniture bottom, and let me hide everything else. And this is in house decoration. There we go. In this, we have a couple of different tiles, and each tiles is one of these, well, little cells inside of a grid. I just want to import this carpet thingy and this other carpet thingy here. This is all I really want. And each of those is going to have an X position, a Y position, and then what you see is the surface. This is what we are importing, which means I already have a class to capture all of this data. That is my generic class. And in here, I need a position, I need a surface, and I need my groups. Oh, and also I need the Z position. First of all, for the position, you might be tempted to just add X and Y in here. But that wouldn't be a good idea, because this X and Y position is not a pixel position. Instead, if I return to tiled and zoom out a bit, there you go. The position we are looking at is the X and Y position on this grid. So for example, all the way in the top left, this cell here has the grid position 0 and 0. And the one to the right of it, so this one here, is going to have 1 and 0. But all of these tiles have a size of 64 by 64. So the actual starting position of this cell here is not going to be 1 and 0, it is going to be 64 and 0. We are essentially multiplying the position by 64, or rather the size of the tile. And this position we have available in Pygame as well. It is inside of settings, all the way at the top we have the tile size. All I have to do is to multiply X and Y by the tile size. Now the surface we already have. It is just the surface we are importing up here. Then we need the groups, and this one is also fairly easy because all we need in here is self.allSprites. And for Z, I want to have my layers, and the house furniture bottom should be inside of the layer house bottom. This one here. Let me copy it and paste it in here, and this should be all we need. There we go. This should already be working now. Let's try. And I do have to walk down a tiny bit because the house is somewhere down here. There we go. There we have a carpet, and it is below the player because of the layers. That is a really good start. Now there's a bit more stuff that I want to put on this layer. And as a consequence, I'm going to wrap this for loop inside of another for loop. And what I want to do is for layer in the list. In here I have house floor, and then I have the house furniture bottom. And now for X and Y and surface is going to be for the layer. This way I am using the same for loop for the house floor layer and for the house furniture bottom layer. Now if I try this, we are getting an error because I forgot the colon. So now let's try this. And if I now walk down, I should be seeing the house floor and the carpet. This is looking pretty good. Although in here, the one limitation is that this house floor has to come before the house furniture bottom. This house furniture bottom is only drawn on top of the house floor because it is being created afterwards. If we reverse the order here, let me add it like this, then you would not be able to see the house furniture bottom. Let me try it now, and there you can see, you, well, cannot see the carpet. But we only have two elements here, so this isn't really that much of an issue. This works just fine as it is. With that, we have 2 layers out of quite a few. Now, this entire thing I now want to copy because there are 2 more layers that work in kind of the same way. We have the house walls and we have the house furniture top. Those are going to work in basically the same way for this line and this line. The one difference is that those 2 should be on the main layer. And now, let me try. If I now walk to the house, always takes a second. There you can see the entire house. Right now, it is always below the player, but this we are going to change very soon. But, well, we have a house. Admittedly, this setup here could be a bit more elegant, but I don't want to add too many for loops, but you could totally do it if you want to. There's quite a bit of repetition in these lines here. Alright, there is one more thing that we do need, and that is the fence. Let me illustrate this in tiled. Here's in tiled, and right now everything is hidden. So let me make most of the stuff visible so we can see what's going on. The fence I'm talking about is this fence here. This is what I want to import now. And this is going to work very similar compared to the house. Which means this could be a really good exercise for you. I want you guys to cycle through the layer is called fence, cycle through this layer and import the surface with the X and the Y position using the generic class. And this should be inside of its own for loop. So pause the video now and try to figure this one out. We need for X, Y, and the surface in tm x underscore data dot get layer by name, and the layer we want to look at is called fence. And then here, don't forget, we need tiles. Once we have that, we need the generic class, and in here we need a position, we need a surface, we need a group, and we need a layer, or rather a Z position. The position is super easy. This is the one we have already done multiple times. Let me just copy it from the house. So position, this one, and surface we also already have. Now for the groups, for now, we only have a single sprite group. So self.allsprites is going to remain the same. Finally, for Z, I do want the fence to be on the main layer. And since that is the default parameter, I can just leave it as it is. As a matter of fact, for this line here, I could actually remove layers.main because this is what we get anyway. Let's do it like this. And now let's try. And there we can see the fence. This is looking very nice. Righty. There are 3 more things that we do have to import. We have the water, we have the trees, and we have some wild flowers. And all 3 of those are going to be their own class because they are all slightly different. So let's create some more classes. This is all going to happen inside of Sprite. First of all, I want to create a class called water. And this is also going to be a sprite, but the sprite we are getting from generic, which means water is going to inherit from generic. And since generic is a sprite, water is also going to be a sprite. And in here, as always, we need a dunder init method. And this one needs self, it needs a position, it needs frames, not a surface, we need groups, and we need Z. The major thing about the water is that the water is going to be animated. And this means we kind of need the same setup for the animation that we have seen for the player. It's inside of Animate, basically this kind of setup here. So we need a couple of frames, like we have seen in here, and then we need an entire method to loop over all of these frames. And the frames are going to be stored inside of the method frames. Let me add a comment here, and let's call this animation setup. In here, we first of all need an attribute with frames. And this is just going to be frames, what we are getting from the parameters. Then we need self.frame_index. This is 0 by default. And once we have that, we can start with the sprite setup. And in here, all we need is this super dunder init method. And for this one, we need the init method of the generic class. All of these parameters here. Position is what we are getting from the position from the water. And let me use named arguments here. That is a bit easier to follow, I think. For the surface, I want to get my self.frames, and in here, self.frame_index. And this should probably be on multiple lines, otherwise it's kind of hard to read. For the groups, all I want is the groups I am getting from the parameters of the water class. And finally for Z, all we need here is inside of settings, we have water. This is what I want to pass inside of the Z argument here. And this doesn't animate yet, but we do need a few more things. So back in level, let's start creating this thing. And first of all, as always, I need this kind of line here. So let me just copy it. The name of the layer we need here is called water. And what I want to do is to create a water tile. Although right now we don't have water available inside of level, meaning besides generic, I want to import water. For this one, we need all of these parameters. Position is going to remain basically the same. I can just copy things and paste them in here. The other easy one is the groups, because once again, we only have a single group so far. So this is always going to be all sprites. The problem we have is we need the water frames, which, if you open the project folder again, are inside of graphics, and in there we have water. And we have 4 different frames, and these we want to animate. But for that, we have to import all of them. Fortunately, we already have a function that imports an entire folder and converts it into surfaces. The same thing we have used for the player, so we can reuse all of this. For that to work though, we first have to make it available inside of level.py, which means from support, I want to import everything. And now I can use import folder. And for the water, I want to have some water frames. And this is going to be import folder. And the file path we need here is one folder up. Then we have graphics, and then we have water. And these water frames we want to use in here. And now let's see if this is going to work already. So if I move over this side, there is going to be some water. This is looking really good. And if I move further down, we should be able to see some more water. There we go. So now we have water, except it's all static. So now we have to animate it. That is going to happen inside of sprites. And in here, I want to create an animate function, or well, method. It needs self and delta time. I think we could do another really good exercise. So like for the player, we have to create an animate function. So try to create this one for the water. Basically what you have to do is copy the thing you have seen for the player and then make sure you're actually calling it. So try this one yourself and see if you can figure it out. I think a really good way here is to look at both of the files next to each other. It's a bit hard to see, but I hope you get the idea. We are basically going to copy all of this. So first of all, we need self.frame_index, and we want to increase this by a certain number. For the water, I went with 5 and multiply this by delta time. But this 5 here is entirely subjective. Play around with this. After that, I want to check if my self.frameIndex is greater or equal than the length of self.frames. If that is the case, I want to set self.frameIndex to 0. Finally, I want to update self.image, and this is going to be self.frames. And in here, don't forget, we need an integer of self.frameIndex. And that is all we need. All we have to do now is to figure out when to call this animate method. And this we are doing inside of the update method. In here, we need self and delta time. And all I really have to do in here is call self.animate and pass in delta time. Technically, you could just add all of these lines here and paste them inside of the update method. It would work perfectly fine, but I think this is a bit more organized. It, well, is entirely up to you. But now we should be having animated water. Let's try, and let's walk to the water. And there we go. We have animated water. This is looking quite nice. So I can minimize the water, and now we can work on the next kind of sprite. I guess a really easy one would be the class wildflower. And this one, like the water, has to inherit from generic. And in here, we need a dunder init method. And this one needs self, it needs a position, it needs a surface, and we need the groups. And after that, we need a super and a dunder init method. And once again, we need these three parameters. We don't need Z because all of the wildflowers are supposed to be on the main layer. And the wildflowers for now are going to stay just like that. We're not going to make any more changes, although later on they're going to change a tiny bit, which is why we need a separate class. But now that we have them, inside of level.py, I want to import the wildflower. And this one, if I copy these two lines here, I want to look at the layer called decoration. Let's have a look at tiled, how this looks. The layer I am looking at is this one here, decoration. And in there, if I hide and unhide it, it's all of these small elements inside of the foresty area. And these I want to import. Now there, if you look at the layers in the top right, these are slightly different compared to the tile layers we have already seen. Basically, these are objects and these we can move around easily, whereas these with the square icon are all tiles. But again, check out my original video, it explains all of this in much more detail. The difference honestly isn't that bad. I shouldn't have actually copied this line. Instead, what I should have been doing is for obj in tmxdata.get layer by name, and the layer we are looking at is called decoration. This one doesn't change. And now in here, we are getting an obj. And this obj has an x, it has a y, and it has an image. And this one is the surface. So this is what we are going to use. And now I want to create a wildflower. And in here, let me copy the parameters we need. We need a position, we need a surface, and we need the groups. For the position, we need obj.x and obj.y. And those are actual pixel positions, so we don't have to multiply them with anything. For the surface, we need obj.image. And for the groups, once again, we need self.allSprites. Let's run this again, and now we can see a whole lot more stuff on the map. This is already starting to look much better. Finally, we are going to need some trees. So I'm going to create a class called tree. This one is also going to inherit from generic. And in here, we need a dunder init method with self. We need a position, we need a surface, we need the groups. And besides that, I also want to have a name of the tree. Why that name is going to matter, let me visualize all of this in tiled. Inside of tiled, here you can see all of the trees, and they all have a name. The name you can see here. So a tree could be called small or large. And this is what I want to use for the name. That way I can tell if a tree is going to be small or large. That's basically all it is. Although later on, this is also going to determine where the apples are going to be on the tree. For example, for a larger tree, we would have this entire surface to place apples. For a small tree, we would only have this surface here. And inside of here, I want to have a super dunder init method. And this one is going to need a position, a surface, and the groups. All of these we are getting from the parameters, so we can just leave it as it is. Although later on, the trees are going to become quite substantially more extensive. But for now, all we have to do is for obj in tmxdata.get layer by name, and the layer I am looking for is called trees. And in here, I want to create a tree, although first of all, I do have to import it with tree. And the arguments we need, let me copy the parameters. The position, we can just copy from the wildflowers, this one here. So position is covered. The surface is going to be obj.image. For the groups, once again, we have self.allsprites. And for the name, this one we get with obj.name. And now if I run this, here you can see a huge amount of trees, and this is looking really nice. So the entire thing is definitely coming together. So there's only one more thing that I do want to cover. Although for that, we need a tiny bit of theory. Let's talk about it. I want the various elements to overlap. At the very least, the elements inside of the main layer. So, for example, if the player is behind in the y-axis, it should be drawn below the other elements. For example, if we have the player here and the player is behind a sunflower, the player should be behind the sunflower, or rather below the sunflower. And if the player is in front in the y-axis, the player should be drawn in front of the other elements. So if the player is in front of it, it should be drawn on top of the sunflower. And this effect is really nice in the game. It makes it look much better. It's also very easy to implement. So let's jump right in. Back in the code, I want to minimize the setup method, and I want to work inside of the camera group. I have to work inside of all of this, and this line here in particular is really important because right now we are just drawing, or well, cycling through all of the sprites. And this I want to sort. And the way I want to sort it, let's say we have two elements like this. I want to sort them by their y position, which means the further down the center of a sprite is, the later it should be drawn. In this case, this sprite here should be drawn first, and this sprite should be drawn after that. That way, this sprite here is always on top of this other sprite. And since this is going to happen on every single frame of the game, this can also change. To get all of this, we need a key for this sorted function. This always has to be a lambda function, and into this lambda function, I want to pass in this sprite. What I want to look at from the sprite is sprite.rect.centerY. That is literally all I needed. So now if I run all of this again, you can already see it with the fence, but it's kind of weird, but the sunflowers make it look much nicer. So now the player can walk through all of this, and it's looking significantly better. So this is really, really nice. And that way the game feels much more three-dimensional. It also works with the house. Let me walk there. So for example here, we can walk through all of this. And well, this is very, very nice. Cool. This was a very large section, but we basically imported the entire game. So massive progress. With the level and the player in place, we can work on the collisions. And let me cover a tiny bit of theory how the collisions are going to work first, because that can be kind of confusing. Let's say we have an object here, and we have the player moving in some kind of direction. And we want to check if the player is colliding with this obstacle. What we are going to do for that is, we are first going to check if the player is overlapping with the obstacle. For example, the player could be here, and we have an overlap. Detecting this is really easy. The difficult bit is to figure out where the collision came from. In this case, it might look like the collision came from this side, but it might have happened that the player was moving really fast in this direction, for example, or the player could have come down this side here. As a consequence, we're going to add a bit more code to figure out where the player came from. In this case, since the only object that can move is the player, we can check the player direction. So for example, if the player was moving in, let's say, this direction here, we know the collision must have happened on this side because the player was moving in this direction. And once we have that bit of information, let me clean this up a tiny bit. If we know that the player moved in this direction and our collision happened here, then we want to move the player back to something like this. And then we have the entire collision logic. It honestly isn't that bad, but you do need some theory here. And one more time, I made a whole separate video on it, so check this one out if you are interested. But other than that, let's implement all of this. Alrighty, here I'm back in the code, and I want to do a couple of things first before we start with the collision logic. The most important part is that all of the sprites, let me minimize them. There we go. All of the sprites and the player are going to need a hitbox or some kind of collision rectangle. We could be using the rectangle itself, but that would not be a good idea. For two reasons, actually. First of all, for the player, the rectangle is going to be really large. If I open the project folder inside of graphics, and let's look at the character for something like left X. In here, if I open this, okay, it's going to be very hard to see, but if I zoom in, you can kind of see by the shade. This entire surface here has a size of this. This is the entire image. And the rectangle we are creating from this has the same dimensions. And this is much larger than the actual image. The reason why it is so large is because we have to capture the entire image and the bunny has to be in the middle. If that wasn't the case, the character would move around if the size changed. So all of these surfaces have the same size, and that is really important. Because of that, we couldn't use the rectangle. But what we can do is create self.hitbox. And this hitbox is what we actually use for the collisions. And for this one, all I want to do is self.rect.copy. So we are copying the rectangle, and this I want to inflate. All that inflate is doing is it takes a rectangle and it changes the dimension, while keeping it centered around the, well, center. As an argument here, we need a tuple with a width and a height, by how much we want to shrink or increase it. In my case, I want to shrink it by 126 pixels on the horizontal axis and -70 pixels on the vertical axis. Next up, this hitbox has to be moved along with the rectangle. And this is going to happen inside of the move method. So in here, what I usually do is, after I've moved the position, I am moving the hitbox. So self.hit, that is terrible spelling, self.hitbox.centerx is going to be self.post.x. And then self.rect.centerx is going to be self.hitbox.centerx. Although in here, I actually realized I forgot one important thing, and that is that this self.post.x needs to be rounded. If we didn't include that, Pygame would truncate these values, which means a 1.9, for example, would be truncated to 1, whereas the proper value would be a 2. And this is what we get by rounding, which is why we need the rounding here. If you don't do that, you are going to get occasionally wrong behavior. Or well, incorrect behavior. But all right, now that we have that, I have to do the same thing for the vertical movement. So self.hitbox.centery is going to be rounded self.post.y. And now self.rect.centery is going to be self.hitbox.centery. With that, we have a hitbox for the player And now all of the sprites are going to need a hitbox as well. Let's start with generic. And in here, I just want to create a hitbox with self.rect.copy. And this I want to inflate. And the number here, I want to be a bit more flexible. So for the width, I went with negative self.rect.width and multiplied this by 0.2. Then I'm going to copy all of this. And then for the height, this is going to be self.rect.height multiplied by negative 0.75. The numbers here, you definitely just want to play around with. It is fairly subjective. It really depends how you want this to look. Mostly for the width, you want to have a fairly small number because you don't want to shrink it too much on the horizontal axis. For the vertical axis, you do actually want quite a large number. And this again is because of the overlap. Let me show the slide again actually. The overlap for all of this works really well because when we created this, there was no collision. But once we have collision, we really have to be aware that this rectangle here shouldn't be too tall. Because if the sunflower would have a collision rectangle that covers the entire height, the main character would never be able to go behind it. We would always get stuck on top. As a consequence, you do want quite a high negative number for the vertical axis. Alright, with that, let me minimize the generic class so we have a lot of space. Water doesn't need any hitbox because it cannot be collided with. And next up, we need the wildflower. And this is now the reason why this is a separate class, because in here I want to have a hitbox, and this is going to be self.rect. Let me copy it, and then I want to inflate the entire thing. And I want to inflate this by static numbers for the horizontal axis, which is negative 20, and for the height, I want to go with negative self.rect.height, and this I want to multiply with 0.9. Finally, we have the tree. Although in here, we don't actually have to make too many changes because the tree can take the hitbox from the generic class. So this hitbox is still going to apply. Inheritance here makes our life a lot easier. That covers a lot of the setup. There's one more thing that we need. Back in level, inside of the init method, I need another group. The group I want to create is called self.collision_sprites. And this is going to be a plain pygame.sprite.group. The only reason I'm going to create this group is because I have to keep track of what sprites can be collided with. So any sprite the player can collide with is going to be inside of this group and inside of this group. That way I can identify them easily, which makes my life a lot easier. And now, when we are creating all of the collidable sprites, that is going to be, for example, the fence we can collide with. So in here, self.allSprites, I want to put in a list, and besides that, self.collision_sprites. The same is also going to apply to the trees and to the decoration. So let me target both. And all sprites should be in a list along with self.collision_sprites. You might be wondering if house walls and house furniture top also need collision sprites. The answer is not really, but I'm going to cover that in just a bit. But that's going to come in just a bit. The one thing we need now is that the player needs to know where all of the collision sprites are, because we are going to run the collision method inside of the player. Which means I want to pass self.collision_sprites into the player. I do want to mention here, for the player sprite is inside of all sprites. And then besides that, the player is going to have a separate parameter for the collision sprites. But the player sprite itself is not inside of the collision sprite. We just have a reference to it. Whereas the decorations are both in all sprites and in the collision sprites. This is a fundamentally different concept here. So I hope you get the difference. But now to make all of this work inside of player, the player is going to need one more parameter. And let's call this the collision sprites. And this we have to capture. Let me put it below the movement attributes. In here we have collision, and I want to get my self.collisionSprites as an attribute. And I guess to keep things organized, I could put the hitbox in here as well. It does seem to make sense. And now I can minimize the init method. And now inside of the move method, we can work with the collisions. Or more specifically, I want to create a separate method that I'm going to call collide. Actually, I guess collision makes a bit more sense. Doesn't really matter. And in here, I need self and I need the direction. First of all, in here, I want to look at every single sprite inside of the collision sprites. So for sprite in self.collision_sprites.sprites. In here, I want to check has attribute if this sprite I am looking at has an attribute called hitbox. They should all do, but this is a good way to make sure and that we just skip any kind of collision if that isn't the case. It, well, makes our life a bit easier. Now, once I have that, I want to check if there's any kind of overlap. And this I get with sprite.hitbox.collideRect. And now I want to check with self.hitbox. If that is the case, we know there is going to be some kind of overlap. The problem is we don't know where the overlap came from. This is why I talked just a second ago. So here we have an obstacle and the player might be somewhere here. We know the overlap is here. The problem is we don't know where the player came from. The player could have come from here, the player could have come from here, the player could have even come from here and moved really fast. Meaning we have to figure out where this came from. And the best way to think about this is, first of all, you want to separate the dimensions. So we first have, let me call it, we first have horizontal, and after we have done that, we are doing vertical. This is also the reason why down here we split the movement into horizontal and vertical movement. In here, the logic gets much easier. We still have an obstacle, and now the player overlaps again, something like this. But now we only have to check if the collision happened on the left or on the right. Now it's still perfectly possible that the player came this way here and moved really fast. So I want to check the direction of the player, meaning if the player was moving to the right, I know that the collision must have happened on the left. Because if the player is moving to the right, any kind of collision has to happen on the left of the obstacle, meaning this side here. And this is what we have to implement now. First of all, I want to check the direction, and if this is horizontal, then I want to check the player direction. So if self.direction.x is greater than 0. If that is the case, we are moving right, or the player is moving right. As a consequence, if there is a collision, then I want to set self.hitbox.right is going to be sprite.hitbox.left. And besides that, if self.direction.x is smaller than 0, this means we are moving left. Then self.hitbox.left is going to be sprite.hitbox.right. There are two more things we need in here, and that is we have to update self.rect.centerx, so the rectangle the player actually sees, because right now we are just updating the hitbox. We're not updating the rectangle itself, so where the player appears on the screen. And this should be where self.hitbox.centerx is. Finally, for the movement, we have to update self.pos.x. And this I also want to set where self.hitbox.centerx is. And this is the entire logic for the horizontal collisions. All I have to do now is, after we have done all of the movement for the horizontal movement, then I want to call self.collision like this and pass in horizontal in here. And now this should be working. Let's try. If I now, okay, this is getting a bit weird because we spawned on something, but if I just move left and right, we definitely have some collisions. Now if I move up and down, this doesn't work at all. But just by itself, this is looking pretty good. Which means all we have to do now is to also check if direction is equal to vertical. Let me add a bit of white space here. And this is going to be your exercise. Basically, what I want you guys to do is to copy the logic here and apply it on the vertical axis. So pause the video now and see if you can figure this one out. First of all, I want to check if self.direction.y is greater than 0. If that is the case, I know I am moving down, which means I want to set self.hitbox.bottom to sprite.hitbox.top. I guess let me draw what this means. This line here means we are checking if the player is moving down. So the player, like this, is moving down. And now we also know that there has been some kind of collision. The collision object now is pink. I hope it still makes sense. And now we have to resolve this collision. This is happening inside of this line here. We are putting the bottom of the player, this line here, at the top of the obstacle, which means we are moving the player up by this amount. And that way it appears that the player is on top of the obstacle. And it appears like that because it literally is. So next up, we need self.direction.y is smaller than 0. And if that is the case, we are moving up. And this means self.hitbox.top is going to be sprite.hitbox.bottom. Besides that, we also have to update self.rect.center.y, and this is going to be self.hitbox.center.y. And finally, besides that, self.pos.y is also going to be self.hitbox.center.y. And with that, we have the entire collision logic. So let's try. And we do have a bit of a problem because we always spawn outside of this fence, which causes a few problems. So let me move around here. And now if I just move around the forest here, there's lots of things I can collide with. And we do have some problems. So something is not right, and I think I know what it is, because back in the player, I am not calling the collision after the vertical movement. Meaning, let me copy the collision here, and this should be vertical. Now let's try this again. So now we have the same problem. We are spawning right on top of a fence, which causes weird behavior. But other than that, now we have proper collisions. Let's see if this is working. This is looking pretty good. And if I walk through here, I can walk behind the bushes, but I cannot walk through all of the trees. And this is looking pretty good. So I am quite happy with this. Nice, this is working very well. There are two problems we have right now. Number one is the starting position of the player, meaning inside of setup, the player is just being spawned in a random position, which isn't ideal. And besides that, we need some kind of mechanism to prevent the player from moving outside of the map, so like this. And let's go through them one by one. The starting position of the player is the easier thing. And for that, we need tiled once more. If I open this one, there is an entire layer called player. And inside of that, we have a couple of objects, and one is called start. This is a simple node, and this one we can use to set positions. And this is where I want to spawn the player. Which means, back in my code, let me add another comment here. Player is probably the best name for this. Spelling it correctly would also help. What I want to do in here is for obj in tmxdata.get layer by name. And this layer is literally called player. And what I want to check is if obj.name is equal to start. If that is the case, I want to create the player. And the starting position of the player is going to be obj.x and .y. If I run this again, we are starting right in the middle of the map. So this is much better. Now we have to figure out the other kinds of collision. So let me run the game again. I can, for example, just walk through the house, which feels a bit strange. For that, if I open tiled again, there is an entire layer called collision. If I make this one visible, you can kind of tell what's going on. I basically drew a couple of tiles all across the level, and this is limiting the player. This is what I want to import and then use it for collisions. This I am doing inside of level, and let me do it, I guess right before the player makes sense. In here, I want to have some collision tiles, and that is some terrible spelling, collision tiles. Since we are now working with a tile layer again, I want for X, Y, and surface in tmxdata.get layer by name. This layer is called collision. Don't forget, we also need tiles. In here, I want to create a generic tile. And this one is going to need a position, a surface, and a group. What you have to consider here is that for the group, I want to only place it in self.collision sprites. This is the one sprite that is not going to be in all sprites. As a consequence, it is not going to be drawn or updated, but it is going to exist. And since this one isn't going to move, we don't really have to update it. That way, even though we have a sprite with a surface, it is not going to be visible. But besides that, everything else remains basically the same. So I have X and Y, and both of these need to be multiplied with the tile size. For the surface, all I really want to do is create a pygame.surface, and this one should be tile size and tile size. That way, we are creating an empty surface, or well, a black surface with the dimensions of 64 by 64, which is all we need for this sprite. And with that, we should be having collisions. So let me run main.py again. I am not able to walk through the house anymore. On top of that, if I try to walk on the water, I can also not do that anymore. And if I walk further to the right, this one also doesn't work. So this is much better. I guess I can demonstrate what would happen if we added these generic sprites to all sprites as well. So if I add this to self.all_sprites, it would look something like this. So these are the sprites we are actually colliding with. And well, it doesn't feel great, but you can tell what's going on. So this is the entire collision map of the level. But I do not want to show them, so let me undo all of this. There we go. And now we have all of the collisions that we need. In this part, I want to work on the trees so that we can hit the trees and that the trees all have apples. There are quite a few different things we need, so let's jump right in. Here we are back in the code, and I want to work on my trees. Let's get started by giving the trees some apples. For that, first of all, we need an apple surface. This we get with pygame.image.load and the file path here. Let me just copy it to save me a bit of writing. This file path here. Inside of the project folder, we are looking at graphics, and in there we have fruit, and in there we have, if I make it a bit larger, we have the apple. This is what we're importing, a simple image. After that, we need a list of possible positions for the apple. And this we have in the settings. Let me minimize all of this so it's easier to read. We have one dictionary with small and large. And the values here are lists with positions. And these names here refer to small or large trees. And these are positions on the tree where we could have an apple. This I want to create as an attribute. So let's call it apple pos, is going to be apple_pos. That's the dictionary from the settings file. And from this, I want to pick the list that is appropriate. And this I'm getting by using the name. Remember here, the name of the trees is either small or large, and this is why this works. Finally, each of the trees is going to have its own sprite group, which I'm going to call apple sprites. This is just going to be pygame.sprite.group. Now, once we have that, I actually have to use that to create some apples. This I want to do in a separate method that I'm going to call createFruit. We need self and nothing else. And in here, basically what I want to do is for position in self.applePosition, I want to have some random number generator to tell if we want to create an apple in a position or not. Now for that, I am going to need randint. So from random import randint. And now all I really want to do is randint, generating a number between 0 and 10. And if that number is smaller than 2, I want to create an apple. And the apple here is just going to be a generic object. This one is going to need a position, a surface, and a group. All the stuff we're getting from the generic class up here. Let me go through them one by one because we do have to be a bit careful here. Although the surface is very easy, all we need is self.appleSurface. Actually, this should just be apple surface because it's singular. For the position, you might be very tempted to just go with position by itself here. Because if you look at settings, we have a list and this looks like a position. And it kind of is, but it's a bit misleading. The way you have to think about it, if this one here is the entire map of the game, and we have a tree somewhere here, the position that is inside of the list refers to the position on the tree, and the number is the distance from the top left of the tree, not the top left of the entire game. Meaning every time we are creating an apple, we have to add the top left of the game, and then we have to add the offset of the apple. And let's do this separately for the variables. We have x and y. And this I think could actually be a really good exercise for you. Try to get the actual position of the apple. You want to get the position of the apple, the position we already have, and then add it to the top left of the tree and see how far you get. All right, let's do it for the x, and I want to get position 0. That is always the x. This is, let me bring the drawing back up and let me clean it up a tiny bit. This position 0 is basically telling me how far from the left of the tree I want to go. To this, I have to add self.rect.left. And this self.rect.left is the left side of the tree. Meaning this side here is this side. Or in other words, it is this distance here. Combined, we are getting this entire area here. And this is where we want to place the actual apple, at least on the horizontal axis. For the y, this is going to look very similar. We want pos1 and then self.rect.top. And this is the actual x and y position we want. This is what I want to pass in here for x and y. Finally, for the group. I want to have two groups in here. The first one is easy. I want to have self.appleSprites. Besides that, I also want to put all of these apples into all sprites, because that's the only way to display them to the player. The problem is we don't really have those available anywhere inside of this entire Python file. We only really have them inside of the level. So this all sprites. Now, the workaround here is every single sprite has the attributes of what sprites it is part of. And this we can access with self.groups. And these are all of the groups the tree sprite is in. This I do have to call, and this is going to return a list. And from this list, I want to pick the first element. And this first element, if I look at my level where I am creating the trees, this one here, the first element is going to be all sprites. The second element is going to be collision sprites. This is what I'm getting with this line here. So that way I am placing each apple into apple sprites. That's the sprite group of the tree, and then into all sprites. That way they are going to be visible. There's one more thing that we need, and let me put all of this over multiple lines with named arguments. Otherwise, this is going to be very hard to read. This one is groups. And finally, the one thing I forgot is we need a Z position. Fortunately, this one is very easy. We need layers. And inside of settings, inside of layers, we have a fruit layer. This is where the apples should be on. Every time we are creating the tree, I want to call self.createFruit. And this should be working. Let's try. If I now run main.py and look at a tree, we can see quite a lot of apples. This is looking very nice. I am very happy with this. We are definitely making progress. Next up, I want to have the logic that we can hit the player. And let me minimize create fruit. We don't need it anymore. So let me call this the tree attributes. In here, first of all, each tree is going to have an amount of health, which I'm always going to set to 5, but choose whatever you want in here. Besides that, I also want self.alive. And by default, this is going to be true. If this one is false, the tree, for example, wouldn't create fruits, but this is going to come later. Besides that, I also want to have what I called self.stump_surface. And this is what the tree is going to look like if the tree was destroyed. So once alive is false, we want to display a stump surface instead of the tree. And this we have to import with pygame.image.load. And in here, I want to create an f string because we have to decide between two different files. So there's one stump for the small tree and one for the large tree. For both, we have to go up one folder, then to graphics, and there's a folder called stumps. In here, I want to work with variables, and this should be small if name is equal to small, and if that is not the case, it should be large. And don't forget, this should be PNG. This is getting really large, and I made a typo, so let's put this on a separate line. Let's call this the stump path. So I want to get this out of here and paste it in there. And place this stump path in here. And now, don't forget, we also have to convert alpha this one. There's one more thing that we do need, and that is a timer. So I want to have self.invol_timer. It's going to be a timer that lasts for about 200 milliseconds. Why we need this timer, I'm going to visualize in just a second. For now, just follow along. But this is basically all we need for the tree attributes. Now that we have that, I want to create another method. And this I'm going to call damage. Here we need self and nothing else. This method is, well, damaging the tree. So I want self.health -1. And this is going to be damaging the tree. Besides that, every time we're hitting the tree with an axe, I also want to remove an apple. But I only want to do that if there is an apple. Meaning, first of all, I want to check the length of self.appleSprites.sprites. If this list here is 0, there is no point in removing an apple. So I only want to do this if this list is greater than 0. If that is the case, I want to pick a random apple and store it in a variable. And to pick a random apple, I need the choice function. And this one I also get from random. So besides a rand int, I want to import choice. And in here, I want choice, and I want self.appleSprites.sprites. And this random apple I want to destroy with the kill method. So now we just have to figure out how to call this damage method. And this is going to happen inside of the player. Although for that to work, we need a few more things. So let me minimize everything inside of the player. First of all, the player needs to know where all of the trees are. And for that to work, back in my level, let me minimize all of these methods as well. I want to create another group. And this I called self.treeSprites. Again, this is just going to be pygame.sprite.group. All of the trees that I am going to create, which happens down here. Each tree is supposed to be in all sprites, collision sprites, and also in self.treeSprites. Really important here, make sure that self.allSprites is the first sprite inside of the list. If that is not the case, then inside of createFruit, this line here would not work anymore. So be careful here. But now that we have that, I can minimize the setup. Actually, I can't because I have to pass into my player, this one here. Let me put all of this over multiple lines because this is also getting really hard to read. We have a position, we have a group. I think it was a singular group, right? Yeah, just group. Besides that, we have collision sprites. And finally, I want to add one more parameter, and this is called trees. And this is going to be self.treeSprites. And now inside of the player, in the init method, I want to create tree sprites. Next up, I have to convert all of this into an attribute. Let me put it all the way at the bottom here. And let me create another section that I call interaction. There are going to be quite a few things we need to interact with. But in here, I want to have myself.treeSprites, and this is going to be the treeSprites parameter. Now we have to figure out how to actually target this thing. And this is going to happen inside of useTool. Remember this we created ages ago, about 2 hours by now. But this method is being called every time we are using a tool. And in here, I want to check what tool we are currently using. So if self.selectedTool is equal to, let's start with a hoe. If that is the case, I want to pass for now. Besides that, I can duplicate this line. I want to check if the selected tool is an X. And this is what we want to work on in this part. But for now, let me add a pass in here. And finally, I also want to check if our selected tool is water. Although in here, for now, also going to be a pass. If we are using the X, I want to check for tree in self.treeSprites.sprites. Don't forget to call it. And now I want to check if we are actually hitting the tree, which means if tree, and now I have to figure out if we are actually hitting the tree. The problem is I don't really have any way to know which point I'm actually targeting. Meaning, let me comment out all of this for now, and let me run the code. And I'm getting an error because I didn't import the timer. So from timer, import timer. Now let's try this again. We are getting another error that the player, this is probably happening in level, this should be tree_sprites. Now it's working. Right now, I can use the different tools, and this is working perfectly fine for all of them. The issue is, right now, we have no idea which point we are targeting. For example, if I'm using the X, I want to know that I am basically targeting this point here. Let me use the X again. This looks about right. And this point I have to get in my code. So back in my player, let me minimize the init method. And in here, I want to create another method that I'm going to call get_target_position. And all I really want to do in here is I want to create another attribute that I'm going to call self.targetPosition. This is going to be the same for all of the tools, which makes it quite easy to work with. And the basic logic here is if this is our player and this is the center of the player. For each of the tools, for example, if the player is looking to the left, then I want the tool to be somewhere here. A certain distance to the left of the player and a bit further down. The reason why I have to move it down is because most of the tools, like the X for example, they go in this direction here. Basically, what I want to do, I want to get self.rect.center, and then I'm going to need some kind of offset. And this offset I am getting from my settings, because in here we have player tool offsets. And these are a bunch of offsets that we can work with. Meaning this is what I want to copy, paste it inside of the player. And now we have a dictionary that we want to take some information from. Notice here, the keys are called left, right, up, and down, which is the same as the status of the player. Which is very handy because now we can get self.status.split. And as always, we want to split it wherever there's an underscore and then pick the index 0 of that list. And this is basically all we need for this one method. I guess importantly, do not forget to call it right after the timers, so self.get target position. Now, the problem is that this target position is going to be really hard to see. At least for now, for testing purposes, we do need some way to visualize it. And I just realized this should be status, not stats. And since this isn't something the player is supposed to see, we can just do this really quick. So for testing purposes, back in level.py, all the way at the end of custom draw, I added a tiny bit more code that looks like this. If you go through this, basically what we are doing is we are drawing a rectangle, another rectangle, and a circle. The result is going to look like this. This is telling us the red line is the rectangle of the player. The green line is the collision rectangle, and the blue dot, this one here, is the target position. So if I use a tool, you can kind of see where it's going. And this also works with the axe and with the watering can. And well, this way you can play around with this quite a bit more. Although for the actual game you don't need it, so most of the time you're just going to comment it out or remove it entirely. But I guess let me keep it for now, because now we know that the target position, so the blue dot, looks pretty good. Now with that, we can uncomment this part here. And now for the tree. I want to look at the rectangle of the tree, and I want to check if this tree is colliding with a point. The point that I want to check is self.targetPosition. If that is the case, I want to get the tree and then run the damage method, which is this damage method here. Let's try if this is working. So back in the game, we are already getting a problem because even if I don't use the axe, the apples all disappear, which I guess kind of looks cool, but not ideal. Also, this one should be commented. One of the main reasons why that happened is if I open the timer again. In here, this line is causing the problem because there is a chance that our current time minus the start time is bigger than the duration. So this could run forever. And as a consequence, we might trigger this function by accident. And a really easy way to fix that is to add another end statement here that we want to check self.startTime is different from 0. And now let's run main.py again. And now if I am colliding with a tree, nothing happens. And if I use the axe, also nothing happens. Let's try different tools. Okay, nothing happens in general. And the reason why that is happening inside of timer, every time we are deactivating the timer, we're setting the start time to 0, meaning this is not going to run. Deactivate has to be after this if statement. And now inside of the player, let me just print tool use, just to try if this is working. So now, if I use the axe, I can see tool use in the bottom left. And I guess now we can try to hit a tree. There we go. The apple disappeared. And this is working quite well. And let me close the timer again. Now we are done with it. Back in the sprites, I want to have another method that checks if the tree is still alive. So check def. And basically all I want to do is if self.health is smaller or equal than 0, then the tree is going to die. Let me just print dead. We just have to figure out when to call checkDef. In my case, I went with an update method that needs self and delta time, like any update method. And then here, I'm going to call self.checkDef. Actually, to be a bit better here, we only want to check def if self.alive is true. And now, let me run main.py again. If I hit a tree with my axe, we get tool use, and now we get dead. This is looking really good. Which means what we can do in here now is I can set self.alive to false. Although there are a few more things that I do want to change. First of all, self.image. So what the sprite actually looks like should be self.stump surface. And since we are updating the image, we also have to update self.rect. This I get with self.image.get_rect. And I want to place the mid bottom should be wherever the previous self.rect.mid bottom was. What that means is if this one here is the original tree and we want to create a tree stump that is a bit smaller. We now have to figure out in this line where we want to place this rectangle. Finally, we also have to update the hitbox. And this we get with self.rect.inflate. Actually, I think good practice here is to copy the entire thing. And now in here, we are going to need a width and a height, or an X and a Y, basically the same thing. For the tree stumps, I always went with -10 and negative self.rect.height and multiply this by 0.6. Let's try. So if I now go to a tree, hit the tree a few times, there we go, we have a tree stump. I can do this with the other tree as well. And we get a different kind of tree stump. And this section is getting quite long, so let's finish it now. But in the next section, we are going to finish up the trees. We are nearly done with the trees. There's only one more major thing that I would like to add, and that is some particle effects. So that when an apple disappears or when a tree disappears, I want to show some white object that flashes on the screen. You'll see in a second what I mean, but it looks quite nice. Once more, here we have main.py, and I want to work inside of the sprites. Inside of the tree in here, whenever one of the apples disappears, that happens here, I want to basically create a white apple on top of the disappearing apple. That way, we're indicating which apple disappears. Also, whenever the tree dies, which happens inside of this method here, I want to do the same thing for the tree. So for a couple of milliseconds, we have a white tree, and then we can see the tree stump. Both of these are being created with another class. Let me create it right here, and I'm going to call this one class particle. This particle is also going to be a generic sprite. So it inherits, like all of the other sprites, from the generic class. In here, as always, we are going to need the dunder init method. We need self, we need a position, we need a surface, we need the groups, and we need a Z layer. For the parent class to work, we need the super and dunder init method. This one for generic add position, groups, and the Z layer. Meaning I can copy them in here, and most of them we don't really have to worry about too much. As a matter of fact, if you look at this closely, those parameters and those arguments are basically identical. The only thing I really want to change is I do not want to have the default argument. Now, the way this particle is going to work is, it is going to be a sprite, but this sprite is going to self-destroy really quickly. It basically has an internal timer. Let's create this one actually right now. We can use the update method here, and this one needs self and delta time, just so that we capture delta time. In here, let me save it as the current time. The current time I'm getting with pygame.time.get_ticks. Once I have that, all I really want to do is if my current time minus some kind of start time, we'll create that one in just a second, is greater than a certain kind of duration. If that is the case, I want to destroy this sprite. That way, we are only showing this sprite for, let's say, half a second, and then it disappears. Besides that, this particle is always going to have the same surface as, for example, a tree, except it is going to color the entire thing white. And that way, we have some kind of particle effect. It's a fairly minimal one, but it does the job for this game. We need to do two more things. We need to get a duration. And this one, I should have put in the init parameters, so in here duration, and I do want to have a default value, let's say 200. Now that we have all of that, I want to create self.startTime, and this one is pygame.time.get_ticks. I suppose I should mention the difference between this start time here and this current time is that the start time here is only being taken once. It's basically 1 point in time, whereas the current time is being continuously updated, meaning from this point here, we are checking another current time, another current time, another current time, and so on, and at some point, we are hitting the duration, meaning that this distance here is greater than the duration, and then we are destroying the sprite. Besides that, I have to store my duration as an attribute, and this I just get from my duration. And this is the basic setup. Besides that, we need to create the white surface. And this we are doing via a mask. For that, I want to create a mask surface. This I'm getting from pygame.mask.from_surface. This one needs one surface, and the surface we have is self.image. Now, once we have that, I want to create a new surface. And this new surface we get with the mask surface and then to_surface. This new surface now is going to be a black and white silhouette of the original self.image. Any pixel that had any kind of color value is going to be white, and any kind of transparent value will be black. I can visualize this in just a second actually. But what we need to do now is to get rid of all of the black color values, which we do with new surface, and we have to set a color key. The color we want to get rid of is going to be black. So a tuple with 0, 0, and 0. And this new surface I want to set as the image of this sprite. There we go. And this should be all we need for the entire class. All we have to figure out now is when to create it. And this happens, for example, inside of the tree. For example, when we are destroying an apple, I want to play this particle effect. Let's do it right below the random apple. I want to create a particle. For this particle, I want to have not these parameters, I want to have these parameters. I suppose for simplicity, we could get rid of the duration here, because we're not going to need it for now. And, well, now we have to figure out a position, a surface, groups, and a Z. And I think this could be a really good exercise. Try to pass in all of these arguments and see if you can create this particle effect. It should already be working once you have created it. Let's put them all on separate lines so I can work with named arguments, and that should make all of this much easier to read. First of all, we need a position. We already have the random apple we want to destroy. I want to get this random apple, I want to get the rectangle of this random apple, and then I want to get the top left. Because this particle should be in the same position as this apple. Along the same lines, it should also have the same surface, so random apple.image. For the groups, we need to do basically the same thing we have done for the apples. Which means I want to have my self.groups, don't forget to call it, and now I want to have the element with the index 0. Now looking at all of this, since we are doing this quite often, it might be a good idea to put a reference to the self.allSprites inside of the tree. But you can do this in your own time. It isn't going to make much of a difference. Finally, for the Z parameter, I also realized it doesn't really have a separate layer, but you don't really need one. You can put it inside of the fruit. It could also be inside of raindrops. It honestly doesn't matter at this point. Let's go with fruit. I guess it fits in there quite well. We need layers, and in there, I want to have the fruit. And with that, we should be having a particle effect. Let's try. If I run out of this, it still runs. That's generally a good sign. And let's use this tree here. And there we go. We have a very basic particle effect. It is indeed very subtle, but it certainly does work. Let me minimize the damage method, and now we want to do the same thing for the tree once the tree is being destroyed, which we can also do quite easily. Once again, I want to create a particle, and now, once again, let me get all of the parameters we need. And I guess for this one, we can also change the duration. So in here, I want to have all of these arguments. The position is going to be self.rect.top left. The surface is going to be self.image. Spelled correctly would be good as well. Then for the groups, once more, self.groups with the index 0. And for that, I want to have layers. And I guess we can put this on the fruit layer as well. Since this is a slightly larger object, let's go for a duration of 500. And this should be all we need. Let's try this one now. And this one is only going to play once the tree is dead. So we have to hit the tree a couple of times. There we go. I guess the effect is a tiny bit long. Let's go with 300. Let's try this one. Although at this point, this is quite subjective, so you can just go with whatever you think looks best. And yeah, I think this is okay. And with that, we have some basic particle effects. And these we can also reuse later on for the plants, which is very nice. Which means we have covered another major section. To finish off the tree, we have to create a player inventory, so that the player gets an apple or some wood whenever we hit a tree. Which means we have to connect the player and the tree with each other, which is a fairly straightforward thing to do. So let's jump right in. Once more, we are in the code, and first of all, we have to look at the player. Specifically inside of the init method, let me put it above the interactions, and right below the tools and the seeds. This one I want to call inventory, because if you want to add something to the player needs to have some kind of system to store data. And for now, the player is only going to have a single dictionary, and this I call item inventory. Although later on, there's going to be a bit more. And in here, we're going to have a couple of different key value pairs. Let me copy them in actually, so you don't have to watch me write. We have these four. Wood and apple is what the player gets from the trees, and corn and tomato is what we're getting from the soil. By default, all of them are going to be 0, and let me line them up a bit nicer. So this is looking better. And these numbers we want to increase whenever the player, for example, gets a piece of wood or an apple. Which means we have to connect the player, all of this here, with the tree. And since they are in different files, we have to work via the level to make all of this work. And let me minimize everything so we're not getting lost. Right now, the level only has 3 methods, even though it is quite a chunky class already. But I want to add another method in here. And this one I'm going to call player_add. Besides self, we are going to need an item. So the item we want to add to the player. What is going to happen in here is I am targeting the player. I want to get the item inventory of the player, the one we just created. From the dictionary, I want to get the item. This would be one of these key value pairs. And this I want to increase by 1. I suppose you could make this a bit more flexible by adding another parameter That would be the amount, for example, but in my case, I will always stick with 1 because I do want to keep things simple, and this tutorial is already getting quite long. This method I have to pass into the trees, which means inside of setup, when I am creating the trees. This happens here. And once again, let's do this over multiple lines with named arguments, so we are not getting completely lost. We have the groups, and finally, this one was called the name. The one additional argument we want to add is, let's call it player add. And this is going to be self.player_add. Make sure here not to call it, because we only want to call it from inside of the tree object. Which means inside of the tree, we're going to need another parameter, player add. And this one we also have to store somewhere in the attributes. Let's do it here. And self.player_add is going to be player add. Now that we have that, when we are damaging the tree, this stuff here, I want to run self.player_add and give the player an apple, which should be all we need. I guess inside of the level in the run method, all the way at the bottom, let me print self.player.item inventory, so we can tell what's going on. If I run this now, you can see in the bottom left the inventory of the player. And if I now hit a tree, we have 1 apple. This I can do multiple times. We have 2 apples, 3 apples. That is looking really good. So that is basically all we need for the apples. The one last thing for the tree we have to do is whenever the tree dies, we have to give the player some wood. And this could be a fairly easy exercise for you, so try to figure this one out yourself. I hope that this one is fairly easy at this point. All you need is self.player_add, and in here you have to add some wood. Let's run all of this again. And for this one, I have to hit a tree multiple times. There we go. Now we have 1 wood. This is working very well. With that, I can get rid of this print statement here and minimize the run method. In fact, I can minimize all of these methods so things are easier to see. And with that, we are basically done with the basic tree. Although the next section is we have to make sure that the trees get new apples once we are sleeping, which means we have to work on the logic to start a new day. But that is going to be the next section. So let's start to work on restarting the day. For now, all this means is all of the trees are getting some new fruits, but later on there's going to be quite a bit more. Besides that, we also have to work on some transitions, but let's do all of this straight in code. It isn't so hard, it's more an organizational thing. But let's have a look at all of this. Alright, once again, we are inside main.py, and let's start by talking about what we need. Basically, I want to start a new day when I stand here, or when the player stands here and presses enter, so right next to the bed. Which means we have to check an input, and we need to check if the player is on top of this carpet, or at least inside of this area. For this, I already have some basic setup inside of tiled. Let's have a look at that. Here we have tiled. If I zoom in, there is one object that is called bed that is right next to the bed. This is an empty area that I want to import. And if the player is inside of this area and presses enter, then I want to start a new day. Once again, if you want more detail on tiled, check out the dedicated video. Now, this I want to import, but for the import, I need another dedicated sprite. That sprite, let me put it right here, I have called interaction. Once more, this inherits from the generic sprite. Although, other than that, it is going to be fairly simple. We have an init method as always, and in here we have self, we have a position, we have a size, we have the groups, and finally we have a name. We do not need a surface in here for the simple reason that this kind of sprite is never visible anyway. Speaking of, we can just create the surface in here, and the surface we are creating with pygame.surface, and we're passing the size in here. That is the size we're getting from the parameters. Other than that, I have to call the parent init method with super_dunder init and pass the surface, the position, and the groups in here. The Z position really doesn't matter because, again, this is not going to be visible, so we can just leave it as it is. Finally, we have to get self.name and store it as an attribute. The name, if I open tiled again, is what you can see on the left side here. We have a name. Besides the bat, by the way, this is what you are going to see in quite a bit. We have the trader. Meaning, if the player stands inside of this area and presses enter, we want to open some kind of menu for trading. But, well, that is something for later. For now, I just want to work with the bat. But other than that, we have finished the entire interaction class. Wasn't actually so bad. Now we have to import it. This happens inside of level, inside of setup. In here, this is getting quite extensive. The layer we want to work in is the player layer. Let me add a bit of white space here, because this is the same layer where we have the player. Except now, I want to check if obj.name is equal to bat. If that is the case, I want to create the interaction sprite. For that to work, I need to import it, meaning all the way at the top, after tree, I want to have the interaction sprite. Now back in here, let me copy all of the parameters we need. We need those 4. And all of those should be fairly straightforward. For the position, we need the same thing we have seen for the player. So obj.x and obj.y. I can just copy paste them. And for the size, we're doing something fairly similar. Except for x and y, we need width and we need height. For the group, I actually want to create a whole new group. Let me do it all the way inside of the init method. This one I've called self.interaction sprites. But this is, once again, just another pygame.sprite.group. Self.interaction sprites. We don't need self.allSprites here because, again, this kind of sprite is not going to be visible. Finally, we need the name of this kind of sprite. You could write just bat in here, this would be perfectly fine. Alternatively, you could also use obj.name. You would be getting the same result. And with that, we have an area. Next up, the player needs to know about this area, because right now, these interaction sprites only exist inside of the level, and the player has no idea about them. As a consequence, for the player, which is right on top, I want to add, let me call it interaction. And this is going to be self.interaction sprites. That way, the player has an attribute to know where these interaction sprites are. So with that inside of the player, we are going to need one more parameter, interaction. This I want to store below my tree sprites, and let's call it interaction is going to be interaction. With that, the player knows where these kind of sprites are. All we have to do now is check if the player is inside of this area and presses the enter button, which we are doing. If I minimize all of the methods, this is going to happen inside of input. All the way at the bottom of this method, I need another if statement. If keys are pygame.k_return. This is telling me if the player has pressed the enter button or not. After I know that, I want to know if the player collided with the bad sprite, for example. And this I want to store in collided interaction sprite. This we are getting with pygame.sprite.sprite collide. And in here, we need 3 arguments. We need a sprite, we need a group, and we need what is called doKill. The sprite in this example is just going to be self. And we want to check the sprite, so the player sprite, against all of the interaction sprites, which we get with self.interaction. DoKill is supposed to be false, and basically what it means is if the player, which is self in this example, if this one collides with the sprite inside of this group, do we want to destroy this sprite? Which in this case, we don't want to do, which is why this one is going to be false. And now that we have that, I want to check if collided interaction sprite exists in the first place, or rather if it is truthy, because that is only the case if it has a sprite inside. If that is the case, I want to check my collided sprite, the first item inside, that can only have a B1, and of that, I want to check the name. That is the name we have created here. If this name is trader, for now, I want to pass, but later on, we are doing something else in here, obviously. If that is not the case, which means we have the bad, then I want to do something else. One thing I do want to do in here is add self.status is going to be left idle. The main reason for that is if this is the player and we have the bad here. If the player presses enter, I want the player to point towards the bad. It would be kind of weird if the player looked to the right, then we press enter, and then we start a new day. It's kind of feeling bad. Let's try this one actually. It should be working. And we're getting an error that element property with does not exist. Do you mean with? This happened inside of the level, and here we need with. Now let's try this again. This is looking better. And now if I look to the right and press enter, the player is looking to the left. So this is working. Very good. With that, we can tell if the player is next to the bad and pressing enter. So with that, we can actually start working on the day transition. For that, we have two elements we need to cover. First of all, we have to basically restart the level. In our case, this just means all of the trees are going to get some new apples if they are still alive. Besides that, we also have to place some kind of transition that indicates we have a new day. Let's start by resetting the entire level, which is going to happen inside of level. And I really want to hide the setup method. This one is really large. And all of the reset logic should be in a dedicated method called reset. This one doesn't need any parameters. And in here, we basically want to reset everything, which for now is just going to be the trees, or rather the apples on the trees. The way I approach this, I first of all have to get every individual tree, which I get with for tree in self.treeSprites.sprites. In here, we actually have not too much work to do, because if you look at the tree, we have a dedicated function. If I minimize everything, we have a function called createFruit. And this one creates all of the fruits that we need. Meaning all we really have to do is call tree.createFruit. Although now we do have a problem because we are not destroying the existing apples. That, however, is quite easily done. All we have to do is for apple in tree.apple underscore sprites dot sprites. Don't forget to call it. And I want to destroy with the kill method all of the apples. With that, we are getting rid of all of the apples and we are creating new apples, which is basically a reset. What we now have to figure out is when to call this method. Because remember, we are updating the level inside of the player, not inside of the level class itself. Which means I have to connect the reset to the player. Although there's going to be another problem, because besides the player, this reset also needs to be connected to a transition effect. How that is going to work is basically the entire screen is going to go dark, then we are resetting the level, and then we're making the screen go back to normal. Inside of this transition, reset is going to be played here, which means we need a system where the player, the level, and the transition all work together. And this, well, let's go through it step by step. First of all, inside of the player, for the init method, I want to have one more attribute. This I called self.sleep. By default, this one is going to be false. If the player now presses enter and goes to bed, all the way down here, I want to set self.sleep to true. That way we know if the player is sleeping or not. And this we can use to start a transition. That is going to happen inside of the level, inside of run. All the way at the end, I want to check if player, this should be self.player.sleep. Then I want to do something like self.transition, this one doesn't exist yet, .lay. And this one is going to need delta time. Now, this transition is going to be a separate class, and this class is going to call the reset method once we are in a certain point of the transition animation, which basically means inside of the init method, I want to create self.transition. This is going to be a transition class we will create in just a second. And this one is going to get self.reset. And it's going to get self.player. With that, we can actually create this new class. Let me save it as transition.py. Once again, we have to import Pygame for the obvious reasons, and we need from settings import everything. The class we want to create is called transition. No need for inheritance, but I do need a dunder init method because this one needs self, reset, and the player. Inside of this, we first of all need to get the display surface because we want to be able to draw on the level itself. This one we get with pygame.display.get_surface. Besides that, we have to capture the reset method inside of an attribute. And we have to do the same thing for the player. Let me call this part here setup. And besides that, we are going to need an overlay image. For the overlay image, we are basically going to create a black image, and then we're going to change the transparency, or rather the blending mode, but in this case, this is going to be the same. I'm going to explain this as we implement it. But first of all, I need self.image, and this is going to be pygame.surface, and the dimensions here we are getting from the settings because I want to have the screen width and the screen height. Let me copy this screen width, paste it in here, and the second one should be screen height. This right now is giving us a surface the size of the entire window that is entirely black. Besides that, I also want to have self.color. This one is 255 by default, and then self.speed. This one is going to be -2. How these two attributes are going to work, I think the best way to explain this is let's use them right away. So I want to have some kind of play method that needs self. And in here, I want to self.color plus equal self.speed. And that information I can use to fill my image. So self.image.fill. And in here, I need an RGB tuple. We need red, we need green, and we need blue. In this case, since we only care between a black and a white color, they can all be the same color. This image I now want to blit on top of the entire game, which means self.displaySurface.blit. I need self.image. The top left should be at position 0 and 0. And for now, let's just leave it like this. And play it because you're probably confused at this point. Things are going to make a lot of sense in just a second, or at least I hope they will. First of all, for all of this to work, we have to import from transition import transition. That means this one here is going to work. And now inside of the run method, player.sleep is also going to work. Although here, that's a time we don't actually need. Now with that, let's try main.py and let's press enter next to the bat. And we're getting some very strange effect, and we're getting an error message. Let's try it again, really quick. If I run this, first of all, we get white, and then we go darker and darker. And that is exactly what I wanted. The entire logic is going to happen inside of play. In here, self.color on the first frame is 255, which with the fill method here means we are turning the entire image white. All of these self.colors are 255, and those are the values for pure white. And if you put this on top of the display surface, we are getting a white image. However, now we are updating in this line the color, which means on every single frame, the color is going to be a tiny bit darker. Because of that, we started with a white image and it became darker and darker. And at some point, this self.color got negative, and this is where we got the error. And this doesn't seem very much right now, but we can make this look much better by adding another argument inside of the blend method. The argument we need here is called a special underscore flags. What we can do with this is set the blending mode. The one we want is pygame.blend underscore RGBA underscore mult. And now if I run this and try the same thing again, now we have a much nicer transition. How this blending mode works, it basically gets rid of all of the white values. So the brighter a value is, the less visible it is going to be. And the pure white value is going to be completely invisible. That way, at the beginning, we are not seeing any of this image, but the darker it gets, the more we see of it. And at some point, it turns the entire screen pure black. Although right after that, the entire thing crashes. That we do have to work on. Fortunately, it's not that difficult. All we have to do is if self.color is smaller or equal than 0, and if that is the case, I want to set self.speed and multiply it with -1. Besides that, if self.color is greater than 255, because now after these two lines, we are increasing the color continuously. And at some point, it's going to be greater than 255, which is also going to be a problem. We do need to limit that one as well. If that is the case, at least for now, I want to set self.color to 255. And with that, we should be having a transition. Let me play main.py and let's see how this is going to look. We are still getting an error. Let's have a look. I guess the main reason here is that once we get below 0, we are only changing the speed, we're not changing this number. And as a consequence, for this one frame, things are falling apart. But that we can fix quite easily. All we have to do is set self.color to 0. With that, it should be working. If I now walk next to the bat, and this is working really well. We are very nearly done. There are 3 more things that we have to do. Let me write them all the way at the top. Number 1, we have to call the reset method. Number 2, we have to wake up the layer. And number 3, we have to set the speed to -2 at the end of the transition. I am pretty sure you can already tell where this is going. This is going to be your exercise. Work through these 3 parts and try to implement them yourself and see how far you get. The reset method I want to call when we are reaching this point here. All I have to do is call self.reset. because reset we have stored here, and this is the one we created in level.py. And this is all we needed. Let's try this one actually. I created it but never tested it. Meaning now, let's have a look at some trees. You can see we have 2 apples on most of those trees. And now if I go to bed and look at the trees again, they are looking different, which means the reset method has worked. Next up, we have to wake up the player. That should happen once the entire transition is over. All the way at the bottom, self.player.sleep should be false. On top of that, while the player is sleeping, I don't want the player to be able to move. That would be kind of weird. This happens inside of the player, and all the way at the top here, I only want to allow any kind of input if we are not using a tool and if we are not self.sleep. This one we can also test quite easily. Now, if I press enter, I will try to move to the left. And I tried, and now I can move again after a couple of milliseconds, meaning this one is working as well. Finally, we have to set the speed to -2 at the end of the transition. This is also going to happen at the bottom. All we have to do here is set self.speed to -2. With that, we are done. This is the entire transition. I guess we should probably try this a couple of times, but this is working once. If I try again now, and this is working again, and it keeps on working just fine. With that, we have a daytime transition. And this one is going to update all of the trees as well. Later on, once we have plans, we are also going to make updates to those. And that, I guess, we can actually start working on next. With the trees finished, we can start working on the soil. And there is going to be a ton of logic in here. Basically, what we have to do is we need one class that covers all of the soil, and this class has to be connected to all of the watering and all of the plants, which is going to be a very chunky Python file. Just to warn you, probably for the next hour, maybe 2, we are going to work just on the soil. You have been warned. But for now, just to get started, let's create the very basic logic for the soil. So if the player uses the hoe, we want to create one soil tile. Once again, I am inside my project and I want to create a new file that I'm going to call soil.py. In here, I have to import Pygame, and I need from settings import everything. With that covered, I want to create a new class called soil layer. No need for inheritance, but in here, I want to have a init or dunder init method with self, and for now, all sprites. Because in here, each of the soil patches is going to be a dedicated sprite. And to make them visible, we have to attach them to all sprites. As a consequence, we do need them available inside of the class. Inside of this class, I want to add one section. Let's call it sprite groups. And in here, I want to have self.allSprites as my all sprites. Besides that, since I do want to have easy access to all of my soil patches, I want to create another attribute that I call self.soilSprites. And this is just going to be another pygame.sprite.group. After that, we are going to need graphics. And for now, this is going to be very simple. We have a single self.soil_surface, and this is something we are going to import. Here we have the project. I want to go to graphics. In there we have the soil. And in there we have a bunch of different things. For now, all I want to import is the file called O. What all of the other files do, you will see in the next major part. For now, just don't worry about them. It's honestly better for you. Meaning all I want to do is pygame.image.load. The path we need here is one folder up, then graphics, then we need soil, And in there we have o.png. With that, we do have a setup, but now we do have a couple of problems. First of all, not every single tile in our map should be farmable. Let me demonstrate this in tiled actually. Here's the entire level, and I think it should be quite obvious that not every single tile here should be farmable. In fact, I only want this area here to be farmable. This is also going to exclude the house and the path. None of these should be farmable, only the stuff that is inside of this area. I hope you can see what I'm talking about. For that, there is a whole other layer called farmable. If I make this one visible, you can kind of see what I am talking about. Only the pure green tiles here should be farmable, meaning this is what we have to import, and then only if the player hits one of these areas, only there we are going to create a soil tile. However, now we do have another problem, and that is that we have to manage quite a bit of data. And this I want to address early because it is becoming really important. Basically, later on, for every single one of the tiles, we have to check a couple of different things. Let me add a couple of comments here in terms of what we need. So requirements for each of the tiles. We need to know if the area is farmable. That's the thing you have just seen. Besides that, later on for the plants, we also need to know if the soil has been watered, and we have to know if the soil has a plant already. For example, if we want to plant a new plant, we cannot plant that new plant if the soil patch has a plant already. I hope that sentence makes sense. Meaning we need to have quite a robust way to manage all of this data. As a consequence, I'm going to store all of this information in one grid. That for now is only going to store if we have a farmable area or not. But let's do all of this in a separate method that I called create soil_grid. In here, we don't need any parameters. And in here, I want to create one list that contains other lists and one list for each tile of the game. Let's do this in tiled actually. So when you look at these specific tiles here, each of these cells is one tiled. And in the grid I am going to create, every single tile is going to be one list. And this list is going to contain a couple of different pieces of information. The one we're going to care about now is if it is farmable or not, which I'm going to do by just adding a capital F inside of the list if it is farmable, and well, there's not going to be an F if it's not farmable. That way we can always tell which one we have. Although to create this, we first of all have to know how tall the map is. For that, I have to import the background image or the floor. This one I get with pygame.image.load. The file path here is one folder up, then we have graphics, then we have the world, and then we have ground.png. This one we don't have to convert because we're not going to show it to the player. Instead, what I want to do, I just want to know how many tiles we actually have in the entire thing. I want to know how many horizontal and how many vertical tiles we actually have. This information I get by simply taking the whole width and dividing it by the tile size. For example, for the horizontal tiles, I want to get my ground and then get underscore width and floor divided by the tile underscore size. This I also need for the vertical tiles. And this I can all do on one line. So v tiles in here. And this one I get with ground.get underscore height. Although this one also has to be floor divided by tile underscore size. I guess while we're here, let me actually print the h tiles and the v tiles. Also, I do want to call this method here in the init method. So self.createSoilGrid. Although, first of all, I do want to create this soil file inside of my level. That way I can show you what the progress is while we are making it. That should make all of this easier to follow. All I really want here is from soil import soil layer. This soil layer should become an attribute. Let's call it soil_layer. And here, soil layer. Really important, we have to pass in one argument, and that is going to be all sprites, which we get up here. And now, if I run all of this, we can see we have 50 horizontal tiles and 40 vertical tiles. Which, if I look at tiled and look at map and map properties, we have in the top left the width and the height. And this is 50 and 40. So this one is working just fine. This I can now use to create a list of lists with every single tile being one individual list. This is going to happen inside of soil.py. And what I want to create is self.grid. This one we are going to do with list comprehension. And let me add a bit of white space in here because this one gets slightly more complicated. First of all, I want to go through every single one of my columns. And I want to create an empty list for my column in range age tiles. Although this is only a single one, so I'm going to put this in another list comprehension, which is going to be for row in range v tiles. Now I can get rid of the white space. And let me just print what we actually get. So self.grid, run all of this, and we are getting a very long list of lists. The entire thing is one long list. Inside of this list, we have one list for each row inside of the game. And then inside of this row, we have one more list for each individual cell. Now that we have that, we have to actually check inside of tiled. Let me open it again. We have to know which of these tiles are farmable. And for that, we need pytmx again. Meaning I want from pytmx.util_pygame import load_pygame. Once I have that, I want to use load pygame and load my tmx data file. That I get by going up one folder. There we have data. In there we have map.tmx. Since we are only going to use this once, I can use a method straight away, and that is get layer by name. The layer we need is called farmable. And on this one, we want to get the tiles, because this one allows us to use all of this inside of a for loop. Meaning in here, this is the one we have already seen. We have for x, y, and a surface in load pygame. Although for this one, we don't really care about the surface, meaning I'm going to use an underscore to just ignore it, or to indicate that I don't care about it. What I now have to do is to figure out which of these grid cells corresponds to the x and y values, and then add a capital F for each of those, which is honestly very simple. All I need is self.grid. And first of all, I need the row, which is the y position. This is going to give me another list, and on this list, I want to get the x position, which is the column. And now I'm getting a list, and I want to append a capital F to that. That is basically it. If I now print self.grid and run all of this, we are getting an even stranger list. What we're seeing in here is every single cell where we have a capital F, this cell can be farmed. What you should be seeing here actually is the first couple of lists should be entirely empty, because on the top of the map there's nothing farmable. And we only get a bit further down an actual F tile. I suppose we can make this a bit easier to read by going for row in self.grid and then print the row. If I now run all of this, this is, well, still very difficult to read, but you can see it a tiny bit better. This one here is the first row, there's nothing, and this continues for a couple more rows, quite a few actually. And at some point for this row here, we have a couple of empty cells, and then we start having 4 cells that are actually being farmable. If I look at this inside of tiled, you can see on the first row, we have a lot of nothing, and then we have 4 cells that are going to be farmable, which is a pretty good sign that this is going to work. I guess for one double check, on the next row, we have a couple more cells that are farmable, and then we have a gap and a few more cells. Let's check this one out. On the next row, we have a gap, then we have 6 farmable cells, then we have another gap, and then a few more farmable tiles. So this is looking pretty good. With that, we have a grid that can store at least 1 bit of information. It is going to get a bit more complicated later on, actually. What we now have to figure out is how the player can hit all of those with the hoe. For that, I want to create another method, and this I called createHitRects. No need for any kind of parameters here. And what we are going to do is for every single tile, we are going to create a rectangle that the player can hit. This I'm going to store in self.hitRects, which is just going to be a list. And now I have to cycle through my self.gridList and convert all of the cells into actual positions. And for that, I am going to need the enumerate method. Let's go through it slowly. I first of all want to get for row in self.grid, and inside of that, I want for cell in row. Let me give a bit of white space here to explain what is going to happen. We essentially have a list that is going to contain, let me draw it really quick. So we have a couple of lists, and inside of each list, we have a few more lists. The first for loop, this one here, goes through all of the lists, and then the inner for loop, this one here, goes through these lists here, which is basically horizontal axis. The problem we have right now is we need to know on what list we are on. For example, we have to know that this one is list 0, this one is list 1, this one is list 2, and so on. And for that, we need enumerate. I want to put both of these inside of an enumerate function. That way, we are first getting the index we are on, and then the actual information. Let's call this one the index row, and the second one I called the index column. Inside of this, we can actually check every individual cell, and I want to check if F is inside of this cell. If that is the case, I want to create an X position, I want to create a Y position, and then I want to create a rectangle. And this rectangle I want to append to myself.hitRects.append.rect. And now for the position and the rectangle, I think this could be a really good exercise. I hope you're not entirely lost at this point. But try to figure out, we are now creating a couple of rectangles, and for each rectangle, we have to convert the position in the grid to an actual XY position inside of our game. So try if you can figure this one out. We know where each cell is inside of the grid. We also know what the tile size is if you want a hint. But pause the video now and try to figure this one out yourself. This is actually fairly simple. All we need for the X position is the index column, multiplying it by the tile size. For Y, this is going to be the index row, also multiplied by the tile size. Finally then, for the rectangle, we have Pygame.rect. And in here, we need X, we need Y, and then we need the tile size and the tile size. Meaning for this rectangle, X and Y is the top left, and the tile size is always going to be 64 by 64. And that way, we have a rectangle created for every single cell that has an F. Do not forget to call this one now, self.createHitRects. And now we actually have something the player can hit. Although, I guess for this one, we have to create another method. Let's call this one getHit. In here we need self, and I want to have a point. And this is the point the player can hit. In here, I want to check for rect in self.hit_rects. And I want to check for each rectangle if the rectangle was being hit by the point we have specified in the parameter, which we get with rect.collidePoint, and the point we're getting from the parameter. If that is the case, I have to convert this rectangle position back into my grid. And that way I can identify if I have a list with an F or not. And well, for that, I have to do basically the opposite I have done here. I need an X and I need a Y position. And for the X, I want to get my rect.x and floor divide it by the tile size. This I also want to do for Y, except now it's rect.y floor divided by the tile size. The way you want to think about it, let's say we have one tile here and another tile here. The first tile starts at position 0 and 0, the second one at position 64 and 0. These points here. If we now, for example, for X have something like 91, if I floor divide 91 by 64, we are going to get 1, which is going to be this tile here. That way, I have converted a pixel position, this one here, into an actual tile position that we can use to get information from this self.grid. And with that, I can check if the string f is in self.grid. And once again, we have the entire list of lists. We first want to get y for the rows, and then we want to get x for the columns. And now, if that is the case, I want to print, let's call it farmable. What we now have to check is how to call this self.getHit. My solution to that is I'm going to pass a reference to the entire soil layer into the player, which happens inside of the level, inside of the setup method. When I create the player is going to have one more parameter that I called soil layer. This is going to be self.soil_layer. That way, inside of the player, I can create another attribute, soil layer. Don't forget to turn this parameter into an actual attribute. Self.soil_layer is soil layer. And now, when we are using the tool, I can get rid of the print statement. And when we're using the whole, I want to get self.soil_layer. And that way, I can target or use this method here, which means inside of player, I want .getHit, and the position is the same target position we have used for the X. Target position in here, and now this should be working. Let's try. Although we're getting an error, the level object has no attribute soil layer. Let's have a look. Inside of level, we need a soil layer, and I think I just called it soil. No, the problem is I am creating soil layer after the setup method. That is a very easy thing to fix. All I need is the soil layer before the setup method. Now if I run this, there we go, and I can use the whole, and we get farmable if I use this here. But if I go further to the right and use it here, we are not getting anything. And let me make this a bit smaller. There we go. With that, we know where we are hitting something. Or more importantly, if that is farmable or not. If that is the case, I want to get myself.grid with the y and the x and append a capital X. This is telling me that on this tile, we have a soil patch. Once I have that, I want to run another method that I call createSoilTiles. This one for now is going to seem quite weird, but it is going to make much more sense in the next video. But for now, all that this createSoilTiles tiles is going to do. We need self in here as always. I want to get rid, first of all of the existing soil tiles, which I get with self.soilSprites.empty. After that, I want to look through the entire grid, and wherever there's an X, I want to create a soil tile. Which means, once again, I can basically copy all of this here, paste it in there, and in here, what I want to check is if capital X is in the cell, and if that is the case, I want to create a soil tile. This one doesn't exist right now. Let me minimize a couple of methods so we have a bit more space. We don't need any of this. All the way at the top, I want to create another class that I call soil tile. This one is a sprite, so we need pygame.sprite.sprite. After that, we have to create a dunder_init method. This one needs self, a position, a surface, and the groups it's supposed to be part of. Then we have to call the super dunder_init method and pass the groups in here. After that, we need self.image. This is just the surface we're getting from the parameters, and we need self.rect. This one we are getting with self.image.get_rect, and the top left should be the position. The position and the surface here are really important. Finally, this one is going to need a self.zPosition. This one, fortunately, is very easy because if you look at the settings, we have a dedicated layer for the soil. This I want to copy and paste it in here. And now we have a basic soil tile. All we have to do now is to pass in all of the information into the class to create it. For the position, this is something we have already seen inside of create hit rectangles. We basically want to do this one here again. I guess I can just put it straight in here. And with that, we have the position. The surface we also have. That is inside of the dunder_init, this soil surface here. This is what we want to paste in there. Finally, for the groups, I want to have self.allSprites because they are supposed to be visible, and then self. I called this one the soil sprites. Soil sprites. And since this is getting quite long, let me put it over multiple lines. We have the position, we have the surface, and we have the groups. That is much easier to read. And with that, we should have a basic start. Let's try all of this. If I now hit the floor, we have a soil tile. This is working really well. And if I hit some other field, we are not getting anything. With that, we have the start of the soil tile. And we also have a really efficient system to organize our data, which is really important. Although this is getting a very long section, so let's finish it for now. Let's keep on working on the soil patch graphics. The one really important thing I want to cover in this section, let me demonstrate it. When we place one patch, it looks like this. When we place another one right next to it, it looks like this. Which is okay for a basic game, but ideally it should be looking something like this. That is what we are going to create in this section. We are going to create our own auto-tiling system that creates nice looking soil patches. This is also the reason if I jump into my code, inside of soil layer, we have this weird setup here, that every time the player is hitting the soil, we are getting rid of all of the soil sprites and then drawing them from scratch. What this allows us to do is to draw all of the soil patches together. And that way we can control different graphics depending on the position of each soil patch. Or rather, if one patch is next to another patch, then they should get a specific kind of graphic. That is what all of this here is for. Although for all of this to work, we are going to need a whole lot more graphics. This is going to happen all the way at the top. Right now, we only have a single soil surface. Instead, what we need, if I open the folder again, inside of graphics, inside of soil, we have to import all of these different elements. This is what I've shown earlier, and now basically what all of them do. I guess I can't really make them larger, but if you look at them individually, for example, here we have the left tile. This is going to be placed if there is one tile to the right of this tile. We also have a tile called LR, short for left and right. This one we want to place if there's a tile to the right and another tile to the left. There's also a file called X all the way at the bottom, and this one is supposed to be placed if we have tiles all around it. So I hope the logic here makes sense. Basically, each of these tiles is going to be placed relative to where the other tiles are. But for that, we have to import all of them. Now, this I want to save in self.soil_surfaces. And in here, you might be tempted to use the support file, this one here, and use import folder. That, however, would not work because we need to know which file we are working with. In all of the examples so far, we didn't really care about what specific image we had, we just used all of them. But for this one, we need to know which tile we are working with. As a consequence, I want to create another function in here. I want to create import folder dictionary. We again need a path, although now we want to create a surface dictionary. What I want to have in here is obviously a key value pair with the value being a surface, one of the surfaces we are going to import. However, the key should be something like right, it should be left, it could also be something like X or LR. And this is what we are getting from the folder. So I want the key to be the name of each of these files and the file itself the value. And that is what we have to create in here. And this, I believe, could be a really interesting exercise. Look at this logic here and adapt it so that we are creating a dictionary with key value pairs. And at the end of it, return the entire thing. Pause the video now and try to figure this one out. A lot of this stuff I can just copy. The first 3 lines are going to remain identical. Because in here, we are just accessing every individual file path that we are going to need. So no change so far. As a matter of fact, the surface is also going to remain the same. So a lot of the stuff remains identical. The one difference now is when we are getting the surface dictionary, I don't just want to append something. Instead, I have to get a specific key, or rather, I have to create a specific key. This I want to be the file name, which I get with image, and the image right now would be something like l.png. The PNG I do want to get rid of. That I'm getting with split. I want to split it wherever we have a dot, and then I want to get the index 0 of this list. This is always going to give me the name of the file without the file ending. This is going to be my key, and the value is going to be the image surface. And that is all we needed. All we have to do now is to return the surface dictionary, and we are good to go. Now back to soil.py, and in here I have to import from support, import, let's say everything. And now I want import folder underscore dictionary, and the file path I need is this one here. I guess just to try if this is working, let me print self.soil_surfaces and run the entire thing. The game doesn't crash, that is generally a good sign. And now we are getting what I wanted. We have a key with, for example, B, this stands for bottom, and we have a surface associated with it. And this we have multiple times. These are all of the files that we wanted. With that, I can close the support file because we are not going to need it anymore. I can also get rid of the print statement here. This one isn't needed either. And with that, we are coming to the really fun part. Basically, what we now have to do is to create the entire auto-tiling option. So let me go through it step by step. First of all, I want to add, let me call it tile options. In here, I'm going to determine what is to the left, to the right, to the top, and to the bottom of the current cell. Which means we are going to cycle in here through every single cell in our grid. One cell could look like this. I have to know what is on the right, on the left, on top, and on the bottom. This is going to determine what graphic we are getting in here. So first of all, I want to have easy access to all of these options, which I'm going to store in a variable. We have top, we have right, we have left, and we have bottom. I want to check if we have a capital X in, for example, for the top, self.grid. And then usually we went with Y and X. Although those we don't have available right now, but we do have the index row and the index column. Those we can use. Index column is basically X. This one we can use like this. And Y is going to be the index row. This we can use here. Although for the index row, since we do want to have the cell on top of our current cell, this needs to be -1. And I guess while we are here, we can also do the bottom, because this one is very similar. We can basically copy the entire line, and instead of a -1, we have a +1. For right and left, we are also checking for a capital X, except now we are checking in the row, and we are checking index column -1. This is working because we have the row quite easily accessible, and this we can use. This I want to copy one more time. Oh, and I just realized right should be +1 and left should be -1. And with that, we know for each of the tiles what the neighbors are doing. Now, this system is still fairly simple, because if I open the graphic again, for most of the tiles, we are only checking the 4 directions, but there are 4 more. We have the top right, the bottom left, and the top left. I am not going to check any of those because that would become incredibly complex and I don't really need it. But if you want to have a proper auto-tiling system, you would have to do it, which would lead to a ton of if statements. But let's go through it one by one. Now, first of all, I need to get some kind of tile type. And this by default is going to be an O. If I open this thing here again, O is the default one, the one we have already seen. And this is a nice default one. If everything else fails, having this one probably isn't going to be too bad. And now this we can use inside of soil tile, because in here we have a surface. This I want to replace with soil surfaces, which is a dictionary. And this dictionary I can access with my tile type. And let's try this one right now. If I run main.py and use the hoe, everything works just as before. That is a good sign. And what I can do now, I could, for example, change this to an LR, run main.py again, and now we are getting a different kind of tile. All we have to figure out now is to make all of this a lot more flexible, which is going to involve a huge amount of if statements. Let's start with the really easy one, all sides. This one should illustrate the logic here quite well. Basically, what I want to check is all of these are either true or false, and I want to check if all of them are true. This could, for example, be if L and B and R and L. If that is the case, I want to have the tile type to be an X. This should be an equal sign. And now let's try this one. So here we have the center tile, and I want to create tiles to the left and to the right, and now to the bottom. And there we go. The thing updated. This was the easiest kind of side. Although this we can clean up a tiny bit. This we're doing with the all function, And the all function checks if all values inside of an iterable, like a list, are true. Meaning in here, we can pass t, r, b, and left, and we should be having the same result. Also, let me put all of this on the same line, because we are going to have a lot of lines. Let's try this one again. It should still have the same result. And it does. This is looking really good. That is covering all of the sides. So next up, we can start working on the horizontal tiles only. This means I want to check if I have a tile and if there is a tile to the left or to the right or to both sides. Meaning we are going to have 3 different if statements here. The first one, we want to check if L is true, so there's a tile on the left and not any inside of top, right, and bottom. Any kind of works like all, except now we want to check if any of those is true. For all to work, all of them have to be true. For any to trigger, only a single one in there has to be true. And let me illustrate the logic here. Let's say we have a tile like this, and we only want to check if there is a tile on the left of it. This is what we are doing in here. If this is true, we would ideally want some kind of graphic that would look something like this. This would be working by itself, but we also have to check that there are no tiles on top, to the right, or at the bottom of this tile, which is what we are doing here. If that was the case, we would be needing some kind of other condition, which we are going to do in a bit, but I do not want to confuse the different if statements here. Each of those should be unique. If that is the case though, I want to have my tile type, and now the tile should be right. Which means if a tile only has a tile to the left and nothing else, we want tile type to be right. Let's try this one. I have a tile here, and if I had another one, this one is going to be to the right. I can continue doing this, and now you can kind of see the one to the right works really well, but the one in the middle gets a bit confused. But that is something we can work on. Although, first of all, I can cover the right side, which is kind of simple. All I need is if R is true, and now this should be T, L, and B. We are basically doing the inverse of this one here, and this one should be L. Then I can copy this one more time, and now I want to check if we have a tile to the left and to the right, which means I want to check if R is true and if L is true, and if we don't have top and bottom. If that is the case, the tile type I want is left and right. With that, I should be having the horizontal logic. If I run this now, I can create some tiles here, and this is looking very good. Although if I go down, we are getting some weird results. But that we can start working on in the next part, which is going to be vertical only. In here, I want to check if we have a tile on top and not any tiles inside of the list, right, left, and bottom. If that is the case, the tile type I want should be bottom. I can copy this one more time, because now we can check if we have a tile at the bottom, and I also want to check if we have no tiles to the right, to the left, and to the top. If that is the case, I want to have a tile with the type T. Finally, one more time, now I want to check if we have a tile on the bottom and on the top, and not to the right, to the left, and that is it. If that is the case, the tiles I have are T and B. With that, we have the vertical tile types. Let's try this one. So now if I only go down, this is also looking really good, and I can still use the horizontal ones as well. Although now if I connect them, we are again getting weird results. Which means we need some more if statements. Let's go with the corners for this one. If this is the tile, I, for example, have to check if there is a tile to the left and a tile to the bottom. If that is the case, this should be a corner like that. Which, if you could follow along so far, should be fairly doable. It's going to look kind of similar compared to these lines at the end here. Let me copy it actually. For this one, I want to check if we have a tile to the left and a tile to the bottom. And I do not want to have a tile on the top and a tile on the right. And if all of that is the case, I want to have a top right tile. This logic is going to continue like that. So let me just copy from my notes. It's going to look like this. These are all of the different kind of corners we could possibly have. If I try this one now, I can go down. And now if I go to the right, we have a corner. The thing we are still missing though are T-shapes, because if I do this, things are falling apart once again. Which is going to be another section, and this is going to be T-shapes. In here, for example, I want to check if we have a tile and there is another tile on the top, on the bottom, and to the right. If that is the case, I want to have this kind of T-shape. Which means in here, I want to have if all, and the tiles I want to look at are, let's start with top, bottom, and right. Also, I have to check and not left. If that is the case, I want to have a tile type of EBR. Let's try this one. Now I have my tile, and I have a tile to the top, to the right, I meant the bottom, and to the right. And there we go. We have a T piece. And now, if we add one more direction, we have an X piece. So this is working just fine. This I now have to copy a couple of times because we have to cover the other sides as well. Next up would be top, bottom, and left, and not right. If we have that, we have a tile called TBL. Copy it one more time. Now we have left, right, and top, and not bottom. If that is the case, the tile I want to use is called LRB. Finally, the last one, I want to check if we have left, right, and bottom, and not the top. And if that is the case, I want to have LRT. And with that, we should have a proper auto-tiling system. So let's try the entire thing now. I can just go around, create more tiles. This is looking pretty good. And yeah, I'm quite happy with this. Although you can probably see there are some minor thingies. These little bits here. They exist because the auto-tiling system here is not perfect. For example, this tile here is technically a corner tile, where we have a tile to the bottom and to the right. And corner tiles always have this kind of bit here at the end. This we could get rid of by adding a bit more logic for this tile to also check if there's something to the bottom right. Although in my case, I think this looks fine, and if we added more logic here, this would become even more complex. And I think this is already quite a lot of if statements. So I'm going to leave it as it is. And now I can minimize all of this, and we have definitely made a ton of progress. For this part, we are going to work on the watering logic, which with the current system in place isn't all that difficult to do. Let's jump right in and let's do it step by step. Once more, we have the entire project, and I want to start inside of the player. Let me minimize everything. And we already have the use tool method here. Inside of there, we have selected tool being water. If that one is being triggered, I want to once again get myself .soil layer. Remember here, the player has access to the entire soil layer. This we have also used for the hoe. However, now I want to use a method called water, which doesn't exist right now, but will in just a second. In here, once again, we need our target position. And with that, we can return to the soil file. And all we have to do now is to create another method. Let's do it below getHit. I call this one water. In here we need self and the target position. What I want to check in here is if this target position hits any of the soil sprites, any of those here. Oh, also, I forgot, the soil surface we can get rid of because we don't need it anymore. For the water, I want to check for soil sprite in self.soil sprites, and there's already a typo in there, .sprites. I want to check if soil sprite.rect.collide point. And in here, I can add my target position. And let's try this one first. If that is the case, I want to print soil tile watered, and the rest should already work. Let's try. I want to create a water tile, change to the watering can, and now use it, and we get soil tile watered, which means this here is already working. This means I have to do two things. Number one, I want to add an entry to the soil rid, which means I want to add a capital W to the cell. Besides that, number two, I want to create a water sprite. This is going to indicate that there is water on this tile. Let's start with number one. In here, we have the same problem again. We have a position for this soil sprite, but we need a cell position, which means we have to do some conversion. We need an X position and a Y position, and what we need in here is the soil sprite.rect.x floor divided by the tile size. This I want to do again for Y. Let me copy the entire thing, except now this should be rect.y. That way I can use these positions to access the grid, which I get with self.grid. And now I want to have my Y, then I want to have my X, and then I get a list, and to this list I want to append a capital W. That way we know which tiles have been watered and which ones haven't. Besides that, number two, I want to create a watered tile to visually indicate that we have indeed watered this soil tile. This water tile I want to create inside of this Python file, which is class water tile. Once again, this is going to be a sprite. So pygame.sprite.sprite. We also need a dunder init method for the obvious reasons. This one needs a position, a surface, and the groups. And we also need a super dunder init method. This one gets the groups as well. Although this class is going to be fairly simple. All we're going to do in here is self.image is what we're getting from the surface. Self.rect is going to be self.image.get_rect with the top left being the position, like this. And finally, we're going to need self.z. This self.z we are getting from layers, and inside of settings, we have a soil water layer. This I want to copy and paste in here. I guess if you're being specific here, this water tile and the generic tile are basically identical, but I do want to keep things as separated as I can here. But you could be a bit more aggressive with inheritance here. It's entirely up to you. And with that, we have the water tile. I just have to call it now. And for this one, we need a position, we need a surface, and we need the groups. And that is going to be your exercise. There are a couple of steps to it. Number one, copy the position from the soil sprite, meaning this water tile should be in the same position as this soil sprite here, which should be very easy to get. Number two, for the surface, I want you guys to import the folder with the path. Let me copy it really quick. The path is going to be this one. From this folder, randomly select one surface. Finally, I want you guys to create one more group. Let's call it water sprites. And the water tile should be in all sprites and inside of water sprites. So pause the video now and try to work through all 4 of those tasks and see how far you get. I guess to make it easy to read, let's store it in a separate variable. But all we really want in here is the soil sprite itself, then .rect, which stores the position, and then top left. That is basically it. For number 2, we have to import another folder, and this should happen inside of the init method. Let's do it right below graphics. It does seem to make sense here. I called this one water_serves, and in here we only want to import a folder, which means import folder, the file path being this one here. In case you're interested, if I open the graphics part, we have soil water, and in there we have 3 different water kind of tiles. From those, we want to select one randomly. Again, let's do that in a separate variable. Let's call it surface. And in here, I want to use the choice function, which we don't have yet, but we can get it with from random import choice. And I want to get a random self.water surface. And this is going to be part number 2 and 3 actually. Finally, we need one more group. This I am going to do up here, and I want to create self.water_sprites. I think I called it, yes. This is going to be just another group, so let me copy it, and there we go. Now, when we are assigning the groups, I want to have self.allSprites and self.water_sprites. And that is all we needed. With that, I suppose I can get rid of all of the comments because they are getting a bit annoying. There we go. This feels much better. And now, if I run main.py again, I can still use the hole, and if I now use the water, we have a water tile. And I can do a couple more tiles and use the watering can again. There we go. This is working really well. The last thing we need is that once I restart the game, I want to destroy all of the water tiles and also get rid of the W for every single tile. That is going to be a separate method. Let's call it remove water. No need for any arguments in here. And there are 2 things that we have to do. Number 1 is we have to destroy all water sprites. And the second one is clean up the grid. The first one is really simple. All we need is for sprite in self.water sprites. And I want to just destroy all of the sprites. That is going to be the first part. The second part is going to be for row in self.grid. And then for cell in row. What I want to check in here is if there is a capital W inside of this cell. If that is the case, I want cell.remove and the capital W. All I have to figure out now is when to call this method. This is going to happen inside of level.py. In here, once again, let me minimize everything. And I want to work inside of the reset method. There's going to be another section. Let's call it soil. And all I have to do is self.soilLayer and remove_water. If I run main.py again, I can create a couple of soil patches, water them, and now if I restart the day, this is still working fine. And there we go. This is looking really good. So with that, we have the watering logic. We are not quite done yet with the watering logic because we need the rain. This is going to consist of 2 different parts. Number 1, we need the actual rain animation so that the player can tell if it's raining or not. Besides that, if it is raining, I want to automatically water all of the soil sprites. So that is what we're going to work on. Let's jump right in. Back in the code, I want to create a new file that I want to save as sky.python. In here, I want to import Pygame, and I also want from settings import everything. And I want to create a class called Rain. There's no need for inheritance, but I do want a dunder init method. Although in here, all we want is all sprites. Once again, so that we can draw in here without having to leave the class itself. This we have to save inside of an attribute, so self.allSprites is going to be all sprites. Once we have that, I want to have a few more graphic files. We need self.rain_drops, and I want self.rain_floor. Both are going to use the import folder function, except with a different path. As a consequence, I have to import from support, import, let's say import folder for this one. Just to have a look at them, inside of the project, I have graphics, and in there I have rain. In here, we have drops and floor. Drops are very simple raindrops, basically just straight lines. For the floor, we have a whole animation. Or it's not really an animation, we can just play them separately. But this is what we are going to import. Let me just copy the file path. It is going to be this one, and it is going to be this one. There's one more thing that we do need, and that is we need to know the size of the entire map. Basically what is going to happen. If this here is the entire map, I want to randomly create little rain animations all throughout it. And for that to work, I need to know how wide the entire map is and how tall the entire map is. That is information I can get from the ground image, which we have to load with pygame.image.load. And for this one, let me copy the file path as well. It is this one, and this is literally just the ground, nothing else. All I want to know is get size. And this I want to store in self. Let's do it via two variables. We have floor w and self.floor h. Once we have that, we are going to need two separate methods. One for create the floor, and besides that, we need create drops. And after that, I want to have an update method that is creating both of those. So self.createFloor and self.createDrops. In here now, we have to figure out what to do. In my case, all I'm really going to do is create a drop class, which doesn't exist yet. So we have to create it. And this I want to create inside of this file as well. Class drop. Now, this is going to be a pygame.sprite.sprite. Although I do want this to inherit from generic to save me a bit of writing. As a consequence, I need from sprites import generic. I am getting much worse at spelling. Essentially, what I want to do is to import this generic class here. We are using this all throughout, and you could even put the drop in here. It would be perfectly fine. But I think in here, it does make a bit more sense. All I want is to create another init method. In here, we need self, we need a surface, we need a position. We need to know if this one is moving or not. Then we need the groups, and then we need a Z position. And how the drop is going to work. It is going to be kind of similar compared to if I minimize all of this. It is going to be kind of comparable to the particle. We're going to create the object for a short period of time and then destroy it. Which means we are going to have a timer for each object and then destroy it after a couple of milliseconds. Now for that, I want to have a random live time, which I'm getting with randint, which we don't have in here yet, meaning from random import randint. The duration here I want to go with 400 to 500. Besides that, for the timer, I want to have self.startTime, and this we get with pygame.time.get_ticks. Also, let me comment here that this should be the general setup. Because in here, I guess this should be at the top, I also want to have a super dunder init method. The arguments we need for this one are the same that we have for generic. We need these four. All four of them are going to come from the attributes that we are passing in when we are creating the drop. So there isn't anything we have to do right now. Although what we do have to do is to work on the moving part. Basically how that is going to work. If we have a raindrop, so the things that are going down, those are supposed to be moving. Whereas the raindrops on the bottom, so the round things, those are going to be staying in place. Which means I want to have another attribute that I called moving. And this is going to capture the moving parameter. If self.moving is true, then we need a position, and this is going to be pygame.math.vector2 and self.rect.topleft. Besides that, we also need a direction, and the direction here is going to be pygame.math.vector2. And for the value here, I went with -2 and 4. Those directions mean we are going 2 units in the negative direction and we're going 4 units down. As a consequence, our actual movement is something like this. Finally, we need self.speed, which is going to be a random value as well, between 200 and 250. Now, these 3 attributes is the same thing you have seen a couple of hours earlier inside of the player. So if I show the init method, somewhere in here, we have direction, position, and speed. These are the attributes you basically always need to move anything inside of Pygame. Finally, I want to have an update method. In here, don't forget, we do need delta time. And I want to check if self.moving, if that is the case, self.pos should be plus equal self.direction multiplied by self.speed multiplied by delta time. And once we have that, self.rect.topleft should be rounded self.pos.x and rounded self.pos.y. We are basically assigning the top left of the rectangle to position.x, and we're using round to avoid the truncating that Pygame does by default. This is going to be the movement, and besides that, we are going to need a timer. That I want to destroy this timer if it has lived longer than the lifetime. And this is going to be your exercise. Create a timer that you are destroying this sprite after the lifetime has run out. Pause the video now and try to figure this one out. All we need in here is pygame.time.get_ticks. This is getting our current time. From that, I want to subtract self.startTime. If that difference is greater or equal than self.lifetime, we know the lifetime has been exceeded. As a consequence, we want to kill this sprite. And that is all we need for the drop. Now we just have to create it inside of here and inside of here. So let me copy all of the parameters we need and paste them in here and in here. For create floor, the surface is going to be self.raindrops. And from this, we want to randomly select one of them. For that, we need choice, which we don't have yet, but we can import it very easily. For the position, I need to have an X and a Y position. For X, this should be a number between 0 and the width of the map. That is what we created up here, which means I need rand int that goes from 0 all the way to self.floor width. And this I also want to do for the Y position. And this should go from 0 to the floor height. Next up, we have moving. For the floor tiles, this is going to be false. Then we have the groups, and the groups are going to be quite simple because in here, all we have is self.allSprites. Finally, we need the Z position. And for this one, if you look at settings, we have rain floor. This I want to copy and paste it inside of layers, and there we go. This is all we need for the floor, and now I can basically copy all of this and do the same thing for the raindrops. It's going to be fairly similar. For the surface, we want to have rain. This should actually be raindrops, and here this should be rain floor. Sorry about that. The position can remain the same. Moving should be true. Groups can remain the same, although for the Z position, we have raindrops. That's the layer all the way on top. This I want to paste in here. And there we go. This is covering the entire rain class. So let me minimize the raindrop and basically everything in here as well. All we have to figure out now is when to call this rain method here. And that is going to happen inside of the level. First of all, I want from sky import rain. This I have to turn into an actual object. Let me add another comment here actually to organize this a bit better. Let's call it the sky, because there's going to be a bit more. In here we have self.rain, and this is going to be the rain, which needs self.allSprites. Besides that, I want to have another attribute here that I called self.raining. And this by default, let's say for now, it is going to be true, so it's easier to test. But later on, this is going to be random. And now, inside of the run method, before we are doing the overlay, let me add a few comments here actually. Transition overlay. I want to have my rain. All I have to do for that is check if self.raining is true. And if that is the case, I want to have self.rain.update. That way, we are calling this update method here, which is going to generate raindrops. And those drops we are going to see, hopefully, in the game. So let's try. And there we go. We have the rain. And honestly, this is actually a fairly simple effect. All we are doing is we are creating random sprites that are either moving for the rain or that are staying static on the bottom. And well, this is the entire rain graphic. If we go over this, it really isn't that complicated, or at least I hope it isn't. With that, I can close the sky.py file, although we are going to see it later, but for now we don't need it. What we need now, which is much more important, we have to update all of the soil tiles if it is raining. And for that, inside of soil.py, let me minimize everything once again, because this is getting quite extensive. I want to create another method that I want to call right below water, water_all. No need for any arguments in here. And once again, I want to go through all of my grid cells. For that, let me copy the nested for loop again, one more time, and paste it in here. I want to check if there's a capital X in the cell and W is not in the cell already. Which basically means we are going through all of the cells and we are checking if there's an X, meaning there's a soil tile, but this soil tile hasn't been watered yet. But we do want to make sure that it does get watered, which means, first of all, I want to append a W to the cell. And after that, I want to create all of the water tiles again. And in here, let me copy it from the water. We basically want to copy this entire thing, although we do have to make some changes. Because for this one, we have a position inside of a cell, and this we have to convert to an actual pixel position. The main thing you have to understand about the soil layer is we are working with two different systems. One is we have all of the positions inside of the grid, and that is basically a table. Besides that, we have all of the pixel positions in the actual game. Switching between them is really simple. In this case, we need an X and a Y position, and those we get. For X, it's going to be the index column multiplied by the tile size, and for Y, it's going to be the index row multiplied by the tile size. This X and Y we now want to paste into the position for X and Y, and we are good to go. The surface is going to be the same surface we had up here. I just want to pick a random water tile. I can just paste it straight in here. And the groups can remain identical, those work just fine. With that, we have a function that can water all of our soil tiles. We now have to figure out when to call it. And this has to happen in two separate places. Number one is when we get hit, or rather when the soil gets hit. We are attaching an X inside of the cell here. If that is the case, I want to pass in if self.raining, which is not something we have yet, but we are going to in just a second. If that is the case, I want to call self.water all. The problem we have right now is that the soil layer doesn't know if it is raining or not. This we only know inside of the level. Although that is a problem that is very easily fixed, all we have to do inside of the init method, after we have set the rain, I want to get my self.soil layer and set raining to self.raining. Also, when we are resetting the day, I have to do the same thing. Which means in here, in a bit, I want to randomize the rain every time we are resetting the day. Once we have updated that, I want to get my self.soil layer again and set raining back to self.raining. And now we always know if it is raining inside of this class here. Which means if I run main.py and I use the hoe, we automatically get water sprites. This is looking really good. And if I switch off the rain all the way at the top here, so raining should be false. Let's try this now. We don't have rain and we don't have water, at least not by default. So, all right, with that, we have some basic rain logic. Although what I also want, when we are resetting the day and it is raining, I want to automatically water all of the existing soil tiles, because right now in the logic here, we are only watering new tiles. We don't water existing tiles. Which means when I'm resetting the day, I want if self.raining is true, then self.soil layer.water underscore all. Let's try this one. Oh, and I do have to switch on the rain. And to test this one, let's randomize the rain. Meaning, when I'm creating the rain, I want to have a random chance to create a rain, which I'm getting with randint, which I don't think I have available yet. I do not. I need from random import randint. And in here, I'm just creating a number between 0 and 10. And if this number is, let's say, greater than 7, this is going to be true. Although for now, for testing purposes, I'm going to set this number to a 3, which means we are going to have a ton of rain. This I also want to do down here. Actually, I can copy the entire line like so. And now for every day, we have a pretty high chance to generate rain. If I run this, it's raining right now, but we can still get started. And let's go to bad. And let's hope. There we go. Now there's no rain, so there's no water on them. And I guess let me water one of them just for testing purposes. If I now go to sleep again, it's not raining. Now it's raining again. And all of the soil tiles have been watered. So this is working really well. Very nice. And with that, we have the basic watering logic. So another major step forward. Next up, we can start working on the plants. Let's get started with the plants. Since we already have a ton of logic in the soil, this shouldn't be so bad actually. But once again, let's go through this step by step. The very first thing we need is inside of the player. We need to know if the player is planting some seeds. For that, we already have a method that is called useSeed. Right now, there's nothing in there, but that is going to change. I want to get this soil layer once again, and now call a method that I called plantSeed. For this one, we need two arguments. The first one is going to be self.theTargetPosition. The second one is self.selected, not tool, but seed. And I hope this makes sense. We have to know what target we are hitting, and we want to know what kind of seed we are using. This is all we need inside of the player. And now in the soil layer, I want to minimize all of the methods, and let me put it all the way below the water. In here, I want to have plant_seed. We need self, we need a target position, and we need a seed. And once again, we have to check if we actually hit a soil sprite, which we get with for soil sprite in self.soilsprites.sprites. I want to check if soil sprite.rect.collide point. And the point I want to check is the target position. If that is the case, once again, I have a pixel position, and this I want to convert to a position inside of the grid, which means I need my soil sprite.rect.x and floor divided by the tile size. I can duplicate this line and change the x to a y, and that way I'm getting my y position inside of the grid. If that is the case, I want to get my self.grid with my y and x. This is going to give me the cell, and I want to append a capital P, short for a plant. That way we know we have a plant inside of this cell. Now this should only be possible once, which means I can already check if a capital P is not in self.grid with y and x. And only if that is the case, I want to create a plant. Now that we have that, I want to create a plant object. This I am creating also inside of this Python file with class plant. And this one is also going to be pygame.sprite.sprite. I want to have a dunder init method with self. We need a plant type. So do we want corn or tomato? Then we want groups. Next up, I need the soil for the positioning. And let's say that's it for now. As always, I need the dunder init method with the groups. I have to convert the plant type parameter into an attribute, so self.plantType is plant type. And then I have a couple of frames, depending on what kind of plant we have. Meaning, here's the project, I have graphics, inside of there we have fruit, and there's corn and tomato. Not the best naming, but it really doesn't matter. Inside of corn, we have these different files. And inside of tomato, we have those. This is what we are going to import. This we get with import folder, and the file path here is, let me just copy it right away. We have to go into graphics and fruit, and in there we have two subfolders. And those subfolders I want to get with an f string. Because what we can use in here is the plant type. Besides that, we need self.h. By default, this is going to be 0. After that, we also need self.maxH, so that we know when the plant is reaching the full age. This we can get with self.frames and get the length of it and subtract 1 from that. Finally, I want to have self.grow_speed, which is telling me how fast this kind of plant is growing. And for that, inside of settings, I have a dictionary. This is what I want to use. meaning I can use grow speed in here and then get the plant type. I guess I should really comment all of this a bit better to make it a bit easier to understand. Let's call this section here the plant growing, and the stuff at the top is going to be the setup. Also, there's one thing I forgot. We have to turn the soil into an attribute. So self.soil is going to be soil. Once we have all of that, we can work on the sprite setup. First of all, here we need self.image. This is very easy because we have a bunch of frames. I want to use self.age for the indexing. Besides that, I have to create self.rect. This I'm getting with self.image.get_rect. I want to place the mid bottom. And the position I'm getting from soil.rect.mid bottom. Although here we have a problem. This is going to be the size of a soil tile, but each plant is going to be about this tall. And since we're placing the bottom of the plant at the bottom of the soil tile, we're going to be somewhere here. And I want there to be some kind of offset. This I created separately and I called it self.y_offset. This is going to be -16 if the plant type is equal to corn, and if that is not the case, it's supposed to be -8. The reason here is that the various plants are very different in size. We do have to account for that. And to use that, I have to turn it into a vector, which means pygame.math.vector2. This needs to be capitalized. For x, it's supposed to be 0, and for y, it is going to be self.y_offset. We are nearly done. The last thing we need is self.z. In here, we need layers as always, and for the plants, we actually have two different layers. The one we are going to start with is the round plant. This I want to paste in here, and this means if you look at the settings, the plants are always going to be below the player. By default, I want the plants to be non-collidable, so the player can just walk on top of them. But once they have grown, I want them to be on the main layer, and the player should be able to collide with them. But that's going to come in a bit. I guess for now, we have added a ton of stuff, so let's actually create one of the plants and see how far we get. So when I create a plant, I need a plant type, the groups, and the soil. This one should be fairly simple, because the plant type is going to be the same as the seed. The soil is also going to be very simple, because all we need in here is the soil sprite. For the groups, I do want to have one group specifically for the plants. This is going to happen in the init method of the soil layer. In here, I want to have self.plant_sprites. Once again, this is just going to be pygame.sprite.group. And now for the groups, each plant should be inside of self.allSprites. It should be inside self.plant, not types, but sprites. And let me fix this typo here. And let's actually try this. So in the game, I can use a hoe. And now if I press left control, we get some seeds that we can walk over. And this I can do multiple times. Also with E, I can change the seed. And now we get a tomato. This is working surprisingly well. Cool. So I'm very happy with that. What we now have to figure out is how to make the plants grow. Inside of the plant, we need an update or some kind of an update method. This one I called grow. There is no need for an argument in here. And now we have a problem, because the plant needs to know if the soil it is in was watered. But this information we don't have available right now. What I want to happen is that each plant can access the soil layer and check out self.grid to know if the tile it is in was watered or not. And for that, I am going to create another method. That is going to be fairly simple though. I called this one check watered. In here, we need some kind of position. This position will be entered by the plant itself. I want to get the actual cell. And right now, once again, we have a pixel position. This we have to convert into an actual grid position so we can access the grid. The same thing we have done here, actually. Let me copy the entire thing, actually, and fix the indentation. There we go. To get the cell, all I want is self.grid, then y, and then x. Once I have that, I can check is watered. And is watered, we are getting with capital W in cell, meaning this could either be true or false. And that is the information I want to return. So return is watered. Now, this method I am going to pass into a plant whenever we create it, which happens down here. Each plant is going to have access to self.checkWatered. For this, we have to create another attribute. After soil, I want to have checkWatered. This we have to turn into an attribute, so self.checkWatered is checkWatered. And now we can create this grow method. All I have to do is check if self.checkWatered with self.rect.center. Remember here, checkWatered needs a position, and I'm just going to go with the center. Remember here, checkWatered did need a position. If that is the case, I want to add self.age plus equals self.grow speed. And after I have that, I can run self.image is going to be self.frames, and I can use self.age again. Although now we do have to be careful, because this age could be a floating point value, which we couldn't use for indexing, but if we turn it into an integer, this is going to work again. And after that, I can turn this into a rectangle, which I am getting with self.image. Actually, let me copy this one here, because it isn't going to change besides that. Now, the main reason why I am updating the rectangle is because the image is going to change and we might have different dimensions, which means we have to get a new rectangle. But other than that, this is the basics of the grow method. What we now have to figure out is when to call it. For that, inside of the soil layer, I created another method, update plants. All I need in here is for plant in self.plantsprites.sprites. I want plant.grow. And this method I now want to call inside of the level when we are resetting the day. So in here. Let's do it all the way at the top. We have the plants. self.soil_layer.update_plants. And that should basically be it. I guess the one thing you want to be careful about here is that this should be called before all of this. Because, for example, if we called it after is raining with this method here, we might water all of them and then update all of the plants, which would be a tiny bit weird. Let's try. So I want to grow some corn, make sure I am watering it, and now let's update the entire day. And we are getting an error. That name, soil sprite, is not defined. This probably happened inside of here. Ah, right. CheckWatered has the problem right now that this should be position 0 and position 1. Because what we actually pass in here inside of the plant is self.rect.center, which is giving us a tuple with an X and a Y position. Now let's try this again. Next attempt. I want to plant some corn again and start a new day. And we are getting another error. This one happens down here inside of plant.grow. So let's have a look at this one. And the problem is happening somewhere in here. The problem is we don't have the soil as an attribute. This we can fix with self.soil. Righty, next attempt. Let's try it again. Let's see if I made another mistake. Now it's working, and there we go. This definitely grew. Let me water it by hand. And start another day. And there we go. This keeps on growing. And now if I start another day, it should be fully grown. There we go. Now, if I start another day, this is going to crash because we are running out of frames. But this was expected. Other than that, this is working just fine. We do have a very good start. Now we just have to make some more updates to the plant, and then we are nearly done with the plants. And with most of the game actually. First of all, once the plant is reaching the max age, I want the plant to stop growing. Which happens inside of grow. All I want to do in here is if self.age is greater or equal than self.max age. And if that is the case, self.age is going to be self.max age. Although, if that is the case, I want to indicate that the plant is ready for harvesting, which I am doing via another attribute that I called harvestable. And harvestable is going to be true once this condition here is true. So we can set this to true. With that, the game is not going to crash anymore. Although what I also want to do is if the plant starts to grow, it should be on the main layer and the player should be able to collide with it. This could be a good exercise. If the plant age is greater than 0, so if we have 1 and above, then the plant should be on the main layer. And pause the video now and see if you can figure this one out. For this one, we need an if statement, and I want to check if self.age is greater than 0. If that is the case, I want to update self.z, which now should be inside of layers and the main layer. Although there is one thing you really want to be careful about, because self.age could be a floating point value, and we only want to do this line here if the plant is greater than 1, which we can get quite easily with integer. If you didn't do this, self.age might be something like 0.7, which would be greater than 0, but the plant itself would still be a tiny seed, which the player should walk on top. So integer ensures that we have a certain kind of plant size. If I run the game now, let's hope it doesn't crash. I can plant something. And if I now update the entire thing, it doesn't crash. And now we should be behind and in front of all of the stuff. So this is working just fine. What we now have to figure out is the collision mechanic. And for that, if I look at the player again at collision. In here, the plants don't have collisions yet because they don't have a hitbox, which we are checking here. But that we can fix quite easily. Once a plant has a certain age, it should have self.hitbox. And this is just going to be self.rect.copy. And this I want to inflate. And now I need an x and a y dimension again. For x is going to be -26. And for y, it is going to be self.rect.height multiplied by 0.4. And this should be negative. That is all we needed. If I now run main.py, and let's create a tomato for now. If I plant this one, although I think this takes 2 days to grow, but that's a good way to double check. So now I can still walk over the tomato plant, but if I sleep again. Now we have a grown plant and there is no collision yet. And I also know why. The reason is the plants are not inside of the collision sprites method. So when I am creating a plant, it needs to be inside of self.collision sprites. The problem is the soil layer doesn't have that one. Although that we can change, I want another attribute with the collision sprites. And let me put this right below all sprites. Self.collision sprites is going to be collision sprites. Now inside of level, when I create the soil layer, which happens here, I also want to pass in self.collision sprites. Now let's try this again. I want to plant some corn because that one is faster. And now if I restart the day, we have something, and now we have collisions. This is looking really good. Cool. So with that, we have the basics of the plant. Although we cannot harvest them, but that is going to be the next section. With the plants being done, the last thing we have to do is the harvesting part, or at least the last thing we have to do for the plants. There's going to be quite a bit more. Let's jump right in, and once again, let's go through it step by step. Back in the code, what I basically now have to figure out is if a plant is harvestable, so this line here is true, and I have a collision with the player, so this player here, then I want to destroy the plant and update the player inventory. All of this is going to happen inside of level.py. I want to create, let's call it plant collisions or collision. There's no need for any parameters. In here, first of all, I want to check if there are any plants in the first place, which I get with self.soillayer.plant_sprites. If there are no plants, this is not going to trigger. And then there's no point doing any of all of this. If there are no plants, this would not trigger. In here, I want to check for plant in self.soillayer.plant_sprites. That way I can access every individual plant, and what I want to check is if plant.harvestable and the plant.rect.collideRect with self.player.hitBox. We are checking if the plant can be harvested and if the plant is colliding with the player. If that is the case, I want to destroy this plant. Make sure to call this plant collision right after update, which happens here. I want to run self.plantCollision. And now, let's try all of this. We're getting an error that inside of level, this should be plant sprites. So should this one here. Now let's try this again. There we go. I can plant some corn and water this. And now I have to do a bit of restarting the day. But the game is definitely coming together. Now it's raining, so I can go straight back to sleep. And now if I collide with this, it disappears. Cool. This is a very good start. Although we do have to do a few more things in here. First of all, I want to run self.player_add. And in here, I want to get the plant and then .plant_type. That way, we are updating the player inventory, so there's an actual reason to harvest something. And this we should probably test. So once again, all the way at the end of the run method, I want to print self.player.iteminventory. If I run this now, we get the entire inventory, and I want to plant some corn. Now I have to restart, it's still raining, It's also raining and we need one more day. And now if I collide with this, we get corn 1. This is working very well. So let me delete this print statement here again. And now we can keep on working in here. I also want to create a particle when the plant disappears, which we don't have available yet. We do not, but I can import it quite easily. I want a particle, which we are getting from the sprites, this one here. And now I need all of the arguments to create it. So let me copy these ones here, paste them in here, and now we have to figure out all of them again. For the position, I want to have plant.rect.top left. For the surface, I want to have plant.image, and for the groups, this should be self.allSprites. For the Z layer, I want to have the layers, and in here, this should be main. This should be all we need. Once again, let's try this. And I do hope it starts to rain. This is looking good. Raining again, one more time. And now we should have a particle effect. And there we go. This is looking good. The last thing we need is whenever we destroy the plant, we still have inside of the grid. Let me minimize the plants. The last thing we need inside of this soil grid, we have to remove the capital P. That way we can create another plant. For this one, I need self.soil layer once again. And now we need the grid. The problem is right now we only have an X and a Y position, and for the grid we need rows and columns, which means we need a row and we need a column. And once we have that, I want to remove any kind of capital P. And this column is going to be your exercise. See if you can figure this one out. For the row, we are going to need the Y position of the plant, which we get with plant.rect.center_y. And this I want to floor divide by the tile size. For the column, this is going to work in the same way, except now we need center X. And with that, we should be good to go. So now if I run main.py again, now if I plant some corn, and restart the day. It's raining again. We do have to wait until the thing grows completely. Now this should be working. And now we are getting an error because I made a typo. This should be tile size. Okay, once again. Let's try this again. And testing a game can be very annoying. It's not raining, but I guess all of this is a good way to test all of this. Let's try it one more time. Now it is raining, it keeps on growing, and now it is completely grown. If I touch it, it disappears, and now I should be able to create a new plant. So let me plant a tomato, and there we go. We have a tomato. I guess if I restart the day, just to be sure all of this is working, one more time, and it is growing. Cool. So this is working as well. With that, we have the harvesting logic. This honestly wasn't so bad. Or at least I hope it wasn't. There isn't actually that much more to do. But there's one thing I did forget to do, and that is the night transition, or the daytime transition. Let's do this one next. For the day transition, we kind of have to do the same thing we have done for the transition between different days. We are basically creating an image on top of the entire game, and then we use blending modes to merge the two. I probably should have done this a couple of hours ago when we worked on the transition, but well, here we are. Back in the code, I want to do all of this inside of my sky, because it kind of fits in there. Let me reopen it. We need the sky. In here, besides the drop and the rain, all the way at the top, I want to have, let's call it sky. we need a dunder init method in here with self. And now, first of all, we need the display surface, which, as always, we get with pygame.display.get_surface. Besides that, we are going to need an image that covers the entire window, which I called self.fullSurface, just surface fine. And this we get with pygame.surface. And in here, I can, once again, from my settings, get the screen width and the screen height. Let me copy in the screen width and the screen height. And now we have a full surface. Once I have that, I want to, let me call it display. In here, we need self, and we also need delta time. And essentially, all I want to do here is self.displaySurface.split. I want to have my self.fullSurface at the position 0 and 0. That way we're covering the entire window. And finally, we need a special flags, which in this case is going to be pygame.blend_RGBA_mult. Right now, this is going to be entirely black, so there isn't too much point, but let's use it right away. Also, I want to close the soil, at least for now, to keep things a bit more organized. I can also close the sprites, because I don't think we need it at all anymore. Inside of the level, I want, besides rain, also import sky. And the sky has to be an attribute. Let's put it right here. Self.sky is going to be sky. Once we have that, inside of the run method, after the rain, I want to have the day time. Like that. And this we get with self.sky.display. In here, we do need delta time. Although not right now, but we do need it to call the method. If I run this now, everything is going to be black. The reason is we are putting a black surface on top of the entire window, which, well, isn't particularly helpful. Although what I want to do now is self.startColor. And this start color is going to be a list with the values 255, 255, and 255. Before I am displaying this surface, I want to fill it with that color. So self.colorSurf.fill with self.startColor. Once we have that, we shouldn't be seeing anything. We can see the game itself. This is looking as always. But now, what we can do with this setup? I could, for example, change this to a 0. And if I now run this again, we get a bunch of weird colors. And this way, we can control how the game is going to look like. In my case, I want to transition from a pure white color to my self.end color, which is going to be the tuple 38, 101, and 189. Just to illustrate what this one is going to look like, let me run it in the game. It's going to look like this. This is very much nighttime. All we have to figure out now is how to transition from this value to this value here. How this is going to look like is I'm going to look at every individual value and subtract it by a certain amount. Let's say -2. And this I'm going to do until we are reaching this particular point. This point here, so you can see it. This is also going to happen for the second one. This is going to go until this point here, and for this one as well, up to this point here. This I am getting with for value in self.endColor. Although in here, I do need the enumerate method because I need to know what index I am on. So I have my index and I have the value. I want to check if self.start, not time, but color, is greater than the value. And if that is the case, self.startColor with the index should be -2 multiplied by delta time. Also, when I am filling all of this, this should be the start color. We are looking at every single color inside of endColor. Against this, we are checking on this line here. If the corresponding value inside of start color, let's say the first one, 255, is greater than the end color, 38 in this case. And if that is the case, we want to reduce the start color value by a certain amount. And this we want to do until we reach the end point. And with that, we should be having a transition. Let's try now. And we are getting an error. This one here should be start color and index. And now all I have to do is wait. I guess while I'm doing that, I can run around a bit to check out the entire level. I've been very focused on specific tasks, but well, the entire game is coming together pretty nice. Also here you can see the trader, and now since we have a collision block here, we cannot move over him anymore. We're going to work on the trader in just a second. And everything else is working really well. Okay, probably I'm just going to speed up this entire game because I am running out of things to talk about. So let's speed it up a bit. Alright, I think at this point you can definitely tell things are getting darker. This is definitely working. All we have to figure out now is once we have all of this color here, we have to set it back to the starting position. So 255, 255, and 255 whenever we are resetting the entire day. This is also going to be fairly simple. All we have to do, let me add another comment here, sky. I want to get self.sky.startColor is going to be 255, 255, and 255. And that, if I now wait a tiny bit, let me speed all of this up. Alright, now we can definitely tell things are getting darker. So let me restart the day. And there we go. This is much brighter. With that, we have the daytime cycle. Really wasn't that bad. And this is literally all we need for the sky, meaning I can minimize it and close the entire Python file. And we are almost done. The last major bit of the game is going to be the merchant. So let's work on that one. There are quite a few different elements we have to cover here. Back in the code, first of all, the player is going to need, let me minimize everything. The player is going to need a full inventory. We already have a couple of things in here. We have this kind of inventory, but we are going to need a tiny bit more. We also need self.seed_inventory, and this one is going to have two key value pairs. We have corn, and by default, let's say we have 5, and besides that, we have tomato. 5 in here would also work well. Finally, besides that, we are going to need self.money. And for starting value here, let's go with 200. It's entirely arbitrary. This is going to be the inventory for the player, and this is also what we're going to access when we are doing the merchant. Although, before we are coming to that, there's one more thing that I want to do, and that is that the player shouldn't be able to use a seed once we are running out of seed. For example, the player can only use corn if this number here is at least 1. Let me minimize the init method, and all of this happens inside of use seed. All I want to do in here is if self.seed_inventory, and then I want to pick my self.selected seed. And only if this is greater than 0, then I want to plant a seed. Besides that, inside of here as well, I want to get my self.seed_inventory, get the selected self.selected seed again, and subtract it by 1. With that, we can start working on the merchant itself. Let me explain how it's going to work. Here we are back in tiled, and the trader is all the way in the top left. What you can see around the trader is inside of player, we have a trader area. This is going to work kind of like the bed. If the player is inside of this area, presses enter, then we are going to start the merchant menu. Back in the code, when we are creating the level, more specifically when we are running the setup method. In here, a bit further down, we are checking for the start position of the player, if there is a bed, and besides that, I want to check if obj.name is equal to trader. If that is the case, I want to create another interaction object, meaning I can duplicate this line here and paste it in here. With that, we are actually done. All of these arguments here can stay identical. Since we're getting information from tiled, all of this is going to be done automatically. The only major change here is going to obj name, because this one now is going to be trader instead of bad. But with that, we have the interaction object. We have to do a tiny bit more inside of the player. Inside of the input method, all the way at the bottom. We have created this line a couple of hours ago, and that is if the player is inside of the interaction area and we have trader. Then we want to do a certain thing. Basically, what I want to do is to run a method called self.toggle_shop. This one doesn't exist right now, but basically what I want to do is inside of the level, I want to create another method. Let me minimize everything in here so it's a bit easier to see. Inside of the level class, I want to, let me do it below player add. This one I want to call toggle_shop. In here we need self and nothing else. And this is a fairly simple method. All I really want to do in here is self.shopActive is going to be not self.shopActive. Meaning whenever we are running this method, we are switching shopActive either on or off. This attribute doesn't exist right now, so we do have to create it. This happens inside of the init method. In here, let's put it under another section, shop. And by default, this one needs to be false. If this one is true though, we are going to show the shop menu. But that is going to come later. First of all, we have to pass this method here into the player, which happens inside of setup. And in here, we have the player. And the player is going to get another parameter, toggle shop, which is going to be self.toggleShop. For that to work inside of the player, all the way at the top, let me minimize the input method, and inside of the init method, we need toggle shop. And for this one, inside of interaction, I want to create another attribute, self.toggleShop is going to be toggle shop. And with that, we should be having a pretty good start. I suppose we can test this inside of the run method. All the way at the bottom, I want to print self.shopActive. And this we should be able to influence with the player. So let's run the game. And we're getting false right now. That is a very good sign. And if I walk to the merchant, and if I press enter right next to him, we're getting true. If I press it again, we're getting false. So this is a very good sign. And with that, we can start working on the actual merchant. For that, I want to create a new file and save it as menu.py. In here, as always, we are going to need import Pygame, and we also need from settings import everything. After that, I want to create a new class that I call menu. In here, we need it under init method. This one needs self, it needs the player, and it also needs toggle menu, so we can switch off the menu from inside of the menu. Inside of this, I want to have a general setup. For this, I want to turn the player into an attribute, so self.player is player. The same I want to do for the toggle menu, so self.toggleMenu is going to be toggle menu. And besides that, I am going to need two more things. First of all, I need the display surface. This, as always, I'm getting with pygame.display.get_surface. And besides that, I need self.font. The font we get with pygame.font.font. Be careful here about the capitalization. The first font is lowercase, the second font is uppercase. This we want to call, and in here we need a font style and we need a size. The size is easy because we just want an integer, in my case 30. For the font, we need an actual file. In my case, here's the project folder and we have font, and in there we have a file called Lychee Soda. This is what I want to import. The file path for that is going to be a string, and I want to go one folder up to font and then to lycheesoda.ttf. And with that, I have a font. With all of that covered, basically what I want to do, I want to create an update method that one needs self and nothing else. And this is actually going to show the menu. Although we do have to do quite a bit of work to get this one done. For now, just to see if this is working, I want to show some blank surface. Which means I want self.displaySurface.blit. In here, I want to create a surface from scratch. And this one is going to have a dimension of, let's say, 1000 and 1000. The position here is going to be 0 and 0. The way we are going to call it, inside of level.py, I want to get rid of print shop active, and instead, first of all, at the top, I want from menu import menu. Inside of the init method, I want to create an object from the class. So self.menu is going to be menu. The two arguments we need here. From menu, we need player and toggle menu. Player is really easy because we have self.player. Toggle menu is also very easy because in here we have self. This one is called toggle shop though, but same thing. I can just paste it in here and we are good to go. Inside of the run method, I have to do some reorganizing. The first two lines can stay identical, and let me add a few more comments here to make all of this a bit clearer. The first two lines are, let's call it drawing logic. After that, we have the updates. In here, I want to check if self.shop active. If that is the case, I want self.menu.update. I think I called it, update. I want to call this method here. And only if that is not the case, so else, I want to do these two lines here. If the menu is active, the player cannot move anyway. So there's no point updating all of the sprites or any of the planned collisions. It's simply not necessary. As a matter of fact, I want to stop the entire game while the menu is open. This is going to include the rain as well, which means it's only supposed to rain if raining is true and not self.shop active. Only then do I want to update the rain. The overlay, however, can stay here. Let's put all of this under the weather section actually. And let me remove these comments. I think this makes the most sense. With that, we have the entire run logic. Let's try it. So in main.py, it still works, and now I want to run to the shop. And in here, I want to press enter, and the game is crashing. Because inside of menu, this one should be pygame.surface. And while I'm here, I also realized this should be inside of another tuple. Now let's try this again. And next to the merchant, I press enter. And now we have a big black rectangle. And the rest of the game also doesn't update, which is a very good sign. Which means this one is working. We just have to add more logic to it. The most important one for now is that we need an input method so that we can switch off the menu as well. This is actually going to be your exercise. I want you guys to get the input, and then if the player presses escape, close the menu. Pause the video now and try to figure this one out. It should be fairly doable. First of all, we have to get all of the keys. This we get with pygame.key.get_pressed. Once we have that, I want to check if keys and pygame.k_escape. If that is the case, I want to run self.toggle menu. Don't forget, we also have to call self.input. But other than that, this should be it. Back in main.py, let's run this again. And right next to the merchant, I press enter, and now if I press escape, the game continues. And this I can do multiple times. This is working really well. So with that, we can toggle the menu. With that, we can actually start creating the proper one. And for that, I first of all want to have a couple of options. The most important one for now is self.width. And this one I set to 400. This is going to be the entire window. And inside of it, roughly here, I want to have the menu. Inside of the menu, we're going to have individual entries, like so. What width is determining right now is the width of this entire menu. Besides that, I also want self.space. That is the space between the elements. This I set to 10, and then self.padding. And this I set to 8. Once we have that information, I want to create the actual menu entries. And for that, first of all, we are going to need all of the, I call this one the options. What this is going to be inside of the player. In the init method, we have the inventory. This is going to be what I want for the options for the menu. And I am going to combine all of those into one list. self.player.item_inventory. And I only really care about the keys here. Don't forget to call this. And this I want to turn into a list. This list I want to combine with the seeds. Let me copy it. And to combine the two lists, I need plus and copy this list. And I want to have the seed inventory. This one here. To make sure that this one is working, let me print what we get. Self.options. And now if I run this and close the game, here you can see we have all of the different options. Wood, apple, corn, and tomato are the inventory of the player, so the items, corn and tomato are the seeds. Although now we do have a problem. Let me run it again actually. Inside of this list, I need to know which of these items can be sold and which ones can be bought. The items should be only sellable. So these 4 items I want to be able to sell, and these 2 items here I can only buy. As a consequence, I need to figure out where I'm drawing this line here, where we end the selling menu and start the buying menu. For that, I created another attribute that I called sell border. This is basically self.player.item inventory. I am getting the length of it, and from this I'm subtracting -1. Later on, I'm going to cycle through this list. And for every item, I'm going to check the index and check if it is smaller or greater than this border. If it is smaller, we are selling. If it is greater, we are buying. And with that, I can create a self.setup method. Let's do it right below. This one doesn't need any arguments. The most important thing I have to do in here is to create the text surfaces. All of those are going to be stored in a list, and the list I called text surfaces. For now, it's just going to be an empty list. All of these items are going to be created with forItem in self.options. That is the list we have created up here. All I have to do is to create a text surface, and this I am getting with self.font.render. In here, we need a string, we need anti-alias, and we need a color. The color is the easiest bit. I just want to have black in here. Anti-alias should be false, and the string should just be the item. Once I have that text surface, I want to get my self.textSurfaces and append the individual text surface. I also just realized this one should be setup, not input. Now with that, we have a list of surfaces. This we can now use inside of the update method. In here, I can get rid of this big black rectangle, and instead, I want to do for text surfaces in self.textSurfs. Although, remember what I explained earlier. For this logic here to work, to separate between the buy and the sell menu, I need to know the index of every item inside of this for loop. As a consequence, I'm going to use the enumerate method here. And let's call this one text index. I suppose for now, all we have to do is self.displaySurface.blit. We have a text surface, and for the position, let's say we can go with 100 for X, and for Y, I want to have the text index multiplied by 50. Let's try all of this now. And once again, I have to walk to the trader. Here we are at the trader. If I run this, we can see the different entries. So this is looking really good. We can also end the menu, and this is working very well. Very good. We are making progress. Although now we do have a problem. Right now, the height is basically random. So we have to figure this out more deliberately. This is also going to happen inside of the setup method. Besides the text surfaces, I want to have self.total height. By default, this is going to be 0. Inside of the for loop, I want to get this total height and plus equal self.text surface and then get underscore height. Although, don't forget, I also want to add plus self.padding multiplied by 2. And this I want to put in brackets. That looks a bit cleaner. Each of those text entries, let's say we have 3 for now, inside of those, the text is only one part in the middle. And there should be some space or some padding between the top and the bottom of the text. This is what we're getting with self.padding. The entire height, though, is what we're getting from self.total height. This is what we're going to use in just a second to center the entire menu. Although there's one more thing that we do need, because if I open the drawing again, between each of the entries, so this space here, there should be some more space. That is the space we have set up earlier in here. To get that number, let's do it here. I want to get self.total height, and I want to add another number. I want to get the text surfaces, and I want to know how many items I have. So I want to have the length. Right now, that number would be 3 because we have 1, 2, and 3 elements. From that, I want to subtract 1 for the simple reason that we only have one space for any 2 elements. As a consequence, if we have 3 elements in total, we want to have 2 spaces between them. All of this I want to put inside of another bracket, and this I want to multiply with self.space. And now I have the total height. This I can use to calculate let's call it menu top. This is going to be the top part of the menu. For this number, I need in my settings the screen height. And this I want to divide by 2. From this number, I want to get my self.total height and divide this by 2 as well. This here is going to be the entire screen, and screen height divided by 2 would be roughly this point here. From that, I want to subtract self.total height divided by 2. That would be roughly, let's say, here, with this being the first half and the other half would be below. So 1/2 here. That way, the menu is always going to be in the middle. There's one more attribute I want, and this I called self.mainRect. This is going to be the bounding box for the entire menu, and this is going to be a rectangle. So Pygame.rect. In here, we need the left, the top, the width, and the height. Figuring those numbers out could actually be a really good exercise. So try to figure them out yourself and see how far you get. There are 3 numbers in here that should be fairly simple. The top is what we have just done. It's just self.menuTop. So I can place this one in here. The width is also very easy. That is the number we have created up here, which means I want to have self.width. Height is also easy. This is just going to be self.total height. The only minor complication is the left side. To get this one, we kind of need the same logic we have used here. I first of all want to get my screen width, and this I want to divide by 2. From that, I want to subtract self.width and subtract this by 2 as well. With that, we should be having a rectangle that is in the center of the window and also is as tall as all of the text elements. I guess let me minimize the setup method and try this one. I guess for now we can comment out this for loop here, and instead I want to pygame.draw.rect. I want to draw on self.display_surface. The color, let's go with red. And the rectangle is going to be self.mainRectangle. And just for testing purposes, it's going to be kind of annoying to always walk towards the merchant. So inside of the player, let me go to the input method. And then here, if the player is pressing enter, I want to toggle the shop already. Like this. Now, if I run the game, I am getting an error. This happens inside of menu, inside of setup, and this self.text surface shouldn't be a self, it's just a text surface. So we're getting this one here. Now let's try this again. We're now crashing, and now if I press enter, we're getting a menu in the middle of the window. I can also press escape, and the game continues as always. So this is working quite well. I suppose next up, we can start working on another important UI element, and that is display_money. There's no need for any arguments in here, and all we are going to do in here is, first of all, we need a money surface. Or rather, since we have local variables, this can be a text surface. All I want in here is self.font.render. In here, again, we need a string, we need anti-alias, and we need a color. The color, once again, is going to be black, and anti-alias is going to be false. It is false here because I have pixel fonts, which don't look good when you anti-alias them. Finally, for the string, what I want to access is inside of the player in the init method. I want to access this money attribute here. This I get with self.player.money. Although this I want to put inside of an f string, like this, because that way I can add a $sign before. Once I have that, I can create a text rectangle. This is just going to be the text surface.get_rect, and in here I want to place the mid bottom. For the position here, I want to have the screen width divided by 2, so we are right in the middle, and then I want to have the screen height and subtract 20 from here. That way we are slightly off-centered from the bottom of the window. Once we have those two bits, I can get myself .displaySurface and split the text surface and the text rectangle. And now all I have to do is to run self.displayMoney, and this should be working. So inside of main.py, I press enter, and we can see the money in the bottom center of the window. This is working very well. Although there's one more element I want to add, and that is a background for this text. This I get with pygame.draw.rect, and in here I want to draw on self.displaySurface. The color for this one should be white. The rectangle I want to use in here is the text rectangle, although I do want to inflate this one by a tiny bit. Let's say 10 and 10 pixels. If I run this now, this is already looking much better, although I do want to have some rounded borders. This I can also get very easily. I need to add two more arguments. The first one is the border width, which in my case is going to be 0. And then we have the border radius, which in my case is going to be 6. And this 6 here determines the border radius or how much rounding we get. If I run this now, we have some rounded borders, which makes the entire thing look much nicer. I guess you can play around with different numbers here. Let's try 4. Yeah, I guess this one looks a bit better. But again, this is pretty subjective, so choose whatever you think is best. With that, we have finished the money. This is all we need in this one. I guess next up, we can work on all of the actual entries. And we already have some good starting points here. We have access to all of the text surfaces, and we know their index. This I can use inside of another method. Let me call it showEntry. In here, we do need a couple of arguments. I want to have a text surface, so the text I want to show. Then I want to have the amount, like so. Then I need the actual position, and this is going to be top. With all of that, I can start working on this. And first of all, in here, I need a background. After that, we are going to create the text, and later on, we're also going to show an amount. But let's get started with the background. In here, I want to create a BG rectangle. This is just going to be a Pygame rect, and once again, we need a left, a top, a width, and a height. Left we can get fairly easily because we have self.main_rectangle.left. Since this main rectangle is in the center of the window, this makes it very easy for us to get positions. Top is going to be what we're getting from the parameters, this top here. The width is going to be self.width, the one we have created all the way up here. And finally, the height is going to be text surface.get_height. Don't forget to call it. And to this, I want to add self.padding multiplied by 2. Once I have that, all I want to do is pygame.draw.rect, and in here self.displaySurface. The color should be white. I want to draw the background rectangle, and I want to go with 0 and 4 for the border radius. With that, we already have a pretty good start. All we have to do now is inside of this for loop, we have to figure out how to actually call this showEntry. Let me add a bit of white space, and first of all in here, we need to get the top. And the top is going to be self.main_rectangle.top plus the text index. And this I want to multiply with a couple of things. Most importantly, the text surface, and I want to get the height of that. Although to that, I have to add self.padding multiplied by 2, and I have to add self.space. Think of this one here is the main rectangle, this one here. And by default, we are getting the top, this line here. And for every item, we want to get the distance downwards. That we get by multiplying the text index by the height of the text, the padding, and the space. For example, if the text index is 0, all of this is going to be 0. So the first item is going to be all the way at the top here. For item number 1, we would be somewhere here. Let's say this one could be 100 because the text height could be something like 70. The padding could be 2 times 10. And let's say for the space, we also have 10. And all of this we want to multiply by 1. As a consequence, the result here is going to be 100. And this 100 is going to be the top of this text entry. And this is what we can use in self.showEntry. Let me copy all of the parameters here. So top is what we have just calculated. Text surface is also what we are getting from here. For the amount, for now, let's just say 0. We're going to work on this in just a second. But for now, if I run main.py again and press enter, now we can see all of the background fields. And those are perfectly centered, which is looking very nice. Definitely progress. Although, let me get rid of this line here, so we're not drawing the text anymore, and also this drawing here, so we don't have the red background. Now if I run this again, this is looking much cleaner. Cool, so with that, we can start working on the text. For this one, I want to create a text rectangle. Once again, this is going to be pygame.rect. And again, we need a left, a top, a width, and a height. For this one, I want to get the text surface and get_rect. In here, once again, I want to place the mid left. I need an X and a Y position. Or rather, I need a left and a top position to be a bit more specific. For the left side, I want to have self.mainRect.left, and now I want to have an offset, let's say 20. For the top, I want to have the BG rectangle, and in here, I want to have the center Y position. Once I have that, I can run self.displaySurface.split and pass in the text surface and the text rectangle. Let's try this one now. And there we go. This is looking really good. Finally, we need the amount. For this one, first of all, I want to create an amount surface. This, once again, I get with self.font.render. In here, we need some text, we need anti-alias, and once again, the color. The color is always going to be black, anti-alias is always going to be false, and the text itself is going to be the amount. Although here, this we have to convert to a string. Because by default, amount is a number, and Pygame doesn't like that. It always wants a string for the render method. Now that we have that, we can create an amount rectangle. This we get with amount surface.get_rect. And for this one, I want to place the mid right. Again, we need a left and a top. And for the left side, what I want in here, if this is one text box, or rather one of the BG rectangle. Inside of there, we have the text rectangle, and the text is somewhere here-ish, with an offset from the left. For the amount surface, I want the exact opposite. I want to come from the right side and have something like this. Which means for the left side here, we want to have the right side of the main rectangle and then go to the left a bit. Which means I want to have self.mainRect.right and subtract, let's start with 20 pixels. Although for the top, all I want is the BG rectangle and then center Y again. And let me clean this up a tiny bit. There we go. All we have to do now is get self.displaySurface.split and pass in the amount surface and the amount rectangle. If I run this now, this is looking pretty good. Although we do have to figure out the actual numbers for the amount. That, however, isn't that difficult, or at the very least, it's certainly possible. First of all, inside of the for loop, I want to get, let's call it an amount list. And this amount list is going to be very similar compared to this options here. As a consequence, I can just copy it and paste it in here. Except now we don't look at the keys. Instead, we are looking at the values. This way, if I open the player, we are getting all of these values here inside of one list. And this list has the same order as this list here. As a consequence, we can get the amount simply by looking at the amount list and using the text index. And that is what I want to pass in here. If I now run this again, press enter, we are getting lots of zeros, but then we are getting 5 and 5. Those are the two seeds. And with that, we have the basics of the menu. Although we cannot select anything, and let's do this right now, I guess we can keep the entire merchant in one big section. For the selection, we need a few more things. Most importantly, let me add this section here and let's call it movement. The one thing we need in here is self.index. By default, 0 here is totally fine. And how I'm going to use this? When I'm creating show entry, let me minimize everything else, there's going to be one more parameter, and that is going to be selected. And if selected is true, so if selected, then I want to, for now, just draw a border around this particular box, which I'm getting with self.displaySurface for the drawing. The color here should be black. And I want to get the background rectangle. Although now I want to have a border width of 4 and 4 for the border radius. If you specify a border width, the content or the filling disappears for this rectangle. But let me show what actually happens. If I press enter now, we are getting an error because I forget to add the argument in here. I want to have either true or false. And what I am checking is if self.index is equal to the text index. Now if I run this and press enter, now by default, the first item is going to be selected. However, if I go to my menu and set this index to, let's say, a 3 and run this again, now we have tomatoes selected. And all I really have to do inside of the menu is to change this index to select a different item. And this I'm doing inside of input. All I want to do in here is if keys and pygame.k_up. If that is the case, I want to set self.index -1. Then I can copy all of this and change the up to down. And this one should be a +1. Now I can set index back to 0. And now let's try this actually. If I press enter now and press down, something weird is happening. The thing disappears, or well, it kind of works, but it moves way too fast. And this is a problem we have encountered earlier. Basically, inside of the init method, Pygame, for this one, for example, checks if the down key is being pressed. But Pygame checks this about 100 times per second. As a consequence, if we are pressing it down, Pygame registers this line, let's say 20 times. Even though for us, it seems like we are only pressing the key once. And as a consequence, we need a timer. This one we already have. I want from timer import timer. And the timer I want to create in here. So self.timer is going to be timer. For this one, we only need a duration. And for the duration for this one, I went with 200 milliseconds. Now inside of the input method, when I'm pressing either up or down, I want to activate this timer. So self.timer.activate. But all of this should only be possible if the timer is not active, meaning if not self.timer.active. Finally, there's one more thing that we need, and that is we have to update the timer, which I'm doing all the way to the top of the input method, self.timer.update. update. I hope you remember the timer actually. We created this one a couple of hours ago. Let me open it actually. So inside of the timer, this one here, we have all of this. And this is what I'm using inside of the menu right now. But with that, this should already be working. If I run this now, I can open the menu and I can move up and down. This is working really well. The problem right now is if I move too far up, the thing disappears, and also if I move too far down, it disappears. This we want to control for. Meaning I want to clamp the values. All this really means in practice is I want to have my self.index, and if this one is below 0, I want to set self.index to length of self.options -1. This means if we are going below 0, we are going to the end of the list. This is also going to work the other way around, that if self.index is greater than the length of the list -1, then I want to set self.index to 0. And now, let's run this again. And if I move down, this still works. If I move up, we are getting to the bottom of the list. And if I move downwards, we are going back to the top. So this is working perfectly fine. Okay, next up, when we are showing the entry, let me minimize everything once more. The next thing I want to do is that, let me run the game again, and we have wood, apple, corn, or tomato selected. I want to have a cell text roughly here for all of these. And if we have corn or tomato selected, there should be a by text here. And this is what I'm going to create now. First of all, for that, inside of the setup, we have to import, or well, create two more things. Those two things are going to be the by or cell text surface. In here, I want to have self.byText, and I want to have self.cellText. Both of those are going to be pygame.font.render. And again, we need 3 arguments. The first one is the text. Let's leave this one empty for now. After that, we want false for the anti-alias, and for the color, we want black. For the by text, this should just be by, and for the cell text, it should be cell. With that, we have 2 surfaces. We just have to figure out when to actually show them. That is going to happen inside of show entry. Specifically, I only want to show this when this specific entry is selected. How this is going to work, I am first going to check if self.index is greater than self.cellBorder. This is the border we created in the init method right here. This one is checking the length of the inventory. So if we are inside of the length of this border, we want to sell. If we are beyond it, we want to buy. Let me add comments here. This one is going to be buy. And if this one is not true, so else, then we want to sell. Actually, I think this one is a bit confusing. Let me do this the other way around. So if we are below this, we want to sell. And if we are beyond it, we want to buy. And all we have to do now is self.displaySurface.blit. And in the cell one, I want to display self. I called this one cell text. For the position, let's say for now, we are going to go with 0 and 0. And for the by text, this is going to be by text. And let's try this one, although it's going to look a bit funny. And we have an issue inside of the setup method. This shouldn't be Pygame, it should be self.font.render. If I now run this again, this is working. And now in the top left, you can see sell, 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 and now we have buy, buy, buy. Although for the tomato, something did go wrong. So we have to make some minor adjustments here. But other than that, this is working pretty good. I guess the problem here is inside of entry, this should be smaller or equal. If I now run this again, we get sell, 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 and buy, and buy. There we go. This is working just fine. Although the position of the buy and sell text we do have to work on. Although the position is looking a bit weird. Let's work on that one. And for this, I want to create another rectangle. Let's call it the position rectangle. In here, I want to have self.forCell. I want to have the cell text and get underscore rect. For this one, I have to place the mid left. And once again, I need a left and I need a top. The top is the really easy part because I get my background rectangle dot center Y. For the left, I want to have my self.main rectangle dot left. And to this one, I want to add 150 pixels. I can place the position rectangle in here, and this should be working. Let's try. And we are getting an error that this should be get rect with lowercase letters. And now we get cell in the perfect positions, although buy is still looking a bit weird. But that we can work on. All I have to do is duplicate this one here, paste it in there, and now we want to get the buy text surface. But the rest is going to remain the same. Meaning if I run this now, we get cell and buy because I didn't paste the position rectangle in here for the position. Now this should be working. Cell and buy. This is working perfectly fine. Cool, I am really happy with this. So let me minimize show entry and the setup. All we have to do now inside of input is to actually make the menu do something. For that, inside of this if statement here, I want to add another if statement. And now I want to check if keys and pygame.k_space. If that is the case, first of all, I want to activate the timer. So self.timer.activate. After that, I want to get the item. So I want to create another variable called current item. And for this one, I want to have my self.options and use self.index. I suppose let me print what we actually get with current item. And if I run main.py, if I now press space, we get wood, apple, corn, tomato, and tomato. This is working just fine. Now I have to figure out, do I want to sell or do I want to buy? That is information we can access quite easily because I once again want to check if self.index is smaller or equal than self.sell order. If that is the case, I do want to sell. If it is not the case, so else, I want to buy. If I am selling, it should be self.player.item.inventory, and I want to check the current item. If that is greater than 0, I want to do something. So this should all be an if statement. Let me copy the entire line here, because what I want to do, if this is the case, this should be reduced by 1. And on top of that, I want to get my self.player.money, and I want to increase that amount by a certain number. This number I'm getting from settings. In here I can minimize a ton of different things. In here we have sale price and purchase prices. For now, I only care about the sale price. This I want to access, and I want to use the current item as the index. This should be all we need. For now, for the else, I want to add a pass, and just to test this inside of the player, let's give the player a couple of items. Like this. And now if I run this again, I press enter, I have lots of different items I could be selling, and if I press space, the amount gets reduced and our money increases. And let me try to sell all of my wood. If I now get to 0, I cannot sell anymore. But I can still sell other things. So this is working perfectly fine. So with that, all we have to do is to check the buy part and we are basically done. In here, first of all, I need to get the seed price. This I'm getting again from settings. In there we have purchase prices. This I want to get, and in here, I want to get my current item as the index. Now I want to check if the player has enough money for it, which means if self.player.money is greater or equal than the seed rice, then I want to get self.player.seed_inventory, and I want to get the current item again. I want to plus equal 1, and then self.player.money is going to be minus equal the purchase price of the current item. There we go, and this should be it. Let's try. So I can still sell things, but now if I try to buy things, my money goes down, and let me hold space pressed, and at some point we should be reaching 0. There we go. Now we're at 0, and I cannot buy any more seeds. I can still sell things though, and now that I have money again, I can buy some tomato seeds. Until I am running out of money. And there we go. This is working fine. So with that, we have created the entire menu. And that finishes basically the main part of the game. All we have to do now is to add some sounds, and then we are done. For the final bit, we have to add the sound. Let's jump right in. This really shouldn't take too long. Here we are back in the code. And what I want to work with, let me open the folder. Here's the entire project, and I want to look at audio. In here, we have a couple of different files that I want to use. The main problem is we have to figure out when and where to use them. But that really shouldn't be too difficult. Let's start with the axe. For this one, I want to look at my sprites. So let's open this one again. In the sprites, I want to minimize everything because I only want to focus on the tree. Basically, inside of the tree, whenever we damage a tree, I want to play the axe sound. Let me add another comment here, play sound. Basically, all I want to do is self.axeSound.play, and that is basically it. For that, I have to import it. This happens in the init method. Let's call this one sounds. All I need in here is self.axeSound, and this is what I get from pygame.mixer.sound. Spelled like that. The file path we need here is one folder up, then audio, and in there we have a file called x.mp3. And with that, we should be ready. If I now run main.py and walk towards a tree and hit that one with an axe, that is sounding pretty good. So next up, we need the sound effect if the player gets a thing. This is going to happen inside of level, because in here I have the player add method. I basically want to play something like self.success.play. This success we have to import, and this happens, let's do it all the way at the bottom, music. This I call self.success. And this, once again, we get with pygame.mixer.sound. The file, once again, is one folder up, audio, and the file is called success.wav. Although for this one, by default, I think it's a bit loud. As a consequence, self.success.set_volume, and in here, 0.3, I think sounded good. And now, anytime the player gets any kind of item, we are playing that sound. So let's run main.py, and let's say I want to get an apple. That sounds not too bad. And if a tree disappears, this also plays. Cool, so this is working. It's also going to play when we are picking up a plant, but that takes a while to test, so I think we're good. For the next tool, I want to work on the hoe, and for that, I want to reopen my soil layer, or soil.py. And I want to minimize everything. In the soil layer, I want to add sounds. And in here, I want to create self.hoe sound. And this one I get with pygame.mixer.sound. The file path here is one folder up, audio, and in there I have ho.wav. This I want to make a little bit less loud though, so I want to set the volume to 0.4. And this now, if I minimize all of the methods, I want to play whenever the soil gets hit, so in here. Let's do it all the way to the top, self.hoSound.play. And with that, we should be having another sound. So if I now use this one, possibly a bit loud. I want to change the set volume to 0.1. And now let's try this. Definitely an improvement. It's gonna get better once we have background music, but I'm kinda happy with this. Next up, I want to work on the watering sound. This one is going to happen inside of the player. In here, all the way at the bottom here, I want to add a sound section, and this I called self.watering. This, once again, we get with pygame.mixer.sound. The file path here is one folder up, audio, and the file name is called water. This one is an MP3. And whenever we are using a tool, and the selected tool is water, I want to play self.watering. Although for this one, I also want to change the volume. So self.watering.set_volume is going to be 0.2. If I now run main.py again, select the watering can, that's working just fine. Cool. There's one more that I forgot, and that is inside of soil. Besides the hoe, we also have self.plant. And this one, let's call it plant sound actually, plant sound. Once again, pygame.mixer.sound, and in here, one folder up, audio, and this one is called plant, and the file ending is a .wav. Let me just duplicate it, self.plantsound.set_volume. Let's go with 0.2. This one I want to play whenever we are planting a seed. In here, so all the way at the top, I want self.plantsound.play. That way, this one will only be played if we are actually hitting the soil. If I run this, I first have to create a soil patch, and now if I plant some seed, not the greatest sound effect, but it certainly works. And alright, with that, we have all of the minor sound effects. The one last thing we have to do is to play the background music. And this could be a really good exercise for you. Figure out where you could play the background music and import it and play it. All of this is going to happen inside of level. I guess theoretically you could also play it in main.py, but level.py is a bit more flexible. In here, I want to import music, so self.music, and this we get with pygame.mixer.sound. The file name here is called, well, we have to go to audio first, and I want to import music, which in this case is an MP3 file. What we also have to do to play it is self.music.play, and in here, loops needs to be -1, so that we play this continuously. Now, for the background music, I have been a bit lazy, because you probably want to change the volume depending on the daytime, or play different kinds of music depending on what kind of weather you have. But, well, I just have one kind of background music. But this video is getting long enough, you can work on this yourself. But now, if I run this, now, before I finish the entire thing, there are some very minor things I do want to change. First of all, inside of the player, if I minimize everything again so we can see what's going on, inside of the input in here, I have to clean up this self.toggle shop. That's the one I forgot earlier. Here we go. And now this one is done. So let me close the entire player. Besides that, in the level, I want to set the rain to something greater than 7, because the rain really shouldn't happen that often. This I also have to update. Let me minimize all of the methods once more. In the reset method, this one should be like this. Finally, inside of the sprites, in here, once again, I want to minimize everything. And in the tree, I created an invol timer. And this one simply isn't necessary. I just mixed up my nodes. But now we are done with the entire thing. This was literally all we needed. And let's make sure this is all still running. All right, this is looking really good. So well done if you have gotten this far. This was a really long tutorial. So I hope you enjoyed it, and I'll see you around.